Hey, good morning. I don't know if you're able to hear me over there. I think I saw that I might be the first speaker for today, so I just wanted to confirm that if that's true.
Yes, Doctor Brad, everything is perfect. We can see you, and even if you want to share your check your screen, that presentation is available.
Oh yeah, let
You
me
can
check
see
that
the
out.
slide
Yeah,
option also.
thank you so much. Yeah, just to give a little background. This is the talk that I developed last year. Of course, this past 6 or 8 months, it's been hard to do new things, but I'd love to share with you some of the most recent work that I was doing, and the talk should be ready to go. Let me just check the connection there.
Yeah, just
Um,
check the share screen option.
yeah,
Rest is fine.
let's see.
Yes,
Okay.
it's
Um,
working perfect. Okay.
okay, great. All right, so I think we're about about at time, and so if it's all right with you, I can go ahead and jump in, and I've mapped it out to be about 30 minutes time. And just would you like me to leave a little bit for Q&A at the end, or shall I just kind of try to go for the 30 minutes? Do you have any preference there?
For Q&A, you can leave, but we start at your given time. We start after half an hour. Is this
Oh,
okay with you?
yeah, and we're coming up on 10:30 right now, so it should be time to go, right?
We are right now it's 10.
Oh, it's 10.
Yes. In India, the time is 10.
Oh, I'm sorry, because yeah, if I googled it, okay, I'm so sorry. Okay, so it's a half an hour from now. Oh, okay.
Yes, has
I,
half an hour from now. Actually, we're
oh,
sitting
okay.
in Prof Mohan lab in Singapore, so it's like a global time difference from one place to another.
Oh, okay. Got it. Okay, yeah, because mine says something a little different. So no worries. Cool. Well, well, if it looks like it's working and everything's visible, shall I like jump back in half an hour if everything's all right, or what's
Yes.
your?
So after half an hour, we will switch the screen of presentation with you. Yeah.
Oh, okay. All right. Well, no worries. I'll hop back in 20 minutes or so, just to be a little bit early, and we'll get started from there.
Yes.
Okay. All right. Thank you. Talk to you later. Bye.
You know.
Good morning, Mr. Satyan. Can we start the
Yeah. Please. Hello.
Very good morning. Should I start?
Yes, you can start. You can start.
Yeah. Dr. Das is there.
Yes, I'm here only.
Yeah. So you can make your welcome speech and
I'm here only. Should I start?
yes. I can see you. Yes. You are very much clear. Yeah. Please go ahead, Dr. Das.
Okay. Very good morning. May I express my warm welcome to all the participants to the second day of the three-day international webinar on enabling technologies and emerging robotics use case studies organized by PRIST University of India in collaboration with Singapore University of Technology and Design. May I take this opportunity to share statistics of this mega webinar with 944 participants as on 7 a.m. IST today, still increasing, including 723 students, 154 faculty members, 45 researchers, in addition to industry representatives representing from Tata Steel, TCS, and so forth. The range of the audience are from wide levels, are from wide ranges, starting from higher secondary students close to doctorates. The participants are also not only from wide geographic regions of India, from 12, from 20 states, but also from 12 other countries as well, namely Singapore, USA, Canada, Mexico, Korea, Indonesia, Philippines, Saudi Arabia, Egypt, Mexico, Ethiopia, and Sri Lanka. Even the area specialization also varies from core development areas of robotics, artificial intelligence, machine learning, cryptography, image processing, data mining, IoT, to wide range of application areas like agriculture, life science, pharmacy, physics, project management, and even education, English, literature, and law. And the comments, as per the first day feedback, are overwhelmingly recharging to all the organizers, which is far beyond all our expectations. Hence, on behalf of all the organizers, I express a heartfelt gratitude and thanks to all the participants for making for their support and enthusiasm in participating in this galloping survey of intellectual quest and making this event real successful. During yesterday's seminar, there was power-packed exploration of various nuances in robotics architectures and features covering reconfigurability, neuromorphic computing, chargeability, control techniques, mobility, and so forth, and the myriads of applications ranging from teaching aids, surgery, uh, health and healthcare to structural maritime applications. Today, in portions of this legacy, we are going to dive into further domains of the applications like exoskeleton support, wheelchair, drain mapping and sewage systems, pet robots, bio-inspired robots, and even low altitude remote sensing imaging applications. We will hear from the experts with their exceptional journey from ideations to innovation to development and even on to the commercializations. Now, I would like to introduce our Vice Chancellor, Sir, of PRIST University, Dr. N. Nirajulu, who holds his master's degree and master's of science in philosophy from University of Madras and doctorate degree from Harvard University, Trichy. He has been serving in the field of higher education for nearly 4 decades as a distinguished professor, active researcher, and naval administrator. He has handled several research projects funded by UGC. His research contributions have appeared in several peer-reviewed Indian and international journals and conference proceedings. His field of specializations are Fauci sets, rough sets, stochastic process, and graph theory. He has organized several national level conferences on emerging fields in mathematics sponsored by University Grants Commission, Tamil Nadu State Council of Science and Technology. And he has held various academic positions in Bharat University, University of Madras, and Mozambique University. So may I request our Honorable Vice Chancellor sir to deliver his address. Thank you.
Thank you, sir. Most revered Honorable Chancellor, sir. Robotics scientists, distinguished organizers of this webinar, participants, ladies and gentlemen, a very good morning to all. And the institution PRIST is a deemed university accredited by National Assessment and Accreditation Council. At present, the institution is having 7 campuses spread over Tamil Nadu and Union Territory of Pondicherry. The student strength of around 20,000 and a faculty strength of around 1,000. The institution is having 8 schools comprising of 12 departments in engineering technology, arts, science, commerce, business management, education, architecture, law, and pharmacy. The significant uniqueness of our university is the efficient functioning of Center for Research and Development and the implementation of research integrated curriculum right from the undergraduate level. During the last 5 years, the Center for Research and Development has posted more than 2,000 publications and registered 50 patents. The institution also established the Robotics Skill Development Center, where 100 students are trained every year in the field of robotics. In the early part of 20th century, science has given birth to a new technology called robotics. Nowadays, universities are implementing robotic process automation for a wide range of internal processes, allowing them to develop more modern, sophisticated administrative operations. The disruptive and costly process of implementing a new course system. Also, some of the universities are using RPA for functions such as course scheduling, which include the user experience of students and creates time-saving efficiency in the office of the registrar. According to Dr. Suzanne Wheeler, General Secretary of International Federation of Robotics, smart robotics and automation are vital to deal with new customer and new consumer trends. In this context, it is highly pertinent to mention that robotics is a new technology which is very much useful for enhancing the quality of life in all spheres. Education should always help to prepare the general population to fit into the society. Since society changes with the technology, it is important that education keep pace with new technology and adapt curriculum to educate the population to be familiar with each new development in technology. Since most people now start dealing with robots in one form or another during their lifetime, one of the prime responsibility of higher educational institutions may be to take initiatives for helping everyone to understand about robots. Moreover, problem solving is one of the complex areas in education, which is both extremely valuable to learn about, but at the same time very difficult to know how to teach. Critical thinking and problem solving skills are essential to attain success at university and later on in life. In fact, the traditional classroom model has done only to a limited extent in imparting these skills to the students. However, new ideas suggest that robotics may hold the key to teach problem solving skills to the students most effectively. Using robots to teach real valued skills may be a strange concept, but it is highly worth for further exploring. The inclusion of robotics in higher education curriculum requires students to understand fundamental problems and how to overcome them. This is done through brainstorming in a group setting or trial and error for individuals. In real world applications, problems are often solved through a combination of approaches. No single formula will be universally helpful for solving problems. For that reason only, it is imperative for students to master the skill of problem solving to succeed in higher education and later on in their career paths. By incorporating robotics into the curriculum, we may encourage students to think creatively and come up with new solutions. The contents of robotic course will have so many different things with analytical mathematical side existing alongside the physicalized manifestation of the outcome of the work. This sort of training helps the students to acquire strong problem solving skills. As on date, robotics is underrepresented in higher education. It is considered niche and expert, but actually it offers a whole host of educationally important learning tools that can really help students to develop critical thinking and problem solving skills, which are very essential for them. Taking all these facts into consideration, our institution is planning to introduce a course on robotics in the curriculum at various levels as generic elective course, discipline specific elective course, and audit course. In MSc Mathematics curriculum, we are thinking of introducing a course on mathematical modeling of robots as an elective course. Now, of course, with the support of with the support and guidance of eminent robotics scientists like you, we can be able to achieve all these things. With these few words, I would like to appreciate and acknowledge the efforts taken by the organizers for coming out with a colorful and splendid webinar. And I wish this webinar to be a grand success. Thank you all. Thanks.
Thank you, Vice Chancellor, sir, Dr. Ithirajaguru. Thank you so much for your wise words for this webinar and the overall concepts behind promoting the robotics in this part of world.
Thank you, sir.
We have our next speaker ready with us, but still we have some time. Uh, so I would like to ask Dr. Ashutosh Das to speak a few words related to the PRIST University and its ongoing efforts. Dr.
These people from different places, they may not be aware of this institute. So our institute is located in a agrarian city of Tanjavur in the Delta region, and mostly surrounded by there are no industries nearby. And it is known to be a temple city of Tamil Nadu with a big temple, Brihadishwara temple, which is one of the biggest Shiva temple in the whole world. So here we are located, having Center for Research Development as an integral part of PRIST University. When we got university in 2008, at that time it was established, and we have got still since that time we have been getting this recognition from DSIR as the CIRO, Scientific Research Institute Organization, and here we have got around 15 projects from Government of India on, actually 17 projects, and we have got more than 50 patents. And we have got more around 2,000 publications. So it's a small, humble beginning. And so we would like to, I would like to take the opportunity to request all the participants who are taking so much efforts to come and participate in the events to extend their interaction with us. We'll be very happy, we'll be enriched by their knowledge, and we are ready to offer any type of assistance from our side we can contribute. And one thing in relation to this present webinar, because India is mostly agricultural country, and our chancellors has deep desire to utilize this robotics in the field of agriculture, and there is no better place probably to explore that except this part of the country, which is known to be the rice bowl of India. So we have got a lot of cultivations there, and many people are wholly dependent on agriculture. So any of these are participants or the experts, if they would like to offer some type of collaboration with us, and we have also agriculture school located in our campus, so that we can take up some projects where you can develop some practical application which you can experiment here and explore and provide to other places, other countries. So this is also one of the desire of a chancellor, and an institute is also highly we are ready for that, or any type of assistance from our side, we are very much happy to provide that. So this is an appeal from our side. In addition to that, related to this webinar, any of the topics of interest to any of these participants who would like to have more interactions with the speakers, have more collaboration with them. So we also encourage them to contact our organizers. We will try to facilitate any type of interactions possible. So these are some of the areas I would like to extend our assistance, our collaborations, and if anything from any of the participants who are already present there would like to offer any type of suggestion in relation to this type of interactions and collaboration with respect to publication of patent and joint projects, or development of robots, and we will be very happy to start the beginnings in the directions.
Okay, thank you so much, Dr. Das, for giving brief introduction about the PRIST University. Still we have time, but as Prof. Brad Adam requested for, he has to, he can start.
Can I say a few more things about institute setup?
If you have any video, then you can share, or else I put the next speaker. You have video related to.
Right now, we are not ready video. It's there, but
Okay. So, if you want to share a few words,
yeah, just two lines. One thing about institute, we have got Campuses is headquarters is at Tanjavur, but we have campuses at Chennai, we have got Kumbakonam, we have got Madurai, and we have got in Trichy, and also Pondicherry. So we have got branches from starting from engineering, technology, science, management, architecture, agriculture, law, even medical science. So we have got a setup with a um, giving proper scope for in relation to what I discussed now, proper scope for anybody who would like to explore something in medical applications, because we have got a strong life science group is available. And similarly, we want to do something on legal side available, law available, architectural side available, we have civil engineering, we have environmental engineering, we have literatures. So any other particular field where anyone would like to interact with us and like to actually see the check the validity of these products, will definitely be very happy to extend that type of supports. Thank you.
But if it's okay, or if it helps, would you like to continue with some of the projects, or should I jump in ahead?
Hi, good morning, everyone. Okay, so yesterday we had a wonderful around 16 distinguished speakers. Have done a very nice presentation on robotics field, different fields, and we had a very good feedback from the audience. So today also we have plans to do another around 16 speakers across the world. So today the first speaker is Professor Brad Adam Campbell. He's from Oregon State University, USA. His presentation will be today on systems design innovation. Regarding Professor Adam, he's actually received his PhD from the University of Texas in 2015, and his bachelor's degree from Carnegie Mellon University in 2008. Both are in mechanical engineering. He then joined former Citibank executive Adam as chief engineer, then later head of R&D at Gilmore Space Technology. He led the research and development team at Gilmore to produce the world's largest hydrogen peroxide oxidized hybrid rocket engine at 70 kilonewton of thrust. This engine is believed to have set record for the shortest orbital class engine development program duration and lowest cost threshold. Dr. Campbell completed the engine qualification at Gilmore through Series B venture capital funding to receive in total 13.7 million. Before joining MIME at Oregon State, he also worked as a research scientist at the Singapore University of Technology and Design, as Massachusetts Institute Technology International Design Center (IDC). So, welcome, Professor Adam. Now the mic is for you. Thank you.
Okay. Well, thank you so much for that introduction. I'll give the camera a few minutes to adjust to the connection, and then I'll start to share my presentation. So it's an honor to be here today, and as much as possible, I really want to offer my thanks for taking the time to come and listen to me, and absolutely, if there's anything we can do out of Oregon State here, hey, let's look for collaborations. We have a strong agriculture research program here too, and while that's not per se my focal area, many of my colleagues are doing wonderful work in that, exploring how do we keep our world green and happy. And so all right. Well, so let me dive into it. Today's talk is systems design innovation, or design systems innovation, and what I really like to share is kind of my personal journey in systems development, because my own research I started in exploring the idea of prototyping. When you want to develop you have an idea that maybe you can solve a product or a system. How do you go about making that possible? And there are actually strategies and techniques that you can do to lower the cost and to enable innovation, especially in early stage development. And I think that's so important when you're looking at, potentially also starting things, from the ground up and developing new systems. And so I'll start a little bit talking about my journey and some of the projects that I had the opportunity to be connected with at the Singapore University of Technology and Design, as well as using Gilmore Space Technologies as a case study. How do we systematically enable innovation? How do we enable that early stage to create something new? And so I really look forward to sharing this with you. So let me go ahead and jump in, talk a little bit about my history and projects at SUTD. So I guess I started at Carnegie Mellon University and University of Texas at Austin. And thank you for the kind introduction, sir. And then Gilmore Space Technologies, and then MIT, SUTD had a collaboration for about 10 years, and many wonderful projects were birthed from that collaboration. You can see a rendering of the SUTD campus, and this is what it looks like in real life, and it's a very beautiful place out there in Singapore. Although I'm now at Oregon, which is also a wonderful and beautiful place. So this talk is really kind of reflects the projects that I worked on at that time there, but of course beforehand at Texas and are very much a part of that research. So when we talk about design, many of us, many people who long to invent. When I was a kid, I didn't even know what the word design meant. I only really even learned about that in graduate school. I came from an agrarian place myself, and one of the things that I learned when studying design is that it's not your first idea that's going to be your best, and you need to facilitate a number of things in order to enable innovation. And the first of those is really what we call, and this is a model. It's one model of which there are many of the design process. And design begins with a user. I studied design in an architecture school for some time, and we talked about what separates design from art. Is design just making it beautiful? Is it just making the form wonderful to look at? And what one of my architect friends said to me is that the difference between design and art is that design is created to solve a user's problem. And I would say the difference between design and engineering is that when you go into design, you don't really know what the solution is going to be. Often when you go into engineering, we tend to think that we probably have an idea of how to build it, but it's more a matter of doing the math to make sure it's going to be strong enough or light enough. And so what design begins with is a process of discovery. And you see on the left here, we talk about discovery. So in the beginning of a process, we seek to understand what are users' needs. How is an artifact that we're going to create or a process that we're going to create going to help users? And so we start by going out for interviews to talk to users, to understand and to gain empathy, to understand their feelings and their pain points and their problems. So when you're creating a design for your friend or family or clients, you understand that you need to know how is that solution going to solve a problem, or maybe it's a system or a network you're a part of. Either way, what are the problems that the design is going to solve? Secondly, we take those pain points and we rephrase them as what we could call opportunity statements or design requirements or needs. And a pain point might be, okay, my shoes are too heavy, and the need would be to make a lighter shoe. It's a very simple translation of an idea, but it's so important because once we've identified an opportunity, now I can do something called ideation, which we call development or ideation. Ideation is about creating not just one idea, but maybe 100 different ideas as to how I might make that lighter shoe. So the idea of develop is we're not going to come in and create just one idea. We're going to create many, hundreds, tens, and then rather than picking one and just having, say, one person pick one and say, hey, that's the best, we'll go through a process. And what we'll actually do is create low fidelity prototypes, mock up, something on a paper, cardboard, whatever. And we'll take that out to the users and we'll say, well, what do you think about it? What did this work out for you? You get that feedback and you ultimately loop back and iterate, because what will happen is when you take that very rough, rapid first prototype out to the user, it's going to come back and maybe not work. And because this is a conference about robotics, an idea that I want to get out there is, when you're developing a robot, don't wait to test it until you have the finished robot. Get the idea out there and then go work with your users and see how you might want to change it so that when you do really develop that high quality one, it's gonna work well. So let me introduce a couple of key terms that I might refer to throughout the presentation. So design innovation, it's kind of a synthesis of design thinking and systems thinking or innovation, invention. It's about being centered to the user, but it's also about using specific methods. Methods are processes that help us achieve a specific goal. So we have methods for how to generate lots of ideas. We have methods for down selection. How do I choose, which combination of perhaps different subfunctions is going to work? And you can, please feel free to go explore some of the websites out of the IDC or some of our previous publications that explain some of these more specific methods to guide you through design. People are absolutely at the core of design. There's a philosophical movement that came around in the kind of the last century about kind of shifting away from design only as something top down to something that's really about the people who are designers. The idea of the user as a designer. If you need a product, create products for yourselves, for your local nation, for your local economy. Create things that add societal value around you. And that's the idea of shifting focus of design as this totally just top down thing is focus on people. And so methods are short, well-defined activities with a set of actions and outcomes. Processes is the overall engineering or the overall development process that guides our transition from one method to another. And then lastly, we use this word principles. Principles are phrased in a way to be ambiguous, but they're meant to guide and provide insights. For instance, embrace ambiguity. What do I mean by that? Well, it means that sometimes you're going to develop a solution and you may not know exactly what it's going to look like, but you want to be comfortable with that. You need to know that maybe as in the early stages of developing a design, I don't know exactly how it's going to look or how it's going to function, so I need to have that flexibility in order to refine it. Okay, so that's a little bit of the context of design. Now, a little bit of a context of my research area, which is in prototyping, is a fun diagram. So this diagram is taken by scraping, 200 articles just on prototyping. And then I created a network of key terms in there. And so that network kind of gives you some insight into what terms are important in prototyping. So it's the physical prototype, the virtual, the CAD model, simulations. It's also the process. How am I going to develop that prototype? Who am I going to use it with? You want to be rapid, you want to be fast, you get the prototype out quickly. You might want to look at what technologies and techniques are relevant. It's not always going to be the same technology that's most useful to prototype different ideas. So you want to kind of look at how some of these ideas might fit together. So what I'd like to do next is to give a little bit of a context of what sort of projects I've been working on in the past and how, when I talk about design innovation, systems design innovation, how do we be innovative in new systems? That's what I'm going to talk about today. So here's an example of a collaboration. This is a really interesting one between a French organization, a Chinese organization in Tsinghua, and then also SCT and MIT in Singapore. We came together and had a big conference. This is back in 2013, so this is kind of a while ago. But anyway, at the time, what we were looking at is creating cheaper microscopes. And so, rather than and on the right, you see the end product, which is an atomic force microscope capable of detecting very small objects. But when I started with, and I designed a program there for the engineers, and when we started, there was maybe like 30 scientists, and a lot of them wanted to just dive straight in. They wanted to come on, let's get to the engineering. But actually, we started with clay and paper and these simple artifacts that let us express our ideas, and they let us do it in very rapid fashion. So what these students were doing right here is using some paper and clay and paper clips to actually prototype some different structural mechanisms that could potentially be used to build that microscope that we were going to develop for high schools there. And by going through this process and really reinventing how the thing was made, we were able to drop the cost by from something like $100,000 for the cheapest machine to less than $100. This is an example of an innovation process I was working on with a company in Singapore where they were looking at creating recyclable packaging, right? So when you send out a product, and ship it between companies, most of the packaging, you just throw it away, right? So you pack a product in there and then you just throw it away when you're done. And so what we actually did is create this modular. So there's something like 10 to the 26 different configurations. So that's a 10 followed by 26 zeros, possible combinations for this packaging array, but all just using one product, one little modular divider that I invented here. But so the idea is that, by going through this process and generating, I don't have an exact count, but I must have gone through something like 200 or 300 prototypes in order to get a functional product here that's injection molded and it's getting mass produced. And so, it's really important to be able to prototype effectively in order to get to solutions like this, where we're going to affect the industry, we're going to affect logistics, we're going to make shipping more efficient. This is another project I did with Singapore schools. They were trying to improve the system by which schools are evaluated to make it a little more user friendly so that the teachers didn't have to go through so much paperwork to evaluate their schools. And in the end, on the left, you can see kind of one of the early high fidelity prototypes of the website. And on the right here, what you see is one of the teachers, and she's helping brainstorm what the website might look like. So actually, that first prototype of the website was just paper and ink, very simple materials, but they gave us this idea of the vision, what the thing might look like moving on. Here's another product. This is a carbon fiber 3D printer that I developed at SCTD. And so, I don't have the early stage prototype here, but what I wanted to show with this one is that in the end, we were able to get this really awesome carbon fiber embedding printing process. But I don't show the low fidelity one here, but the first prototype of this, actually, I guess you can see it. Yeah, so you see this print head. So this is called an isolated subsystem prototype. So I tested this really kind of high fidelity functional extruder head that has, two different features, a rotary extrusion feature and the traditional XYZ frame. But that's just a prototype that I had one student spend, maybe a couple of months. It did take a while, longer than I hoped, but it only took her a couple of months to make this thing and to prove that it could work. And then in the end, we ended up with this beautiful machine that's being used to produce aerospace components over at SUTD. You can print parts up to 1 meter to each side, so it's this fantastic printer. But it was enabled by that early low fidelity prototype. This is a project that was really cool, near and dear to my heart. I spent some time in Papua New Guinea, where women's sanitary pads are not incredibly accessible. People were generally using old T-shirts, and so that there can be a lot of cause of infection as a follow-on from that. And so what we did is we just interviewed tons of local users. We looked into what materials are locally available, and then we did a series of prototyping workshops to come up with different templates for a reusable sanitary pad. And then because there was a champion, there was a person, Christina Kambungan, who wanted to kind of lead this company. She developed a social organization where she trains young people how to make these pads, and then they can sell them themselves. But that was completely enabled. That project was enabled by the fact that we went through user interviews, we went through prototyping, but there was also an entrepreneurial lead too. And so it's so important when you're developing something to understand that someone kind of has to take on their role of entrepreneurship. Again, I don't have the early stage prototypes here, but similar stories. This is a space camp that I helped to design and develop in Australia. You might recognize the face, looks familiar. That was a climbing wall I developed. We use water ballast on the back to make you feel like you're in zero gravity, so you can climb up the truss and you feel like you're kind of floating through space there. But this prototype on the right, the first one that I made, when you have a business card, sometimes you have it on that little elastic kind of coil that you can pull it out. Well, the first prototype of this climbing wall, I made it with a couple of magnets and just a string, because that's all I needed to prove that the physics was possible. And once I knew the physics was possible, I could explain that design to the engineers and they were able to build it. This was a project, I think I'll skip through most of it, but we were looking at, again, changing climates, changing environment. How do we, create a safer environment, particularly with regards to concerns on skin cancer? How do we make it safer to, go outside when the sun, the ozone is depleting in certain areas? How do we make it safer to go outside? And so what we actually developed is clothing, and I'm going to jump ahead and show. clothing, as well as architectural tiles, as well as in the end, what we developed is just a little tag, and that tag will actually change color according to the level of UV intensity, so that you can actually, walk out into the sun, and your shirt will change color and protect you from the UV rays. So it's actually like a dynamic protective fabric to help you when you go outside to be protected from the intensity of the sun. Again, I think we produced, I don't know how many thousands of prototypes, but a lot, many, many, many different prototypes. And we tried a bunch of different stuff. You can see we tried this, this little giveaway artifact. We tried clothes, we tried tiles. And in the end, it kind of came up with just a small little kind of tile that you can wear around. But, again, I just want to kind of promote this idea that you have to have really diverse ideas. You have to try lots of different things before you're going to get to something that works. And we created a version of this shirt that we gave to the prime minister, and he seemed to like it. And so this is actually the patentable part right there. This is the one. So it's the scale along with the shirt that shows you the intensity of the UV rays. But so again, this is the kind of project that we work on. Sort of an example of some of the things we do. And the last but not least is one of my most proud moments, and one of the programs at SUTD focused on student innovation. And this is one of my students in the middle. That's Peishan. And I love Peishan because she was just an individual student on a capstone project. Usually there's 6, 8, 10 students that come in on these capstones, and usually they have funding. But Peishan, she didn't have any funding. She worked for a volunteer organization, a kind of spiritual organization. She didn't have any teammates. She had no money, no teammates, but she had this idea that she could recycle rejected foods and use them to a benefit. And so her company is now, fully self-funded. So she's got a very successful company doing basically food recycling. And I'm really proud of Peishan because, she came into my office, when I was assigned as her mentor. And she's like, I'm just one person. I don't know if I should do this project. Kind of feel like I should give up. And I told her, Peishan, that means you have to do it. That means it's important. So, she created a business model. She did user interviews. She went out to farms. She talked to the farmers. She looked at the problems that they were having. And, she identified where the waste food was happening, which markets were kind of most guilty, so to speak, of throwing away a lot of waste food. And she kind of identified those as her pickup points. She established a relationship to collect unused fruit from those farmers, and she started recycling it. And she now has a very successful business called Ugly Food. And what they do is they take food that was rejected, and they actually, what is not pretty enough to be bought by the consumers because it may have some minor aesthetic imperfections. Maybe there's a little bit of dirt on it, or maybe there's a bump on one side, but it's still fantastic for making juice. And so that's her company, is they make juice, and some of the fruit they actually sell because it's just surplus. But it was just her idea, and she stuck it out, and it had great success. So let me talk a little bit. So these are kind of some examples of innovation, some of the impacts that innovation can have, at least in the projects that I've worked on. But what I want to talk about is how do we systematically enable that kind of innovation? How can you go out and achieve some of these results? Now, I want to start by talking about some historical examples to put innovation into context. So I'm going to talk about paper. I'm going to talk about the personal computer, and I'm going to talk about neural networks, or AI, as you may know it.
There is Professor Artisan. Yeah.
So all of these innovations have something in common. If you look at a standard systems engineering process, what happens is you start by setting program requirements, kind of what is the thing supposed to do, how's it supposed to work. Then you go in, you do your trade study, you do your refinement, then you configure your system. It gets accepted, you kind of put it out there for the user. But the problem is, if you're, and this is certainly true, you mentioned you had some civil engineering groups there, and kind of this might often be the case in something like a civil engineering context. You don't really start looking at any of the engineering until your system's already mostly finished. You kind of already have the amount of funding allocated, you have a general idea of where you're going to build the bridge, you have a general idea of how much money you're going to spend on it. Then maybe you hire a subcontractor and they might start to do some prototyping of the materials. But in general, you don't start building until way down the pipeline in a project. And so how do we change that? How do we kind of reverse things and create real innovation? It's by moving prototypes earlier. And I'm going to talk about why. So what happens is, and this is a paper from one of my good friends and James Tan, and also professors Kevin Otto and Dr. Wood. And so what James was looking at is, where do big systems go wrong? And if you look at some of these huge kind of multi-billion dollar systems from the US government, what you can see, and in this chart, what it's showing you, the height of this bar chart tells you how much the mistake cost, right? And the blue side shows, how much the mistake cost is very high if that mistake happened, what we call before design freeze. And that means if you say made a bad decision and you're going to put power lines and data lines right next to each other as a designer, that's going to be a way more expensive mistake than if, say, your engine, your fabrication engineer puts the power and data lines next to each other at the assembly. And why is that? Because the assembly engineer is going to go back to the designer, and if the design's wrong, it's going to take a long time to catch that. And so it's so important to make sure that our systems, have a good mission, that they, that there's a good concept behind it, and that the concept, the notion of the design or your robot, the notion of your robot is designed well, or otherwise, when you kind of come back at the end of it, it may not really work. So how do we prevent getting our systems wrong, right? How do we make them right? And so what you'll see is that, when there's, we looked at these different projects, right? And all this is showing is a study of students. And the idea was, when does a change get made? So, and what they found is that, what percentage of activities lead to an what activities lead to an improvement in the design? And so what they found is overwhelmingly, it was prototyping or testing that led to feature changes and improvements in the design. So when you can prototype something, you can improve the design. But as I just showed you earlier, often prototyping happens too late. How do we fix that? We need to prototype earlier. So you need to come up with ways to build and test your idea early on. And that's how you get it right. So let me talk a little bit about some of the methods that can be used, because obviously now you might be saying, well, Dr. Cameron, I don't buy it. How am I going to go prototype my new, tilling robot if, until I build it? Talking nonsense. How do you test something before you build it? Well, there's many ways to do that. And we call that, and I call that strategic or systematic prototyping. And so, what this chart is just an illustration of a space. And there's lots of different ways you can prototype. We can have many different ideas. So we call those parallel concepts. So you see each row, you can imagine I produce lots of different ideas. Let's say I want to have a tilling machine. Maybe I do one that's based on a motorbike. Maybe I do one that's based on a more efficient ergonomic integration with with an ox. Maybe I do one that's based on using a low-cost tractor, but somehow increasing the yield, right? So those could be three different systems I might choose. Once I choose one of those systems, I might do an initial idea, and then I might iterate it, which means to build it, test it, and refine it. We call that iteration. You kind of build something, see if it works, and refine it. Now, every time you build something, you have these different choices. You can do just a piece of it, just one component, see how that works before you put the whole thing together. You can make it virtual. You might make a CAD model. You might reduce the scale. If we're going to make something the size of a house, we're going to make a house. Maybe we should do it on a scale of 5 or 10 centimeters first to see how it looks. And then lastly, the requirements can be the relaxed requirements, sort of an approximation. Sometimes we call this abstraction, which means I test the idea more than I test the function. And so these are some different choices I can make on how to prototype. And I'm going to go a little bit more into detail about this map and talk about what some of these prototyping strategies are. So the first is that these two first ideas I talked about, iteration and parallel concept testing. These can be used to improve the quality of a design or enhance the user experience. So let's talk about those a little more. So earlier I talked about this Ministry of Education project. And so what I wanted to show you is that in this project, we iterated the idea many times. Over a 15-week period, we went through 10, 20, 30 different variations of the design, improving it each time. So we started with a mock-up given by the user, rough prototype. We went through 10, 20 different variations. We started with the first low fidelity version. The user didn't really like it. we improved it, and carried on. And what the data shows in controlled studies is that when you iterate, that design just gradually improves over time. And so you want to keep iterating and keep getting to that improvement. Now, what the data also shows is not only will the improvement will the design gradually get better, actually the cost of each iteration will go down. And so that means it's going to, for you to iterate, it's actually going to be lower cost as you go on. And so that's just a wonderful phenomenon of testing. Now, this is something I was doing with DISTA. It's an organization. Well, I shouldn't say, but a Singaporean organization, parallel prototypes. And so what we're looking at is different layouts in a service delivery system. And what we found is that, this gives us a wonderful capability to compare. And so parallel prototyping allows you to compare different options and see which of those is potentially going to be better. Because if I pick one idea, and I think the chart that I want is not, oh, here it is. Yeah, this is the chart I really want to show. I apologize, the other one's not relevant. But so let's say I have 5 different ideas about how to solve a problem. In this case, these illustrations are some examples of a student-led problem, controlled experiment, right? But what we wanted to do is to say, if I have 5 teams and they each start with one of these ideas, do you think they're all going to end up just as well off? And the reality is what you find out is that if you pick a bad idea to start, like let's say you chose concept B and it didn't get very far. I'm trying to build a thing that moves the concept far, right? Moves the design far. Let's say I chose B. It turns out maybe it's not going to get that artifact very far, right? But if I chose C or D, even from the beginning, that first iteration is going to do better. And so why you sometimes want to do parallel prototypes is so you don't get stuck in a trough, stuck in a hole with a design that's no good. And you want to avoid that before you go into iteration, because you might iterate many, many times on a bad design. It's not really going to help you out. So that's why you want to do parallel prototyping. Now, those both lead to improved performance. Now, what about things that might reduce the cost to make it more feasible to prototype? So these are scaling, isolation, requirement relaxation, or what we call abstraction, and virtual prototyping. So scaling is the idea that I'm going to take a really large system and I'm going to make it small. I'm going to, make it really, really tiny so that it's very cheap. It's very efficient and easy to build it. Here's an example. We did this beautiful pavilion for the 50th anniversary of Singapore as an independent state. And, we scaled that design down and went through hundreds of different prototypes before we built it. This was a design working on an electric vehicle. So this is subsystem isolation. So what happens say you're designing a vehicle? In a car, a lot of the other components are going to depend on the engine. So we wanted to prototype this electric vehicle, but before we did that, we focused on the wheel hub engine here so that we could make sure that we knew how that engine worked before we integrated it with the whole vehicle. Because then that way the rest of the components which rely on the performance of the engine are gonna, we know what they need to be. And then this example I call abstraction. I talked earlier about how you can iterate through different variations, but if you look at the version above, right, you might have been wondering, hey, Brad, that doesn't really look like a website. Well, we call it an abstraction. So an abstraction is when you make a more kind of simplified graphical or a mock-up or a paper prototype. Doesn't have any function, but it shows what the idea is. So we call that an abstraction. And what the research shows is that if you apply multiple techniques together, if I isolate a key function and I scale the size of that function, I'll actually get kind of multifactorial reduction in costs. And so if you're in a cost-constrained environment, you can still innovate because you can apply these strategies in order to enable you to prototype your robot or to prototype your new architecture very easily and very, very low cost. So now I want to kind of speed through an example. Let me just check how I'm doing on time. So I'm going to speed through this industrial example. I don't have as much time to talk about it. This is when I was working on a small spacecraft launcher as the head of R&D at Gilmore Space. And I want to talk a little bit about context and market motivation that also leads to design innovation, because design has to be driven by a market. And so the market need for small spacecraft launchers is, it was kind of ambiguous at first. It's not self-evident. So I had to do a lot of market analysis to say, why would this make sense? So worldwide, there's kind of a steady launch of satellites around the world, but in Asia Pacific, there's lots of satellites emerging, and so there was really a market to develop an Australian vehicle specifically for small satellites. And I know that ISRO has been developing a vehicle lately, and that's awesome. I definitely hope to see collaborations with ISRO at NASA and all that kind of stuff. So I'm open. But if you look at Moore's law, why is there a need for small launchers? Like, who cares? Well, computers keep getting smaller, and if you look in the 60s, computers were huge, and now computers are smaller. So maybe we don't actually need as big of launchers. And there's lots of companies. SpaceX is doing some cool stuff. You have companies like Planet Labs, Spire, Iridium, lots of wonderful new constellations coming out. The CubeSat open standard, so students can now work on satellites via the International Space Station. The CubeSat standard open up possibilities for student teams to actually develop their own satellite and get it in space. But why would small spacecraft change the game? Well, they're easier to deorbit. They burn up faster, so they're not creating space junk. They can have better communication, better resolution, and lower cost. Also, simplicity is powerful. If I have a system that relies on 100 components, if any one of those components fails, then the whole system fails. And so simplicity is robustness, and redundancy is robustness, right? The more parallel, yeah. So there's a lot of benefit for that market. But what was holding up the industry is that, well, and in some cases still challenging, but we need constellations in lots of different places. And so there's a market to develop a vehicle to support actually the replacement of those constellations. And so that's something that we could certainly work with partners on, is like helping to develop some of these small vehicles, because the Falcon 9 is still really, really big, 20,000 kilograms. So at Gilmore Space, we were looking at creating something a little smaller. Now, solid rockets are generally they can explode, so they're dangerous. Liquid rockets are just super complicated. They're just really hard to make. But hybrid rockets are fairly simple. And we were looking at hybrids because some of the old technology was that wouldn't burn easily, and so also the materials were no good. And so what I want to just jump ahead and note is that in my research, I'm going to just jump ahead on this. In my research, I developed this tiny little prototype, just a desktop thing. But I was able to use this to test the materials and to get it right and to make it work. And that's really enabled some fantastic things for Australia. They're developing their own launch vehicle program now, because we applied this kind of innovation where we do kind of low cost early stage testing to get it right, get the physics right, and then we can do bigger engine tests and more impressive things. This is the engine. So what I kind of want to get across here is that when you want to innovate,
Sorry, Prof.
when you
Adam.
want to create new things, have an impact on the world, it's so important to look at that user perspective, to look at how our designs are going to connect with the user, and to start by making, to start to lead by doing. That's what it's really about. And so, I hope that's inspiring. I kind of, jumped into this talk. I know it's not exactly on the subject of robotics, but I think that this idea of low cost innovation, is absolutely a prime opportunity for, organizations like yourself at PRIST University and here at Oregon State. We'd love to seek international collaborations, and we hope that we can get there. Of course, we live in an ever-changing world, but again, for my part, I love to make that possible. So if you want to look more into again, how to kind of make some of those decisions and how to enable rapid prototyping, I encourage you to reach out and feel free to request. I'm happy to send you some of my papers, or again, do look into my publications, because my publications will speak to that. And I see a question here. The parameters to be looked into deciding effective design freeze and the final cost. Well, so quantitative methods for design freeze, I don't really think that way. I really focus on what goal do we want to achieve. And innovation is very much an early stage process, right? But also so many of the clients that I would work with are fixated on that. I actually think that wherever possible, you should kind of avoid a design freeze. That's the principle of embracing ambiguity, right? Of keeping the options open, so that you enable that flexibility to develop adaptive solutions. Yeah, so that would be my answer to the question that I saw. Anyone else wanna post a question for a few minutes? I'd be happy to hang out and feel free to post something in the chat.
Bradley, I have a question.
Sure.
Christy from PRIST University. You were talking about the isolation, component isolation when it comes to designing the robotics. It was
Right.
interesting. Now, should we do that? When you are designing a robotic system for a vehicle, would you need to go for every component isolation and do it? What is the logic behind it?
Yeah, that's a really great question. So how do you kind of identify what to isolate? So what I usually think about is the novelty, because if you're just putting together piece by piece design, if you're just trying to reinvent the wheel, you might if there's a component, maybe you come up with a new sensor, and you think that new sensor is going to enable you to do different things that other robots couldn't do before. Well, your whole system kind of rests on that particular sensor being real, right? And so I would focus on developing that. So what we'll usually say is the most critical function or the most difficult to predict, and that becomes one to test. Yeah, I hope that helps.
Thank you, Professor Brad Adam. Actually, it was a very nice presentation. You have covered most of the subjects related to design science, design thinking, design innovation, design process, design principles, and you have also covered some developing new process, developing new materials, especially the UV resistant material, which is very relevant to this new environment, because a lot of UV related issues are booming up. So this will be hopefully this will be very useful not only in the robotics field but in most of the engineering area. Okay, so thank you so much, and so now the time to switch over to the next presenter. Okay, so now my privilege, and I'm so happy to invite the next presenter. Is Dr. Mohan Rajesh Ellara. In fact, for SUTD and for PRIST, we don't need any introduction to him, but still we need to do some introduction formally. Mr. Mohan Rajesh Ellara is currently an assistant professor with the engineering product development pillar at SUTD. He received his PhD and MSc degree from Nanyang Technological University, and he obtained his BE degree from Amrita Institute of Technology, Barrier University, India. His research interests are in robotics with an emphasis of self-reconfigurable platforms, as well as research problems related to robotic ergonomics and autonomous systems. He has published more than 80 papers in leading journals, books, and conferences. He is a recipient of SG Mark Design Award in 2016, 17, and 18. Okay, so he is the co-founder of Lionsport, a robotics company that develops and deploys a wide range of autonomous cleaning robots. He's also a visiting faculty member of the International Design Institute at the Shenyang University, China. So I welcome Dr. Mohan Rajesh Ellara for the nice presentation. Yeah, hello. Okay, hello everyone. I'm Mohan, and I'm glad to be in this forum to present our ongoing research commercialization effort at SUTD and broader in Singapore.
Particularly, my talk here would focus on our experience with the Lion Spot and how we made effort to carefully translate outcomes of research program from the university, SUTD, into the startup companies. So at SUTD, we have a large research program that targets design, development, and validation of reconfigurable robots, targeting maintenance applications. We have robots that deal with problems related to cleaning, inspection, logistics, security, often involving laborious and unsafe and repetitive work processes. And again, Singapore being a country that has large issues with aging population and always a drive towards improving productivity, robotics serves as a significant opportunity in solving problems in this domain. So when we started this targeted research program in 2017, we had aspirations to not just provide and produce intellectual outputs, but also go beyond to translate technologies in terms of licenses to commercial companies and even inspire startups that are capable of taking these technologies from the university through existing frameworks that our Ministry of Education has put in place to translate the technology as licenses, and these companies would bring them to solve the problems in Singapore and also to commercialize these solutions globally. Specifically, cleaning robots were of interest to us because Singapore globally is known as a clean and green city, and a cleaning robot from Singapore would be easily accepted in most countries because of the standards for cleanliness in the country, and also the aspiration of the country to integrate technology into the maintenance and cleaning work processes. So we identified cleaning robots as an apt candidate for us to pursue in terms of inspiring a startup in this domain. So again, cleaning work processes itself was ripe to accept robots because in Singapore and again in most developed countries, even many of the developing countries, we see a big shortage of cleaners, and also these work processes can be easily robotized. There are some robot platforms that have been developed earlier when we were thinking about a potential startup, but the robots were in ideal or meaningful for these work processes. So we looked deeper into some of the challenges that these robots faced and how we would develop and deliver robots that significantly outperform in terms of functional performance, and also to look at the seamlessly integrate into the existing work processes. So the robots that existed before LionSbot were often too large in size, and here we are looking at robots for professional industrial setting, robots that can clean shopping malls, airports, schools, universities, office buildings, and places like that, which are often crowded, dynamic, with a lot of uncertainties. So the robots that existed before LionSbot were too large, they were too slow, given the complexity of the environment they were navigating. And again, collision is something that these robots must always avoid, as it would lead to even termination of contracts for these robotic startups. So the robots were often slow and they were too expensive. So the platforms that were deployed for professional setting were in a price range of over $80,000. So as a professor of at the university in Singapore, we're leading a research program here. I had technological outputs that were developed, and I had an understanding of the product strategy that can be put in place in a company, but I lack expertise in terms of understanding the industry the constraints that the industry faced, and also networking and challenges within the industry. So that's where my co-founder Dylan came into successfully finishing this puzzle. So Dylan and Michelle, they are husband wife, and they have been successfully running Super Steam Asia Pacific, a leading cleaning equipment distributor in Singapore. And with their company, they distribute foreign cleaning equipments and technologies. Beyond that, they also manufacture and produce certain cleaning equipments and solutions locally. So they had a sound experience of over 20 years in the cleaning industry with strong networking globally and locally with cleaning service companies, with government agencies in the environment domain and all. Also, they carried with them the infrastructure and resources in this domain. So we came together with Dylan and Michelle's aspiration to also build cleaning robots of their own. We set up LineSpot in early 2018, and we wanted to develop robots that were fundamentally different from what existed before LineSpot. So we brought in the ideas of design thinking, genuine design thinking, engaging participatory design processes in our product development phases, empathy for end users, empathy for stakeholders, other stakeholders, not just driven by technology, but to have a niche design trade-off between all these different variables. The manufacturer, the design team, cleaning service companies, government agencies, building owners, so our supply chain. So we have to take into account all these factors when we have to arrive at a particular design, so that we can produce robots that define the future of cleaning. So there are a few attributes that define our LineSpot robot. The first one is our robots are cobots. Basically, they work closely with humans and human in the loop. So with that idea, imagine there is a shopping mall that requires robotic deployments for cleaning. So human would handle areas that are complex or inaccessible for robots to perform cleaning job, whereas robots would cover areas that are often easy to reach by them, and that significantly redefine the design of the robot, because if we attempt to make robots complex to achieve close to 100% area coverage, then we will end up with robots that are often bulky, computationally complex, and very expensive for cleaning service companies to offer, right? And we also go into the dilemma of human versus robots. But now, with the case of LineSpot, we took a careful stand where we will develop robots that work by the principle of cobots, working closely with humans, where robots would cover majority of the spaces to clean and maintain, whereas humans would cover difficult to access areas, managing these robots. Then we another principle that define our LineSpot robot is the right robot for the right job. So we do not integrate a number of cleaning feature into a single robot, but instead we have dedicated robots that perform different type of jobs. Like we have a robot for scrubbing, we have a robot for vacuuming, we have a robot for sweeping, while they share a big percentage of the hardware DNA among them and software DNA between them. So with this case, we have dedicated robots that are super efficient in handling specific jobs, and they can be deployed at the same time or in series. So we also offer a ownership light approach for business, as our robots are rented monthly, then selling them. So the cleaning service companies or building owners did not upfront come up with a huge cost, but instead they can rent the robot. And also they need not worry about maintenance issues, but our company provide all services associated with the maintenance 24/7. And finally, our robots are designed for mass deployment, so we can scale up to support deployment not just within Singapore but globally. So our robots has a set of new vision. We have a number of robots that targets specific areas within the cleaning work processes. Our robots are nimble. They are able to access spaces that are impossible for other robots to access. and that can only be powered by specifically designed hardware and software. Beyond that, our robots can work as a team, and this teaming could work with homogeneous set of robots, meaning we can have a set of scrubbing robots working together to scrub, or it can be a scrubbing robot working with a vacuuming robot to clean with different principles for cleaning a given space. One major attribute that our robots bring to market is its personality. So our robots are ones that people love, and that is exhibited through our human-friendly emotions that the robot produce. So we have dedicated wealth of effort in terms of arriving at our aesthetics and human-friendly emotional outputs that our robot produces. So a short video here of our LineSpot platform, the LeoBot, our very first class of robot that has now been deployed in many places in Singapore and around the world. So our robots are completely engineered, manufactured in Singapore, and we have now gone beyond deployments in Singapore to global deployments. Our robots have now been deployed in over 10 countries. So again, most of the engineers at LineSpot have been trained in different aspects of robotics and product development by SUTD. So we now have over 40 engineers, out of which over 30 have been trained at SUTD. Again, they work and they were affiliated with the International Design Center that the previous presenter shared. So with our LineSpot, we look at a rental as a service model for deployment of our robots, where the cleaning service companies or building owners sign up for an X number of robots. Then they look at the categories of robots that they are going to rent in terms of scrubbing, vacuuming, sweeping and all, and then they look at the infrastructure places to deploy. So we present a new business model for deployment of cleaning robots in large scale. So in terms of international expansion, we work with our distributors who are also leading cleaning equipment distributor in different countries for bringing the robot to different nations. So we have a family of cleaning robots rather than a single robot, which is often the case before LinesBot came into existence, where the companies are often producing scrubbing robot or vacuuming robot and not more. So in our case, we have 8 different robotic platforms that we are now deploying all around the world. So our robots often come with 5 cleaning modes, ranging from schedule and clean, where a robot operator could schedule cleaning processes and the robot would cover the defined area. Our robot can be operated in a teleoperate mode, where the user can continuously manually control a robot to clean a given area. The robot can be deployed in a point and clean mode, where an app can be used to point specific regions in a map, and the robot would go down to these places and automatically clean the space by itself. The robots can be deployed in a teamwork mode, where multiple robots can be deployed to cover often large areas like shopping mall, train stations, bus station, and on. So our robots can also be deployed in a mingle mode, where the robot moves around interacting with people in social spaces. So our robots are often characterized by a number of new technological features like the nimble tech, where while operating in nimble tech, the robot moves really, really close to wall surfaces to clean areas that are close to wall, which are often inaccessible by other traditional robots. Our robots offer a quiet tech option, where the robot produces um, very little noise, and this is often expected for robots that operate in like hospitals. So we use ecotech. For instance, our mopping robots uses 7 times less water than traditional robots in the market. We use Z water, which is a proven cleaning chemical that has superior performance compared to other solutions in the market. So also here, our robots use one map and which can be shared across multiple robots, meaning we can have a scrubbing, mopping, and a vacuuming robot, and a single map recorded once for a given facility can be shared between these maps. And with the robots being enabled by 4G SIM card on board, the maps can be downloaded remotely for them to operate in a given space. So we offer a number of cloud features, from aggregated reports on a daily basis that these robots produce and send to cleaning service company, to tracking of assets, real-time updates in terms of human density in particular areas, which the building owners would be of interest. Like in shopping mall, there is always an interest to know congregation and density of people from time to time within the given building. And all these information are collected, and also the map. So we have rich information of the map across different buildings that can be used for future expansion of robots and also activities within a given building. So our robots are powered by AI in terms of efficient path planning to scheduling of the robots, predictive maintenance, and also efficient energy strategies, which helps in extending the lifetime of operation of the robots for a single charge. So safety has been of utmost importance for LineSpot. So LineSpot is the only company that has a comprehensive safety strategy within the cleaning robotic market. So our safety strategy is available for download by our customers from our website, or any individuals that are interested to know. So we have multiple hierarchy of safety features. Even with sensors, we have a lidar, a camera on board, ultrasonic sensors, infrared array, and bump sensors to ensure safety. And at algorithmic level, the robot has packages that help to produce different behaviors when it's interacting with an adult versus a child, so that the robot can be very fluid to ensure safety when a scenario arises. So with the current COVID situation, LineSpot is playing a larger role to support in terms of increased need for cleaning and disinfection of facilities, and reducing number of cleaners who are willing to to go into these places to clean. So LineSpot has now increased deployment rates in hospitals, and our robots have been deployed in Singapore Expo, where COVID patients have been housed. Also, we have increased deployments in hospitals, performing disinfection, where the routine for disinfecting processes has significantly increased. Also, we have our new robot that has been deployed in the market recently, Leo Ray, that looks at UV disinfection. Again, it offers a number of first of its kind features um, um, towards UV disinfection. So with LineSpot, we are not just looking at bringing products to market, we are looking at transformation of work processes in cleaning industry. So what you see here is a typical example. We have Lily, she is 75 years old, and she now operates 4 Leobot robots at Harbourfront Center, is a shopping mall, and it looks at transformation of a job from cleaner to a robot operator, and upskilling individual from work processes that are often dull, routine, dangerous, or ergonomically more difficult to jobs that are human friendly, and that can be handled by an aging society. So we are making big impact in these areas and working closely with government agencies in Singapore that targets transformation of jobs. So we have been recently awarded the Innovation Award at the Interclean, and this is equivalent of Oscars of cleaning equipment. And we are very proud that we are the first Asian and Singaporean company to win this award. And here we are fostering to go even aggressive in the domain with new class of robots and more efficient robots that can handle a rising situation with COVID-19. Our robots have been deployed in many iconic sites within Singapore and have been deployed, and they are increasingly be deployed in new sites that are often complex, involving heavy crowds and dynamic scenarios. So our robots have been featured in a number of media worldwide, gaining attention in different markets, given that our robots are also being deployed in prominent sites beyond Singapore shores. So far, our robots have been deployed in over 11 countries, and this number is increasing by the month. So again, that's the end of the presentation, and LineSpot is an example where we show that the research and design and product development can always be meaningful and can translate the boundaries of research lab to enter as products, solving the problem in a local setting and translating into products for the global market. Thank you. I'm now open for questions.
Thank you, Professor Mohan Rajesh Allara. It was a very nice presentation. And it is covering how the research commercialization and the success history of the LineSpot, making cleaning robots for for various applications, and how you build the different cleaning robots. And it was good for, especially for any people, have a new insight to the people who want to come into this emerging robotics manufacturing industry. So, is there any question from the audience, please?
Very good morning, Rajesh. This is Ramchandran.
Yes.
We are at Tanjavur. As you know, we are going for a food processing industry.
Yes, yes.
Wherein 5,000 tons, metric tons cold storage we are aiming for.
Yes.
Can we make one robot totally to control this cold storage unit 24/7?
Yeah, certainly. I see that agriculture and larger food processing are areas where robotics and automation can play a big role, and it is a domain where there are many work processes that are often repetitive, labor intensive, and present many safety and ergonomic issues. I'm happy to collaborate and work on potential projects in this domain.
Thank you, Professor Mohan. I think in order to keep our time, let us move to the next presenter. Let me invite Dr. Laolin Hong. He's an associate professor in mechatronics in Auckland University of Technology, New Zealand. He had about 30 years research experience in the areas of robotics, mechatronics, and control in his academic careers in Hosong University of Science and Technology, China, Singapore Polytechnic, Singapore, Massey University, New Zealand, and AUT. Please join and do your presentation, sir. Dr. Laolin Hong.
Dr. Laolin, can you hear? It's also open.
Sorry, excuse me.
Yes, yes. Now we can hear you. Now you can please.
Can you hear me?
Yes, yes, we can hear you. Now you can share your screen, the third icon from the left.
Just a minute. Optimize for text in the image. Power plant.
Hello.
Sorry, can you hear me, please?
Yes, we can hear you.
We can see your presentation.
Okay. Excuse me, can everybody hear me?
Yes, yes, we can hear you and we can see your screen. You can maximize and please continue. You can maximize the PowerPoint screen.
Sorry, some audio quality is not here, but yeah, I don't know why.
You can share the whole screen actually, apart from not just PowerPoint slide. There is an option for whole screen, then yes. We can see your PowerPoint slides.
So can you hear me?
Yes, yes, we can hear you and can see your slides as well.
Okay, good. And I'll continue because the bandwidth here, I'm at home, and New Zealand is too remote from Singapore or India. I think maybe network problem.
Okay.
Okay.
Yes, perfect. But please continue. Okay, sure.
Yeah. Thanks for the excellent presentation before me. They are more on very large scale and system level. Today I just present a very specific issue in control of robotic wheelchair, especially two-wheel robotic wheelchair, which actually provide much better maneuverability and mobility than the conventional wheelchair. But this wheelchair is inherently unstable in the sense that it cannot be maintained at upright position itself through its own mechanism. So this means we need to actively control its stability so that the wheelchair can keep upright position to make sure the rider has enjoyable experience in riding. Okay. The outline of my talk is include introduction and some mechanism used for stability control. Then after that, some existing approaches to achieve stability control. You can see how the motorized robotic wheelchair is evolved from the traditional manual wheelchair. Traditional manual wheelchair looks like this. They have two wheels and two caster wheels to support the stability of a wheelchair. Then the actuator is added to drive each wheel. So we call the motorized wheelchair. If some intelligence has been implemented in the motorized wheelchair, so it can be called the robotic wheelchair, because the difference between a conventional wheelchair and a robotic wheelchair is whether some autonomy or intelligent behavior can be achieved in the wheelchair. For the conventional robotic wheelchair, I think they still keep the caster wheel here, but this caster wheel is good for stability, but it can make the motion very clumsy and the dexterity is lost. This means if you want to turn around, change directions, or you want to have a more dynamic motion pattern, this caster wheel really cause a problem. Yeah, problem. Then nowadays, some wheelchair manufacturer get rid of caster wheels. So this means they removed the caster wheel. But after caster wheel are removed, the wheelchair is not stable in terms of keeping upright. Yeah, something like that. And only two wheels. I think a two-wheel mechanism is a typical differential drive mechanism in the mobile robots or other vehicles. They provide much better maneuverability and mobility. For example, such kind of a wheelchair can turn in a very narrow space easily. So you don't need to, the robots doesn't need, the wheelchair doesn't need make maneuver in a large space to turn, to make a turning behaviors. Yeah. The model of this kind of wheelchair can be simplified as the two-wheel involved pendulums. But this only simplification is not actually equal to a two-wheel involved pendulums. Yeah. So in terms of principles behind this wheelchair, yeah, the involved pendulum mechanism can be used as a reference in order to develop dynamic model as well as controller design. Okay. The stability is affected by many factors, such as uncertainty of system parameters. For example, different riders have different weight, different height, so this will affect the inertial parameter of the systems. Also, if you want to autonomy in the motion of the wheelchair, the sensor are needed. So the sensor signals are normally noisy, and you need to make sure the signal is as clean as possible. So if not, your control system must be robust to the noises in the sensor. Also, the disturbances really happen because of the road conditions, as well as the riders, posture keep changing on the wheelchair. And yeah, there are quite a lot of external disturbances. So in this case, the controller must be adaptive or robustive, to handle all these uncertainties. Fortunately, the adaptive robust controller are quite mature, at least in theory. Okay, I cannot say in practice. Many people say in practice, the PID controller actually dominate in many industry robots. But in the past 30 years, 20 years, there are tens of thousands of papers, published for the robotics control. Yeah, they have plenty of controller, has been developed. Yeah, so maybe we can use those controller which has been developed and to stabilize robotic wheelchair. So this is the point I want to highlight today. Yeah, this is just one kind of disturbances. The mass as well, the mass of the rider relative to the wheelchair, yeah, can be easily changed. So the dynamic model can never be accurate. You need to take into all these variation or disturbances into considerations. Now, there are another problems. Traditional two-wheel robots, they rely on the wheel to stabilize. But we know the wheel actually was originally designed to produce the motion, forward motion, backward motion, or turning. I think this is the main task of the wheels. Now, the wheel also take another task, to keep the rider upright. So it seems quite demanding to the wheel. This also another issue coming out. Most robotic wheelchair is powered by battery. So if you just using wheel to drive the wheelchair, as well as keep its stability, the controller might be very hungry for the power. The battery can become flat easily. I think this may be the issue for the Mohan's cleaning robots. I just say, for any autonomous robot system, the power supply is a big issue. You need to keep charging. You need how to keep the battery alive as long as possible. So this means the controller should consume the minimal power so that the battery can last for longer time. I think this is the critical issue you're facing the autonomous robotic system, including robotic wheelchair. So now, recently, maybe not recently, many people have developed approaches which can free the wheel from stabilizing wheelchair. This means they try to add additional mechanism to the wheelchair, which can help the wheelchair to stabilize with much less energy, or can stabilize the wheelchair more efficiently. This means the response time is fast, the working range is small. Yeah. So this is the motivation behind a new stability control approach. Okay. So the first one is they add a backrest. This means if you have a rider here, we add another rotating. Now this rider, we add another rotating mechanism. So hopefully, with a small change of the motion of the backrest, which can stabilize the wheelchair. So this means the motion of this mechanism will be in charge of stability control, then free the wheel so that the wheel can focus on producing forward motions or backward motions or the motion required for turning. Yeah, this is the one approach. It is mostly based on the rotational motion of the backrest. Second one is they say the seat can be made to move. So take a look. They produce movable seed for the rider. This actually mostly is a linear motion of the seed, either in the x-axis or y-axis. Yeah, this is a second approach. But because this seed move the rider too, sometimes the rider, for example, 100 kg or 200 kg, I think it's maybe a lot of it's quite a challenge, to move such a big mass. So the people come out another idea. So they put additional mass underneath of the seat. So this means instead of move the seat together with the rider, yeah, we can just move a mass underneath the seat. I think all this approach has been tried by different groups. I think mostly I found in Japan. There are some groups in Japan have tried these approaches and get some result. Get some results. Okay. Now, with all this mechanism has been selected, assembly. The next one is modeling and control. As I said, there are rich resources of dynamic modeling in the control scheme for the traditional industry robots, especially the industry robotic manipulators. Also, there are a lot of research outcomes from the mobile robots control. I think the mobile robots control area dominated by kinematic control. Yeah, the industry robotic manipulator, is dominated by dynamic control. This means the acceleration dynamic effects have been considered more in the industry robots than in the mobile robots. The reason is the mobile robots is quite a complex system. It looks simple, but in reality it's not. The reason is it is a so-called non-holonomic systems because there's so many researchers dig very deep into non-holonomic systems. The reason is the mobile robots is constrained in the derivative space, the position derivative velocity. So there's no closed form solution to translate the constraint in the velocity space into the position space. So the dynamic modeling is actually very complex. Yeah, facing this problem, should we try to use a non-holonomic system to model this robotic wheelchair, or should we using the model of industry robots, robotic manipulator? I think we can choose the second one. The reason is if you put more emphasis on the holonomic constraints, sometimes your problem becomes undoable in practice. Yeah. This is why many mobile robots control is based on kinematic model and on the speed control, not on the torque control. This means if you're using the torque or the current of a motor, and it's a typical dynamic control. If you just use the speed as input, it's the kinematic control. Now the problem coming. If you're just using the industry robotic manipulator control or modeling, there are many dynamic, like non-holonomic and other dynamic phenomena is not considered in your model. So in this case, we can use some robust control scheme or adaptive control scheme to compensate, for the uncertainty in the modeling. So this is some of my observations in this area. If you're just using the industry robotic manipulator dynamics, which is established by traditional Newton-Euler equations or Lagrange formulations, we can actually produce the dynamic model which are quite similar to the common dynamic model of the industry robotic manipulator. I just give you one example. Yeah. So once this model is established, you can apply many robotic controller which has been developed. Yeah. Either using the this means you need a model base. A model base means the controller need to compensate the dynamic system, dynamic behavior explicitly. You need a dynamic model. So this includes a very traditional computer talk control scheme, sliding mode control, and yeah, you can also use in model-based LQR controller. Is this for the linear model or nonlinear model. Second one is a model-free. This in your ignore the dynamic model. So PID, force logic, ANN, etc. So these two main approaches can be applied. At the moment, I have students working on this subject. We have produced a prototype of wheelchair and try some control algorithm. We get some promising results, but still we have a lot of work to be done to make sure the stability control scheme is practical and it can be commercialized in the future. There are still a lot of efforts to be taken in the future. Okay, this is all of my today's presentations, and thanks for your attention.
Yeah. Thank you. It was a very good presentation, and it's a good understanding about the stability control feature. I'm sure it will be useful in aspects, especially some new approaches like mobile mass.
Yeah.
Very interesting. Many thanks. And is there any question from our audience, please, to Dr. Rolling Hong?
I have one question. Regarding the stability, like, have you used that you were mentioning on the rotating mass base behind the wheelchair? Is it the principle similar to gimbal, like flywheel kind of concept, which counterbalances the whole center of mass by rotating the mechanism at the back, which is placed?
Yeah, actually, this you can see nowadays. I think very famous one. The balance of the I think I forgot name. You know, I think this has been. The people have a cost. The roller. Uh, yeah, this idea is similar to that. Yeah.
Correct me if I get it wrong. So there is a like rotating mass at the back of the wheel, right? In one of the slides you were mentioning.
Yeah, the mass can be rotated, or you can using translational motions. But we're trying to compare different motion to see which one is much more robust or more sensitive. So require less working range and consume less power. So far, it's hard to quantify. So I try to establish a model to quantify the disadvantage or advantage of different mechanism in terms of the different objective. For example, the magnitude of input, the power consumptions, etc.
Okay. If I have more question, I'll contact you via email. I'm Amir working with Prof. Mohan only. So
Yeah, sure.
I find it interesting. Yeah, Sure,
Yeah, we can communicate. I think not so many groups working in this area. So
yes,
if you're looking around, but because this two-wheel robotic wheelchair will become more and more popular. In New Zealand, there's one company. There's only one company start to build a two-wheel wheelchair.
yeah.
This company, because the IP issue, we really hesitate to work with the people outside the company. So my hope is if we can get some initial results from the lab, then we can show them uh, the performance of our prototype compared with their wheelchair.
Okay,
Yeah.
okay. Thank you so much.
Yeah. Also, this kind of the robotic system here, yeah, New Zealand has a very high bar in the compliance. Especially ethic approval. Yeah, this a headache to me. You develop any system for healthcare, you need to follow the ethic approval committee, and there's a very high bar to overcome. So eventually, there's no choice. We need to work with industries because they are very experienced in compliance issues, safety and health, many law and legal regulations governing this research.
Okay, thank you, Professor Lolin.
You're welcome.
Thank you so much.
You know my email, right? Maybe you just type my name, you can get my
Yes,
contact number. Yeah,
actually,
my PhD students. Yeah,
yeah.
you
Thank you
get
so much.
some. You're welcome. Yeah.
Okay, that's great, Dr. Laurin. Right.
Okay. You're welcome.
Question from maybe a last one question from audience, please.
4 minutes.
Yeah.
This is Christy from PRIST University. Hello.
Yes. Sorry, I cannot hear you.
You can also type the chat box. Participants are advised to type your question in the chat box so that
Sorry,
Laurin
I
can.
can. Sorry, I cannot see that. And I'm new to this program. This is the first time I use this APP. Yeah, where normal. I don't know where is the nose. Just a minute.
Yes, the rightmost.
Sorry, because the application window disappear. I don't know where where to find it.
Okay.
Sorry. Yeah, I found it. Uh, but I cannot find any questions. Yes. Can you type? I can read it.
Uh, sorry, I want to ask that the Euler-Lagrangian model you showed, that is for the wheelchair only, or it is up to mass model when person is sitting and then the wheelchair, because there will be two coupled masses, and the Euler-Lagrangian model, the inertia matrix will differ. Are you certain that though that model will verify the properties of Euler-Lagrangian model? For example, the derivative of inertia matrix minus 2 into the correlation matrix equal to 0. Those kind of equations, the model will verify.
I think you must be careful. I know why m dot minus 2c is skew symmetric, right? I don't think so.
Yes, yes.
Yeah, the property. I try very hard. Actually, Mohan know me very well. I work in Singapore for many years in mobile robots control. Actually, I have tried to model mobile robots as close as industry robots. Then I try very hard to check whether the good property of the industry robots model exists. Unfortunately, there's a no, and I don't think so. Yeah.
Yeah, the same thing I am facing. I am also trying to go for dynamic
model of mobile robots and controlling them. I'm
Yeah,
also in
yeah,
professional
yeah.
lab,
So
but
we are
I'm
we
not
are on
very
the
sure.
same
But I
boat.
try to. Yeah, I
Actually,
tried wonderfully approach only.
I try very hard to develop that. Actually, several pages in the 1990 or 19 I think last century, 1990. But I give up. Yeah,
Yeah, yes. I was facing the problem. That's why I asked you. Anyway, if I'll get some idea about it, I'll mail you and try to contact you.
yeah. But the good property, there's some property has been maintained. Yeah, for example, the positive definiteness of the inertial matrix maintained. You know, the
Yeah,
inertial matrix has a very good property. It is symmetric as well as positive definite.
okay. We can
No
exploit that
problem.
property and
Yeah,
design controller. Yeah.
yeah.
Thank you,
You
Prof.
know,
Thank you, Prof.
some property has been maintained, but some property may not. Yeah,
Yeah. Yeah. Thank you for your information. Thank you, sir.
yeah. You're welcome. We need to talk. You can email me, or we can have discussion on this issue.
Of course, sir. Thank you. I'll
Yeah.
try to contact
Okay.
you later.
Yeah, yeah. Okay. Sorry. Thanks so much. Yeah.
Yeah, hello. Am I audible?
Yes, you are audible, and we can see your screen as well.
Okay, thank you. Shall I start?
Yeah, sure. Please.
So hello everyone. I'm Rizwana, a research fellow at SUTD Singapore. First of all, I would like to thank the organizing committee and the PRIST University India for arranging this international webinar for the robotics community. And thank you, Prof. Lolin, for a detailed and informative presentation on the control and stability. Today I'm going to present on self-reconfigurable drain mapping robot. So this work is part of AirMine project, which is funded by a national robotics program and A-Star Singapore, and which is carried out under the supervision of Professor Mohan Rajesh Ellera at SUTD. So coming to the service robots, so these robots are usually assist human beings typically by performing a task which is dull, distant, dangerous or repetitive. So the application could span from the construction, cleaning, underwater, defense or maintenance. So they are typically autonomous or semi-autonomous, or it can be operated remotely. And statistics show that there is a demand of service robot which is gradually increasing, and in the next 5 years, the demand is almost going to double. Yesterday, we have few wonderful presentation on service robot, and we have seen that how they are working effectively and efficiently during this COVID situation. And our team at SUTD is developing a class of reconfigurable service robot for various applications, including floor cleaning, drain inspection, pavement sweeping, and glass facade. And Professor Rajesh Mohan Ellara has already given a brief overview of these robots that we are doing in our lab. And today I'm going to present on the maintenance robot for the drain inspection or the drain mapping application. So drainage system are the integral part of urban areas. Here we consider the drainage system that those are mainly constructed to carry the extract water to reservoir. So the drainage system can be classified into open or closed surface or subsurface type. And the primary purpose of these drains to remove the excess water in safe and timely manner. And if there is any clogging of water, then the community face water-related or mosquito-borne diseases or many more hurdles. So to control this kind of problems, serious inspection, monitoring, and the periodic maintenance of the drainage system is highly required. At present, this work is done manually and it is very labor intensive. And it has safety concerns as well because there are a lot of difficulties in accessing the areas under poor lighting and less ventilation condition. Hence, there is a need for design and development of the robotic equipment for the drainage application. So this figure shows a schematic of a drain that carries excess water to the reservoir. It has a level shift. So this type of drains are usually widely found in Singapore, and the drain width varies from 1.1 to 1.8 meter, but this level shifting height is varies from zero point 0.3 to 1.1 meter. So as a part of this project, National Environmental Agency of Singapore has a special requirement for a drain mapping robot with level shifting capability. So the primary objective of this robotic platform is to identify the mosquito inhabitant and maintain maintenance of the drain infrastructure periodically and detecting the water clogging area. So from the mechanical point of view, there are mechanical design point of view, these are the design requirement. So we need a locomotion system which is suitable for dry and wet terrain or uneven terrain, and the platform has to work in the constrained spaces of the drain environment. And we need a set of mechanism that adapt the variable drain width and level shifting and also adapt to the variable height of the drain. So based on the mentioned design requirement, in the first phase of the project, our team have developed a hybrid platform called Tarantola. It has a central body called trunk, which is attached to 4 legs, and each leg has 4 degrees of freedom, and it consists of revolute joints, prismatic joints, and the telescopic extension mechanism. And each pair of the front and the rear legs are attached by a single chain sprocket mechanism. And in this project, we observed few drawbacks in this particular platform. We found that the telescopic extension it takes longer time to extend and the contract, and the platform is incapable to perform the level shifting. And due to the single point of contact of the wheel on the platform, we found that the platform is quite unstable on rough terrain. And also there is some slippage issue in the chain sprocket mechanism in the abduction unit. So in the next iteration, we obtain the underlying design inspiration from nature. The giraffes are the tallest and land animal with long legs. The hind leg, which is the rear leg, has 4 joints as shown in figure. And this hind leg has a unique mechanism by which the hind leg can bend towards the posterior end about the femur tibia joint as shown in the figure, and also the leg can splay out to the side about the hip joint. That implies the hind leg has mobility in the two orthogonal planes. And secondly, both fore and the hind legs maintains a unique posture called the outward folding during the sitting. And we claim that with this folding pattern and the degrees of freedom associated with the legs, the animal is able to accommodate the large body weight with a stable posture during sitting and the standing. So using this concept, we build a hybrid drain mapping robot called Tarantula 2. So you can see the similarity between the posture between the two designing, natural design and the engineering design. So this is the Tarantula platform, and it has a trunk body which is connected to 4 legs, and the platform weight is around 20 kg, and the platform height can vary from 0.5 to 1 meter, and it has 3 sub mechanism, which is the abduction unit, leg, and the wheel. And the trunk is the primary supporting structure of the platform, which is designed to placed parallel to the drain section. And the trunk cover is made of high-grade plastic, but all other components are made of aluminum. So the trunk carries a suspension mechanism that is used to support the electronics parts and also a abduction unit. So as we discussed earlier, the leg design is based on the giraffe's leg anatomy. Here, each leg has four joints: the hip, femur, tibia, and ankle joints. And hip joint provides the abduction moment to the entire leg. Hip joint of the both front legs are driven synchronously by a abduction mechanism, as shown in the top right figure. It has a DC motor which is connected to a set of gear trains. And during the reconfiguration, when the platform has to move inside the drain environment, it has to change the wheel spacing, and that means the spacing between the legs. So during reconfiguration, both abduction mechanisms synchronously actuated so that both legs maintain the fixed wheel spacing and the platform has maintain a stable height. And it also has a special feature in for example, it has a bidirectional rolling wheel, which consists of a rolling and the steering unit, which are independently. That means the wheel has the capability to roll and the steer along two different axes. And here each leg consists of the two linear actuator with a revolute joint at the proximal and the distal ends. During the process of design, structural analysis plays an important role. For this platform, the gear train mechanism, abduction mechanism, the legs, and the wheels are the critical structural component, and the deformation and the loading capability and the natural frequency of the system and the components are required to be estimated. So we carried out FE analysis, and from FE-based static analysis, and from the simulation, we found that the design is structurally safe because the maximum deformation and the maximum stress is generated in the parts is less than the critical stress of the material. Next is the model analysis, which is very essential to know the natural frequency of the system. So during navigation, the platform has different gate condition. During locomotion, all the legs are retracted, so the platform moves at its lowest height, and all the legs are in contact with the ground. However, during the level shifting, all the legs are extended state and the platform has a maximum height. However, the boundary or the contact condition changes, so that the platform has both swing and the stand phase during the level shifting, and the contact condition basically changes the natural frequency of the platform because the boundary condition changes. So using FE analysis, for each boundary condition, we obtain the fundamental frequency based on which we try to operate the abduction motor, linear actuator, and the wheel motor below the first natural frequency in order to avoid the resonance. So as discussed earlier, the wheel is a rolling wheel, which is made up of Durlin, which is a high-grade plastic material, and it has a bidirectional movement capability. It has a spherical cross-sectional geometry. That's why we call it OS wheel. And this work is recently selected in IROS 2020. Here the wheels are assembled at an angle beta with the legs. Here each wheel is represented by two independent rotation, theta 4 and theta 5 as shown figure. And due to the complexity of the geometry, the wheel radius changes due to the change in the steering angle. And the variation is obtained by the spherical model, and these above equations govern the rotation of the wheel. So we experimentally validate the locomotion capability of this wheel, and we built a mini platform to check the locomotion capability with the two OS wheel. And this figure shows the trajectory tracking of the platform. And we found that the wheel can change the motion during motion without stopping in between. So coming to the leg kinematics, so here each leg has 4 degrees of freedom, which are represented by theta 1 to theta 4. Theta 1 is the degree of freedom of the hip joint. So the change of height of the trunk is attained by using two-link planar motion. And here height of the leg is a function of theta 1, theta 2, and theta 3. However, the wheel spacing is a function of theta 1 completely. So the vector diagram of the each leg, which consists of two subsystem, because in each subsystem we have the linear actuator. So here the vector diagram for each subsystem is shown here. So in each subsystem, the variation of the length of the linear actuator act as an input, which result in the variation of the angular rotation. And we also formulate the inverse kinematics, which is required for the controller design. So you can refer the published paper for the details. So we also carried out workspace analysis to check the workspace obtained by each wheel. So the workspace analysis is carried out for each leg based on the DH formulation. First, we experimentally obtain the rotational range of the femur tibia joint and hip femur joint. By using this data, the workspace is estimated. So we found that without a hip joint, the leg is a planar mechanism, and the workspace that we obtain is a 2D workspace. But when we add a hip joint to the DH formulation, the workspace becomes a three-dimensional one. So coming to the platform kinematics. So this is the simple platform kinematics we have used. By simulating this kinematic equation, we verify the straight line and the turning ability of the platform in the different trajectory. And we also experimentally verify the turning capability of the tarantula in a curved path. Then comes to the stability, because this is the quadruped robot, and stability is a critical factor. Even if the speed of the platform is low, the static and the dynamics balance of the platform needs to be maintained. Here we use the concept of static stability margin, that is the concept of the support polygon, to study the stability of the platform at the static state. So the rectangle below the platform represents the support polygon, which is the projection of the contact location of the wheel on the ground. So when all the legs are on the same length, the trunk is perfectly horizontal, and the CG exactly lies at the center of the support polygon. But as we increase the tilt on the inclined plane, the area of the support polygon gradually reduces and the CG shifts. So with the further increase in the tilt, the CG may fall out of the polygon. So in that case, the system is going to be unstable. So that's why in Tarantula platform we have intended to adjust the leg height such that the trunk body will always be in the horizontal position, irrespective of the any inclination of the terrain. And secondly, when during the level shifting, the point of contact changes and the area of the support polygon also reduces. So, and there is a high chance that CG may fall out of the support polygon. So any tiny perturbation can cause instability to the system. So therefore, we have incorporated an tell mechanism and a IMU based active correction for enhancing the stability. So you can see here how the support polygon varies for the different scenario of the gates and the level shifting. So the one of the objective is to keep the trunk horizontal position to avoid the fall and keep the CG inside the support polygon. So as I mentioned, an IMU is installed on the trunk, and the pitch angle is monitored from IMU. And based on the pitch error, the controller actuates the leg joints to maintain the pitch angle in the threshold limit. And we tested the algorithm, and the results show that the variation of the pitch angle is on an inclined plane from 0 to -10 degree and -10 to 0 degrees. So here you can see the A, C, and the E are the stable posture. So we validated the locomotion capability of the platform in the lab setting. So by rotating the wheels clockwise and the anti-clockwise about the rolling axis, the platform is able to move forward and backward. Similarly, about the steering angle, if we change the steering axis, then the platform is able to move in the sideways. And by varying the wheel velocity, the platform can have in pivot rotation. We also tested the label changing capability in the lab setting, and it was verified on a wooden block. We checked the climbing down capability of the platform. We installed one IMU sensor, and it was connected to the trunk, and that helps in maintaining the correct position. So now after level shifting, the platform is trying to come to its stable height, which is the lowest height of the platform. So the legs are retracting to maintain the lowest height. And the platform was also deployed in a real drain environment with a level shift of around 1 meter and 80 centimeter width. And the platform takes around 3 minutes to cross the level. So during navigation, and the platform is moved at its lowest height to get a stable posture. For avoiding the wall collision, we implement a fuzzy-based controller, and two IR sensors are mounted on the each side of the platform, and that measures the distance between the wall and the trunk body. Any deviation in this distance activates the controller to act on the error and move the platform in the middle of the drain to avoid the wall collision. And we also observed that there is a slight deviation from the middle line, which is mainly due to the rough surface of the drain. We also used LiDAR sensor to get a map of the drain, but that work is currently in the progress. And currently, we are also working on the robust controller design for obstacle avoidance, and we are going to implement the torque-based controller for each leg, and we are going to work on the drain mapping using the LiDAR. So I would like to acknowledge the funding agency once again, and Professor Mohan Rajesh Ellera as a principal investigator, and all my lab mates of Roll Lab Singapore. So these are the references. You can refer the paper for if you need more details. Thank you. If any questions, let me know.
Host, they can ask question, participants.
Thank you, Dr. Riz. It was very comprehensive presentation. How a robot can deploy in the drain environment and conduct to test this kind of frogging and any stagnant water detection. Yeah, it was very interesting, especially all these technical aspects, and you are this then the model analysis, especially the wheel kinematics, very strong presentation. So let me invite any question from audience, please.
May I put a question? This is Christian from PRIST.
Hello.
Dr. Parveen, I have a question.
Yeah, please.
See, you were telling about the removal of stuff when drainage gets clogged.
Yes.
Now, supposing the drainage, it is so much clogged, it has got so much clogged, there is no room for the robot to even travel forward. Now, that is when we say it's a serious clogging.
Sorry.
How do you tackle this kind of?
Yeah, so currently we are focusing on the main platform, and in the future we are going to work on designing a clog removing structural design. So that process we are working on that. So we need some external manipulator which can be attached to the platform to remove the clogs. So so that is the idea behind that for the clog removal.
Yeah, because the clog has got to be removed first before the robo could travel into the drain. That is important.
Yes, yeah, yeah.
Yes, I think that an extra manipulator is required to be added in that
Yes,
case.
yeah.
Thank you, Dr.
Um,
Parveen. It was very, very informative.
Thank you so much. Thank you all.
hello. Uh, hello.
Hello.
Is there any
Ah,
other question from audience, please?
Madam, I'm Yolini, ma'am, mechanical department.
Hello, yes.
Madam, good afternoon, ma'am.
Good afternoon.
I have one more doubt, ma'am. How does can a robot go and clean it, ma'am?
Sorry, can you explain again?
How does can a robot go and clean, ma'am?
So
Like,
actually, currently we are focusing on the label shifting application. After that, we are going to implement one manipulator for the cleaning application. So which work is under progress. So once you have a manipulator which is attached to the platform, then you can that can helps in the cleaning or clogging removal.
oh, okay, okay, okay. Thank you, ma'am. Thank you. Okay.
Okay, welcome.
Thank you, ma'am. Thank you.
Okay, thank you all.
Okay, thank you, Dr. Rees. Let me invite the next speaker. So Professor Sharath Kodagoda. He's from University of Technology, Sydney, Australia. Today the topic is robotics in civils. Let me introduce a little bit more on Professor Sharath Kodagoda. He's the Vice President of the Australian Robotics and Automation Association and UTS Ambassador to W Smart Country Network. He's a director of the UTS Robotics Institute. He has contributed equally to teaching and research and recognized the Australian Teaching Award UTS Medal National Research Awards. His broad research interest is to develop robotic solutions for humans to safely and effectively carry out dirty and dangerous tasks. So please join our webinar, Professor Sharath Kodagoda. Please, for you now. Thank you. Professor Sharath?
Hi. Can you hear me?
Yeah, we can hear you.
I'm trying to
You can share the screen.
screen.
Third button from left.
Yeah, it is there. It doesn't connect for some reason. So all the access given to me for sharing, it's trying to connect, but it can't.
You are the presenter, sir. Yes, you can share. And select the third button from left.
Yeah. That's the one I'm trying.
Sure.
It tells me something else. Is your screen? Okay, presentation.
Either you can share your whole screen or just the PowerPoint slides.
It's a PowerPoint slide. I have dual screens. Maybe that's the problem. Let me see.
Sure.
Allow. It doesn't. Okay. Let me get rid of the dual screen and see. It's a bit of a problem, isn't it? Okay. Mm. I'm not sure what is happening. It says we can't display your share content. Make sure you are allowed permission to share the content. Is the full access, sharing access is given to me?
Yes. We will reassign.
Reassign. Let me reassign.
Yeah, okay. Still not. There's something wrong. How can we do that this then?
Can you log out and log in once again? Basically, close the window and then please log in again.
Okay, just one sec. There's one more thing I will try. Something happened?
Yes, happened.
It's magic, isn't it?
Yeah, now we can see your screen. Yeah.
Okay, all right. Sorry, there was a little bit of, is it okay still?
Yes, yes.
Yeah, okay. All right, yeah. Okay, sorry for the little bit of a technical glitch. There was so many buttons that I had to press to get it sorted out. So thanks for bearing with me. Okay, I will, thanks for the kind introduction. Without taking much time, I will move to the slides and say who we are and about robotics in Suez. So I'm from the Center for Autonomous Systems previously, and now it is called the UTS Robotics Institute. We started in 2003, and we have been doing so many things in robotics areas. We have been in media for many aspects. And then we have grown into around 100 people as researchers in the institute now. We have connections with many major universities, and we are working with them as joint research centers or collaborations. Our graduates are working in the MIT, Michigan, Amazon, Google, so on and so forth. So it's a relatively well-established center. What we are doing is in different areas. These are the engagement themes that we are working on. We are very successful in the infrastructure maintenance and infrastructure robotics. That is the topic that I'm going to talk about. I'm not going to talk about all the things relating to what we do. We have been doing infrastructure domain, bridge maintenance, bridge inspections, and then tower inspections, underground water pipes, underground sewers, so on and so forth. But today's talk is mainly on the underground sewer pipes. So this is the lab that I have originated few years ago. It is called the iPipes lab. What we are doing is driving innovations in underground infrastructures to make social industry impact. So that's what we are looking at under this particular lab. This is one of the labs in the Robotics Institute. Okay, today's talk is going to be on this. So as you can see here, this is not a good picture to look at. And this is a real situation. So this is this was happened in Dhaka, Bangladesh. And what happened was there was sewers were clogging, and one of the ways of removing that clog is for people to go in there. And you can see that that is really without any PPEs. So this is not the best job, or this is I considered as one of the worst jobs people do. So the thing is how we can get them out of these, or provided them tools to do this better. So in the Australian context, the situation is not that bad. When we look at here, we have over around 150,000 kilometers of pipes, underground pipes. Still, all major cities, including Australia, are facing the old infrastructure, and these are multi-billion-dollar assets. When pipes burst, you might say that there are a lot of water going out, like making fountains and so on. But if a sewer breaks, that is going to sting, and that is not a good experience. So I'm going to show you a real sewer deployment by a human person. Basically, one of my researchers went inside the sewer because we have to test those things. We have to understand. We have to appreciate what is out there. And I'm trying to take you to a sewer with me here, just to give some idea about what are we talking about. So it's not the best place to be in. It's dirty, and the water is not that clear. And then it's pitch dark. And then there are other.
The slides are not changing. Dr. Sagar, the slides are not changing.
Is it?
Yes. I don't know whether I'm seeing it.
You can't see the video?
No, the presentation, no.
Oh.
The slides are not changing. I'm seeing only the first slide. Maybe others can tell us. Ms. Satyan, you're there? Ms. Satyan?
How is it now?
I'm not seeing the second slide. Only the first slide I'm seeing. Yeah, slides are not changing. Slides are not changing.
Okay.
You have not gone on to the presentation mode.
Okay,
We are seeing the first slide.
That's a bit strange. Let me
It
see.
is only your photograph and the first slide.
Oh, I see.
Yes.
Let me see what's going on there. Can you see it now? Same?
No. The first slide, yeah. First slide I'm seeing. Yeah, now it is changed. Now it is changed.
Now changed?
Yeah, now changed. Yeah.
Now is it changing?
It is changing. Yeah, it is changing.
Okay. All right. Yeah. Okay. I will keep this. Let me see the slide. Is it changing?
It is changing now. Yes.
Okay.
Yes.
All right. Okay. Okay. Yeah. So apologies for that. Okay. So this is what I was showing before about the thing that what we don't want to see. This is the sewer entry. Okay. I will show you the other video considering the time constraint. You can see the video now, right?
Robots and sewers wide. That's the slide we are seeing. It's a photograph. Video hasn't come.
Okay, right. So maybe I can't do the PowerPoint. Is it changing now?
It is the same slide.
It didn't change.
It didn't change. Robots and sewers wide. Yeah, now it is changing. Sydney water sewer. Sydney water sewer. Yeah, it is changing now.
Is it changed?
It is changed. Yes.
It's changing, sir, now.
Now?
Yeah.
Yeah. Okay. Can you see this video now? Is there a video?
Video not coming.
Oh my goodness. Yeah. I don't know what's going on here. Okay. Can you see it now?
Yeah, we can see the screen.
Yeah. Now is it changing? No? It doesn't change, is it?
Sir, we can see only your screen.
Only my screen. So you can't see the PowerPoint?
Yeah, we can see the PowerPoint, the robots in civils.
Yeah. Is it changed now? No.
You are trying to play your video, right?
No, no, no. I was just going to the next slide. It looks like you can't see it.
Yeah, we can see your slide. You please go ahead.
Can you see the video now? No, isn't it?
No, the video is not playing.
This is not good.
In fact, the video is not opened. You are still trying.
Is it? No, no, it is playing it here.
Oh,
So
is
now
it?
the video,
Okay.
video is playing here. You can't see it?
No, we can't.
I'm not sure what is going on there.
Maybe you can go ahead with the next slide, and then we can try again later.
Yeah, let me see. Can you see anything?
No, nothing.
Okay. Anything, any good?
We can see your slide.
Yeah. But the first one, is it? It's not changing? It's not changing, isn't it? Okay, what I will do is, sorry for that one. I think I'm mind of the time. So what I can do is try to, tell a few things about it. I don't think you will see the slides, but I try my best to explain what we have been doing.
Sure, sir.
Yeah, how many more minutes do I have?
You have still another 16 minutes.
16 minutes, okay. So one of the problems that we, the problem that we have in Suez is that after some time,
Please go to the presentation mode. Dr. Sarath, please go to the presentation mode. Go to the bottom. Go to the bottom right side. You have the cup. You have the cup symbol. Click it. It will go to the presentation mode. Then the video will play.
Okay, let's try that.
Yeah, at the bottom there is a cup.
Can you see
symbol.
now? No, the presentation mode. I am in the presentation mode.
You are in the presentation mode, but we are seeing only the overall PPT. You have not gone to the presentation mode yet.
Okay, how does that work?
Professor, you can put the full screen, then again try the video. Maybe better.
No, yes, go to the presentation mode. That is at the bottom. The cup symbol is there.
Which one you are talking about?
Bottom of the PPT.
You're talking about the PowerPoint, is it?
Come to the bottom. Yeah, come to the bottom. Come to the bottom.
Yeah, no, PowerPoint. I am in the presentation mode.
Oh, I see. I see. But we are seeing only the overall slides.
This is very strange for me. Let me see what is.
Sometimes this happens.
I normally don't use the WebEx because if I have to go with the WebEx, the client I need to install, and I'm working from home and I couldn't get it sorted out. So I'm using the web interface. It gives me this trouble.
I think it is okay, sir. You can go ahead with your slides, whatever mode you can.
You please proceed.
Yeah.
Sometimes this will happen. Not a big deal. We are clearly seeing your slides.
Yeah. So you can see my
Video
slides, is
also
it?
was playing.
Hmm?
We are
Sometimes
seeing.
video also was playing. Okay, somehow missed. Anyway, you proceed, please. Very
Yeah.
interesting.
Yeah. I will proceed anyway because I think I am mind about the time. What I can do is after this, maybe I will send you the slides so that you can have a look later. So given the time, I will just give some overall view of this. You will need to imagine though how it works.
The very important thing you are bringing. Please proceed.
Yeah. Okay. All right. So when we look at the sewers, we flush things in the sewers. The industries send things to the sewers. So that includes the sulfates. So that sulfate is interacting with the bacteria over there and convert that into hydrogen sulfide. And that hydrogen sulfide is again interacting in the gas phase, interacting with the bacteria and convert that to sulfuric acid, which basically attack the concrete and make it softer. So that is the process. And what we are trying to do is to estimate the soft part of the concrete and then to estimate how much hard part of the concrete is left. So that is what we are trying to do here. And there are several videos here, which unfortunately I won't be able to play it for you, which could have been great if we got the opportunity to do that, because seeing is believing. So we had many sensors we tested. The whole idea is to see whether we can develop some sensing technologies which can non-destructively detect the soft part of the concrete as well as the hard part of the concrete, and also about the mapping the tunnels in a three-dimensional and reconstruct it. So in order to do that, what we have developed is robotics device, which is basically a system which has many sensors. For example, we have ground penetrating radar. We have pulse eddy current technique in order to find what is inside the concrete. And the idea at the same time, we have some camera system in order to get the three-dimensional reconstruction happening in the tunnels. So one of the problems here in designing this is that the manholes that we can deploy these units are very small. So it is minimum, or the manhole size is 600 millimeter diameter manholes. So what happens so there is that our system need to be deployed through that manholes, which is 650 millimeters, but the sewers are bigger than that. The ones that we're looking at is 900 millimeters to 1.5 meters. So that needs some expansion mechanism within the robotics device so that it can touch. Other difficulties is about sewers are like us. It comes with all sort of shapes and sizes. So this device need to be expanded into different sizes. And also the sewers in some parts of sewer networks, you can't really shut down. So you can't shut down the water and then deploy any units there. The flow can be controlled, but you can't shut down. Therefore, what we decided to design was a floating device, floating robot. So floating robot which has extending arms, 3 arms, and also having all the sensors mounted on there so that while it is moving, you can take all the measurements in relation to CCTV or three-dimensional reconstruction of the sewers, as well as ground penetrating radar data and pulse eddy current radar data. And also we have the capability to drill if we need to. So that is kind of the platform. And this platform has many novelties. Because of that, a few weeks back, we won the most prestigious Australian Water Awards Research and Innovation category. This is a national awards, Australian National Awards. And we are now preparing to go for the International Water Awards. So this, I'm sorry that I couldn't show this. This platform and the data visualization, as well as all the data analysis part, is the main innovation in this particular project. So the most of the figures and more, I have many photos and videos to show in terms of the deployment of this in the labs, as well as deployment in the sites. We are working with the Sydney Water. That's a big organization. And the idea is that they have funded this project. And what we are doing is basically working with them, developing these technologies and testing them in their sewers. So I have another project that I'm leading, which is a huge project. We have over 34 partners, and it is over $25 million project, which is about designing sensors, and part of that is about designing sensors and robotic devices for the coatings and liners. What does that mean is that once we have identified, or once the water utilities have identified that the pipes are not doing great, they need to be intervened. One of the ways of intervening is to apply coatings or apply liners in the water pipes. So in this particular project, what my team is doing is to devise sensing and robotics technologies to do the condition assessment of the liners for quality assurance purposes. That means once the liners and coatings are done, our sensors and robots need to measure some quantities and make sure that it is within the specification. And also looking at long-term performance monitoring of those liners and coatings. So that is the part that we are doing. And in terms of that, if I only consider the sewers, there are two types that we are considering for coatings. One is called the CAC, calcium aluminate cement, and the other one is called the geopolymer. So we have been working on those materials to identify sensing technologies which can basically measure the quantities which are required by the water utilities. For example, once those coatings are done, they wanted to know what is the thickness of that coating. So we have been developing ultrasound-based techniques to measure that. And also in smaller pipes, these are good for the larger pipes, but smaller pipes, they might be using some liners, which is a spray liner or what we call CIPP. Then for those ones, people can't go in. Therefore, we use again robotic devices fitted with all the sensing, including ultrasound to measure the thickness, and then RGBD in technical terms, the camera system, so that it can reconstruct the three-dimensional view and take measurements of any defaults or faults in that any faulty sections and take measurements from that. So again, I have several videos here I wanted to share with you, but unfortunately couldn't. So the idea is that once we do the lab test, our approach has been, we have been doing simulations, we have been doing fundamental research, but one of the main things that we are doing is actually we wanted to see this technology is applied in the field. So we are very concerned about it, and in our plans, we have a major component in going into these sites. We deploy them in sewers and then learn from that, because at the end of the day, these technologies need to be available and usable in real scenarios. So the next phase of this project is we are now discussing with Sydney Water is about operationalization, which means once we have proven and validated these sensings and robotics in the sewers, the next phase is about how can we make it operationalized with Sydney Water personnel so that it can be used in real life. So that is where we are at the moment. I'm concerned about the time as well. That's basically what I have to say at the moment. Unfortunately, apologies for the technical problems, which I couldn't share this, the nice videos and the photos that I got. I'm happy to answer any questions if you got.
Dr. Sharath, you can please mail us, the organizers, the videos and photographs.
Yeah, I think what I can do is I will share that with you.
Yes,
some of the
we would-
videos I won't be able to share. That's the main problem, because this is part of the industry funded project, and definitely I think I should be able to share the PowerPoint presentation with the pictures in it. I think that I will do. So if there's any questions from that, I'm happy to answer from that point of view as well. Yeah, I know it is hard for you or who are in the audience to ask questions without seeing what this is, but happy to answer any questions if you have in overall.
What are the kinds of sewage problem?
Sorry, what is the question again? Hello?
Who was asking the question?
Hello.
What are the different kinds of sewage problem you listed out?
Okay, the main problem, which is for the water utilities, want to assess how the sewers are. So they wanted to rehabilitate before it collapsed. So one of the major problems over there is how can you find out how much good concrete left in the sewer pipe? So that is the main thing. So in order to do that, there are difficulties, because some sewers people can go in there because those are very big. Those are called traversable sewers. So in those sort of situations, what they need is a sensing unit which can be carried. So we have to develop one. The second one is about the smaller sewers. For them, people can't go in. So in these ones, how it is happening now is people are sending CCTVs. So what we have done is adding that other sensor suite so that it can measure that quantity, which is how much what we call intact concrete or good concrete left in that the pipe, so that they can estimate what is the lifetime of that particular pipe. That's the first problem. The second one is about when you put, when you identify it is not a good pipe, then you have to rehabilitate it. How you rehabilitate is using using coatings. So once the coatings are done, they wanted to do the quality assurance and also long-term, evaluate the long-term performances. So how could you do that is the second question.
Thank you.
Yeah.
Thank you, Dr. Sarath. Hello.
Yeah, all good. I can hear you.
Thank you so much for your presentation. We have our next speaker with us.
Okay, sure.
He is Dr. Srinivasan Venkatraman. He is an assistant professor in the Department of Design at Indian Institute of Technology, Delhi. He holds a PhD from Indian Institute of Sciences in Bangalore, one of the esteemed institutions in India, and a bachelor's in mechanical engineering with distinction from University of Madras. His academic interests are broadly in the areas of design, creativity, innovation, design theory, methodology, virtual reality, and new product development. He is a member of editorial board of International Journal of Design, Creativity, and Innovation. I am changing role as a presenter to Professor Srinivasan Venkatraman.
Okay, thank you so much for the kind introduction. I hope I am audible.
Yes, you are audible. You can please share your screen as well.
Yes, I'm sharing now. And then let me go to the presentation mode. I hope my screen is visible.
Yes.
Okay.
Screen is visible.
Okay. So without further ado, a very good afternoon or good evening or even good morning to whatever part of the world you are in. This presentation, okay, I'm an assistant professor in the Department of Design at the Indian Institute of Technology in Delhi. In this presentation, I'm going to talk about my investigation into checking the efficacy of using patterns to aid design creativity during the idea generation phase of conceptual design. Unlike the previous presentations, my presentation might have a slightly different flavor in the sense that I'm more interested in the design process. In other words, I'm interested in studying what contributes to good designs and bad designs, and then based on this understanding, try and improve the process in order to improve the chances of generating good designs. So please see my research in that context. The research that I'm going to present in the next 17 or 18 minutes was carried out when I worked as a postdoctoral researcher at the SUTD MIT International Design Center, located within the Singapore University of Technology and Design. This is part of a collaborative project where there were contributions from the Ministry of Defense of Singapore and generous funding from Ministry of Education of Singapore. Okay, so let me start with the motivation for this research. I mean, we all know that patents are some form of intellectual property that help provide the legal protection for the inventors, for their inventions, to prevent others from copying or yes. So patents and designs have been primarily used for identifying the state of the art. That is to understand what has been done and what has not been done in a particular field, in order to try and understand the infringements, if any, of a particular design to see if it infringes any existing design or not, and so on and so forth. So the advantage of patents is that they contain enormous information of novel and functional products and processes from multiple and diverse domains. So potentially, this is a very rich repository to seek inspiration or stimuli for design, especially in the early stages of design. But the limitations with patents are that the language in patents is essentially prepared by the lawyers. It's legal jargon, very difficult to understand for the designers and then to use them for designing. So that's one part of the motivation. The other part of the motivation comes from design creativity. So design creativity has been defined as the ability to generate outcomes that are both novel and valuable. So novel meaning something that is new, original, not seen like anything before, and valuable meaning how valuable is an outcome in terms of the problem for which it has been generated. How well does it solve the problem? And then researchers have talked about how when one combines knowledge from different domains, there is a better chance for producing creativity or improving creativity. And therefore, combining these, given that patents are a rich repository of information of products and processes from multiple and diverse domains, can we ask the question that whether patents aid design creativity during the ideation phase in conceptual design? So that's the broad question that we're asking. Now, in the next couple of slides, let me briefly introduce you to a couple of terms that will be very useful for you to understand the rest of my presentation. The first is what is called as analogical design. Let me define what analogies are. Analogies are similarities in attributes, characteristics, functions, behavior, and structures between two seemingly unrelated objects. So, for instance, what you see on your left is the nervous system of the human body, which was used to inspire or stimulate the neural networks. And the next image is that of the hydrophobic nature of the leaf of a lotus plant, which is used to inspire or design the surface of a wash basin or a water closet. And what you see, the final image is, of course, how the beak of the kingfisher, the way it fishes, it picks up the fish from the surface of the water without creating much disturbance, was used to inspire to design the nose of a Shinkansen train, the bullet train. Now, what is analogical design? So, analogical design is the process of identifying stimuli or objects in the source domain, which can potentially inspire designs that need to be solved in the target domain. So, one needs to first identify what we think are relevant stimuli. So, things such as the central nervous system, the hydrophobic nature of a lotus leaf and the beak of a kingfisher, and so on, and then translate it into a problem or into a solution that can actually solve the problem. So, for example, translating a central nervous system, how the central nervous system works into a neural network, and so on for the given problem at hand. So that's broadly what analogical design is. Now, in this slide, what I'm trying to show you is a technology map. A technology map is a network. Now, I'm showing the technology map as a network of classes of technologies. Okay, and the different nodes here represent the different technology classes. Now, what are these technology classes? Technology classes are used as classifiers for patents, to classify patents. Now, what do I exactly mean by that? So, let us consider one patent, a US patent, which is about the legged mobile robot. Okay, and also talks about the method of controlling the operation of the robot. So, this particular patent has been classified under International Patent Classification G06. So that G06 actually pertains to computing as part of the technology map. So what this technology map shows is the distance between the different technology classes based on the knowledge similarity between the different technology classes. So what it means is if two nodes are close to each other, it means that these two knowledge domains or technology classes are much closer in terms of knowledge and so on. So, and there are about 121 technology classes which are represented in such a map. And then I'll be using this map later. Now, the specific research questions that we are asking in this research are, what is the effect of using patents as stimuli for ideation outcomes, specifically looking at the design creativity of outcomes. So looking at novelty and quality of these outcomes. Just to help you recall, novelty is the degree of newness or originality, and quality is how well does a particular outcome or a solution solve a particular problem. Okay. And then the second question that we're asking is, what kinds of patents are really useful for design creativity? Again, we're looking at in terms of novelty and quality. So how did we go about so how do we go about answering these research questions? So there was a course in SUTD, in the engineering product development pillar. This course was called Engineering Design and Project Engineering. And one of the requirements of the course was to do a course project. Okay. And the objective of the course project was to design and develop a spherical robot for an application of the student's choice. Okay. In order to do this, there were about 105 students in the class who were divided into about 21 teams. And each team had about 4 to 6 members. and they followed a structured design process. So they started by defining what the problem is. In other words, what specific application are they going to target? Identified the broad needs and requirements of this problem, and then generate, evaluate, modify, and select concepts. And then from the best concept, they developed a prototype, tested the prototype, and then they demonstrated the prototype. Okay, and these are some images of the spherical robots that they developed as part of this project. And these are some photos of they demonstrating the working of their robots to the jury members. So there are all kinds of robots that could really roll on the floor, robots that could roll on water or swim in water, and then robots that could fly, and so on. And these were developed for various applications. So these were recreational purposes. These had healthcare applications, defense applications, and so on. So that's one part of the project. That's the overall goal of the project. Therefore, the students took it very seriously, because the grades in the project therefore depends on how well their prototype performs during the jury. But what we used in this project was the conceptual designs from what the students generated. So what we did was we divided the students into 3 groups, because I told you there were about 105 students, divided into 35 each, and we gave them different kinds of stimuli. Okay, one kind of condition was to give them no patterns as stimuli. The next category got 121 more cited patterns, and then the next group got 121 random patterns. Where does this 121 come from? These come from the 121 technology classes of the technology map. So one most cited from each technology class was given, and again one randomly chosen patent from each technology class was given to the students. And then the students were also allowed to use other resources such as books and internet in order to supplement the information that they find from patents. Okay. Now with these, they were asked to generate conceptual designs of spherical robots for their specific problem. Okay. So just to clarify, even though this was a team exercise, developing the prototype was a team exercise, but for the conceptual design part, they were asked to ideate individually, and that's why we could divide them into 3 different groups. And then we looked at their conceptual designs, the kinds of sketches like these, sequence-based sketches with some amount of detailing. And then we as researchers, we looked at novelty. We analyzed these designs and looked for novelty and quality. So novelty was assessed by an expert. And then he rated novelty in a scale of 0 to 3, where 0 stands for no novelty and 3 is for high novelty. And quality was assessed using a particular formula here, where F stands for functional requirements, W stands for working principles, and S stands for structure. What it tries to do is it assesses how well does a design fulfill or fulfill the requirements for which the design is developed. In other words, how well does a particular design solve the problem for which it has been generated. And this has been assessed in a scale of 0 to 2, where 0 is for low quality and 2 is for high quality. Okay. Now, with this as a basis, we started to analyze. We wanted to see what patterns emerge from these. So in total, there were about 226 conceptual designs that were generated, unique conceptual designs, I must say, and these were analyzed. Okay. So just to show you some statistics from that. So most of the concepts that we see were generated with patterns. Okay, 61% of the concepts were generated with patterns. And then because we gave the students some degree of freedom to also use other kinds of resources, what you find here are the different degrees of simulation. So without any stimuli, they generated about 4% of the concept. With just the other resources, they generated about 35% of the concept. With patterns only, they generated 10%. And then with patterns and combinations with other resources, they generated about 51%. And then we looked at what kinds of patterns are being used to generate the concepts. And interestingly, we find that a majority of the concepts are generated using patterns that the students identified by themselves. So these were patterns that were other than what was actually given to them, apart from the 121 most cited and 121 random patterns. And therefore, the students, we found that developed some kind of a liking to or an attachment to patterns. Okay, now comes some of the interesting findings. So going back to the research question. we wanted to see what effects do using patterns have on the novelty of the concept in terms of how new the concepts are, how original the concepts are. So what you see here is a bar graph that shows the average novelty of the concepts generated without patterns and with patterns. Even though the average novelty with patterns is slightly higher, but this was not significant enough in the t-test, where the significance was about 31%, which is not, which is very, very low in terms of the error percentage. And this is a more interesting graph. Okay, so what we are now doing is trying to see what is the average novelty of concepts generated with different degrees of simulation. That is, without any stimuli, with just the other resources, with just using patterns alone, or with patterns and other resources in combination. And what we consistently find is that novelty that is generated with some form of a knowledge, could be other resources, could be patterns, or could be patterns and other resources, is significantly higher. When I say significantly, it is statistically significant than generating without any stimuli. Okay, so that was one interesting thing for us. So stimuli in some form or the other, it seems to be helping at least in terms of novelty. Okay, then we looked at the effects on the quality, which is one part of the first research question, if you remember. We looked at quality, and then this shows the quality, average quality without patterns and with patterns. So what we found was that the average quality of concepts generated with patterns. So quality again meaning how well does a particular solution solve the problem for which it has been generated. That is, it's found that the average quality is significantly higher than average quality generated without any patterns. Okay, so that is an important finding for us. And then we again looked at the average quality generated with the different degrees of stimulation. Again, with no stimuli, with other resources, with patterns alone, and with patterns and other resources. And some more interesting findings that the average quality with some form of a knowledge, be it other resources, patterns, or patterns and other resources, were significantly higher than average quality without any stimuli. And another interesting finding was that the average quality of concepts with patterns and the other resources is significantly higher than average quality just with the other resources. And therefore, patterns and other resources in combination seem to be improving both novelty and quality of concepts. Our next question was to look at what kinds of patterns are really helping generate novel and quality designs. So what this bar chart shows you is the number of patterns or the frequency of patterns used to generate concepts of different grades of novelty and quality. Okay, so what you see here is that a majority of the patterns are used to generate concepts of either medium or high quality or medium or high novelty. That's primarily in that rate. Okay. Just to show you some background of the results that I'm going to show you from now on. Excuse me. So what this bar graph again shows you is the frequency of the patterns used to generate concepts across the 121 technology classes that I showed you from the technology map. So what you see on the left are the technology classes that are much closer to the domain of spherical robots. Okay? And what you see on your far right are domains that are much far from the domain of the spherical robots. Okay, so there are domains of spherical robots that one can ascertain from the technology map. And what we here again find is that majority of the patterns are sourced from technology classes that are much closer to the spherical robots. So therefore, it could be that the students could easily find the link to the problem that they were trying to solve, and therefore they could pick relevant sources of information from these. Okay, I'm not doing very well in terms of time, so let me quickly try to show you the remaining findings. Now, what I'm trying to show you here is the average proximity of patterns that have been used as stimuli to the problem domain versus the average novelty of the concepts, as to how the average proximity of a stimuli has influenced the novelty of concepts. Okay? What we consistently find is that as novelty increases, the proximity goes down. In other words, what it means is now if you source patterns from very different domains, from domains that are far from your domain of spherical robots, then there's a good chance that you will develop a novel design. And that's what I'm trying to say here, that high novelty concepts use patterns from far domains. Okay. I mean, even though a lot of researchers have talked about this anecdotally, I mean, there's not been any empirical proof. So this is one of the first important findings. And now with this graph, what I'm trying to show is the distribution of the average proximity. How does the average proximity of the patterns from the problem domain vary with the quality of concept? Okay. So what we find here is that mostly that as quality increases, right, the proximity also increases. In other words, what it means is if we keep sourcing patterns from domains that are much closer to the problem as opposed to being far, there's a good chance that you might end up with the concept of a high quality a concept that will really solve the problem rather than being totally out of the box. Okay. Now, quickly moving to the conclusions. So what did I try to show you in the past, 17, 18 minutes or so, that patterns individually or in combination with other resources have been found to be effective for generating solutions or concepts of higher novelty or quantity or quality, sorry. And then patterns from far domains can help generate novel solutions, highly novel solutions. In other words, novelty is directly proportional to the distance of stimulation. Third conclusion is that patterns from domains that are near to the problem domain can help generate solutions of high quality that are very relevant to the problem. In other words, the quality of a solution is inversely proportional to the stimulation distance. And the most important takeaway from this presentation is that patterns are more than just legal documents, and they can potentially inspire, develop the next generation of products. Now, with that, I'll finish and thank you for your attention. And then this is my email address. So if you need more clarifications on my research, I'm happy to share. I mean, we also published quite a number of articles from this research. So yeah, I'm happy to share them in case you find the research interesting. Thank you.
Thank you, Professor Srinivasa. It was like a very good talk for the teachers, especially those who teach design subjects, like from where to generate the idea and how to generate novel idea. And basically, the summary presented out of the real class sample from SUTD and the outcome of those ideation sessions, that which ideation was compared with, like if the students are given with a near design patent, then those ideas were generated, were ranked higher. So it was really a nice presentation. I would quickly ask participants to put their questions with, if they have any questions, they can please ask by opening the mic, or they can put type in the chat box. Hello.
Yes.
So I have one question.
Good afternoon, sir.
Oh, okay. Okay, please go ahead.
I am Kannan Mahadevan from PRIST University.
Yes.
Okay, good afternoon. Yes.
Sir, is there possible to file design pattern of special purpose spherical robo through drawing only with the 7 views and a perspective drawing? Is possible, sir?
I'm afraid it is not possible.
Okay, sir. Thank you.
Just the diagrams alone are not sufficient. I mean, this is a general rule for filing patterns that drawings alone are not sufficient. You also have to demonstrate at some level.
So it will be under conceptual, sir?
Sorry, say that again. Hello.
You have other questions? Please ask. Hello. We have still time, 5 minutes, so we can ask Professor Srinivasan the questions related to patent, because it is very relevant in the present scenario. we always look for now patents as well, apart from journal publication.
Hello, Professor. Good afternoon.
Good afternoon.
This is Karthikeyan Pasraman. So, we are mainly focusing on remanufacturing, which means we take already existing gears or something, and we will do a special purpose machine. Can we patent that? What is the procedure to patent that?
I believe, I think you can patent. There's nothing stopping you from patenting your design. But again, I think the question that somebody might ask is that how is this design new?
Yeah.
In what aspects is it?
Up to today, there is no existing machines like that. So we have created one and manufactured, and it was successfully running till now. So can we patent that one?
Yeah, I mean, if you think it is new, it's not been done before. I'm not an expert in remanufacturing, right? So I cannot say if you will get a patent or not. But then, if you think it is new, please go ahead. Yeah.
Can you suggest some of the regarding that one? Can you give me some links or something?
I mean, you links to filing patents?
No, that I can find in online. But regarding already existing one.
So I mean, there are huge patent repositories. So I don't know. You can start with patents.google.com and just search using keywords to see if there are patents that are similar to what you're claiming.
Okay, thank you, Professor.
Professor Venkataraman, I have a question. This is Christy from PRIST University.
Hello, sir.
Sir, the slide that you showed regarding innovations with patents and without patents, I think without patents it was about 78, if I'm right. And with patents, the innovations, you have noted it to be 132 or something. Now, sir, what is the source for this information? What is it you want to convey through this? I just wanted to get your opinion on this.
So I don't know if you're able to see my slides. I don't know which slide you're referring to.
Yeah, it is the previous one.
This one?
No. Slide 12. Slide 12. Yeah, without patents, it was, I think,
in silent.
80 plus.
No. So what I'm trying to show here is these are n equal to 88 is the number of concepts generated without patents, and 138 is the number of concepts generated with patents. And so the average novelty here, yeah.
So the novelty you mean to say, if patenting is not done, novelty is not getting encouraged. That is the point you want to drive home, sir.
No. What I'm trying to say here is that patents are with patents can be used as stimuli, right? So let me just go back to the slide on analogical design. Okay. Now
that's a stimulus you want.
Yes, patents are being used as stimulus here.
Okay. Yeah. Please go ahead, sir. Kindly explain this one.
Yeah. So this is what we are trying to say. That until now, patents have been primarily used for checking whether my design is infringing or not, or whether a particular design, what has already been done in this field. But then we are taking a step further to say, how about we use patents itself for stimulating? Now, for instance, I'm working in the domain. So let me just go back to this slide. Okay. Are you able to see the technology map? So, for instance, I might be thinking of a robot. Okay, a robot, and then trying to work using robot as a land vehicle. This is B66, for instance. So I can think of a patent, I don't know, for example, from fuels and lubricants. Okay.
Yes.
And then try and see, for instance, can I get inspired by how a particular lubricant flows? Okay. And can that be used as an inspiration for me to develop a new kind of a motion for a land vehicle?
Okay, fine.
So that's what we're trying to do here. And what we're trying to do here, I mean, and then because this is something that I should have done. So for example, I'm working in B62, say. So if I'm taking a pattern from say B61, which is very close by, then the chances of novelty is very low because these are very related to each other in terms of knowledge. But it will help you with quality because you'll be able to identify solutions that will work for you. Okay. But now if I use a patent from a domain that is very far, say, I don't know, for example, information storage, making that link might be tough, but then the chances of novelty is quite high.
You're right. Thank you, sir. Well, that was wonderful listening to your talk.
Yeah,
Just
thank you so much.
one more question. I think 1 minute we have. Which website or which source you have used to generate this technology map? Is there any website for this?
No. So there's a publication. I mean, this is one of the works from an earlier researcher from the same group. I can share the publication with you. So if you can please send me an email. My email address is on the last slide. So please send an email and then I'll share the publication, which you might find relevant.
Sure. Thank you, Dr. Srinivasan, for the nice talk on patents. We have our next speaker in line.
Thank you.
Mr. Satyan will introduce. Thank you so much. Bye.
Hi everyone. Hi everyone. Let me introduce the next our speaker, Dr. Timo Rosenberg. Dr. Timo is an experienced R&D and commercial manager with a strong background in physics. Dr. Timo received his PhD in thermal engineering from the University of Utrecht, Netherlands. Timo has overseen the development of numerous robotic products at Demcon and is currently business unit manager for the business of Demcon Robotic Systems. Okay, his the topic today is artificial intelligence in robotics. So, Dr. Timo, the mic hand over to you, please. Dr. Timo?
Here we go. Yeah, can everybody hear me now? Okay. Can you see my screen as well?
Hi, Dr. Timo.
Yeah. Can you hear me and can you see my screen?
Yeah, we can hear you now, and we can see your PowerPoint slide as well.
Okay, that's great. So let me start by thanking the organizers of the conference for letting me speak, giving me this opportunity. My name is Timo Rustenberg. I'm the business unit manager for the robotic systems that we develop here at Demcon. So I'll start introducing Demcon a little bit, tell you a little bit about what kind of company we are and what we do. And then I'll go a little bit on what we've done on AI in robotics, which I find very interesting. So I like talking about it. So that's why I've chosen it as a topic for this conference. So Demcon is essentially mainly a design house for complex mechatronics. So we've been doing that for almost 27 years now and quite successfully. So Demcon started in 1993. It was founded by two engineers from the university that I studied as well. And now, 27 years later, we're about 700 employees. Most of them are engineers. And what we do is we develop very complex mechatronic solutions for our customers. We're doing that based out of the Netherlands, so a little country in the northwest of Europe. We have five actually different locations here in the Netherlands. Our headquarters is in Enschede, where I'm located right now. Then we have one office in Germany, in Münster, and we have an office in Singapore, which is just 2 years ago we opened that. But we're being very ambitious, so we're actually looking to expand to different countries around the world. What we do is, like I said, we develop technology. We have a big passion about technology, about difficult design challenges. The type of people that work here at Demcon are people who enjoy a tough challenge. They get this sort of glitter in their eyes when somebody tells them something is impossible. We've a very strong dislike for the apparently correct solution. Very often when a client comes to us with a problem, they'll already have a solution in mind, and it's our sort of natural way of working to start by asking why. Why is this your problem? Why is this the solution you're looking for? Are there no alternatives? Is there nothing better that we can think of? We're very much driven by tangible results, so we really want to build something, make something that works, either a prototype or a machine, a production equipment, something like that. And we tend to do that in partnerships. We know a lot about developing technology, but we don't necessarily know everything about the domain that our client is working in. So we tend to work very closely with our clients. We're not the type of company that will take a project and then you won't hear from us for half a year and then we come back with a result. Typically what will happen is we take on a project and we'll come back 2 weeks later and say, hey, we've got this in mind. What do you think? And then keep that as a sort of an interactive way of working with our customers. So like I said, we develop mechatronics. We do that in a number of different fields. So we've got 4 different business units where we do development of mechatronics, high-tech systems, which concerns mainly with semiconductor industry. So we develop a lot of technology for the semiconductor industry, mainly the front end side of that industry. We do a lot of work in medical field, so we develop medical devices, medical robotics, diagnosis equipment, things that can be used in an operating theater, that sort of thing. We develop robots, which is the business unit that I'm responsible for. Anything that moves, floats, swims, drifts, flies, we develop that, and that's my business unit. And then finally, we have a business unit that's concerned with optomechatronics. So developing optics, developing custom CCD chips, and developing software for optics for optomechatronic systems. Besides the actual design house, so the actual R&D departments that we have in the company, we've got a bunch of subsidiary companies and specialized departments in different fields. So we have departments specializing in industrial systems, so that's production automation. We've got a department, actually an own company for doing production, so anything that we develop, we can also produce in larger series. We have groups specialized in doing simulations, heat transfer, fluid dynamics. We have a group specialized in cryogenics. We have an animation studio, which is actually very relevant for the rest of my talk. And then we've got a whole bunch of OEM companies where we produce our own products. So we've got a product line of mainly medical devices that we developed over the course of time and that we're now marketing ourselves. Basically, what we do is we're a partner for development, and we cover pretty much any stage of development. So we can start from essentially a blank sheet of paper with just a great idea and go to a prototype or a proof of principle. We can build and test the prototype, and we can go all the way to series production. We have customers who come to us, they already have a prototype, and then they hire us to go to production. We have customers who come, they have nothing, and they just want to go to a prototype, and then they take it from there. So anything in between. So very, very flexible. And our way of working is that we get paid for the hours that we put in, and then that's it. All of the IP, everything we develop goes to our customers. So we don't own any of the IP that we develop for our customers. Our customers pay for the IP, they get it, and then they can market it and make money on it the way they want. So that brings me to the actual content, the core of my presentation, which is on AI in robotics, or at least what we've done with AI and robotics. And I'm going to start with just a really, really simple introduction. Probably most of the people in the audience will know everything about AI, but I just do the small introduction anyway, just to make sure that we're all talking about the same thing. So let's say we've got a robot and it's got two sensors, and based on the sensor output, I want the robot to either turn left or right. Now, if there's an obvious relation between the sensor outputs and whether I want it to turn left or right, I can just simply program a relationship, an empirical or a logical relationship between the sensor outputs, some sort of function that takes sensor outputs 1 and 2 and decides whether it turns left or right. It's quite simple. But if it becomes more complex, if the relationship is more complex, and if it's harder to quantify, then one of the things I can do, one of the approaches I can use is actually using deep learning. So I can actually let the robot itself decide in what cases it will turn left and in what cases it will turn right, based on a whole bunch of examples that I'm giving it. So different example. Let's say I want a robot to recognize something. I can use vision algorithms. In this case, I want to see if I can teach a robot to recognize the difference between a daffodil and a tulip. I can use a traditional algorithm. I'll take the image that the robot sees. I'll apply some filters, come up with some sort of mathematical formula that describes, what is the shape of a daffodil or what is the shape of a tulip. And I'll probably get a pretty nice result. The alternative is saying, well, I'm going to use AI. I'm going to use deep learning neural networks. So I take the data that I have, I put different filters, different scaling factors over it, put it in a neural network, apply all sorts of mathematics. And what I do is I make the layout of my network in such a way that all of my input data, which is all the pixel values of my entire picture, they all get scaled down to just two numbers, value 1 and value 2. And I'm calling them the daffodil value and the tulip value. And what I do is I fill this network with random numbers. I feed a lot of data that I know what the result should be. So I have pictures of daffodils and tulips. I feed that into my network. And for every picture, I find out whether it correctly predicts it's a daffodil or a tulip or whether it's wrong. And initially, it will be 50-50. It will be either correct or wrong because essentially it's random what it's saying. But what I can do is I can start adjusting all of these values in my network to reduce the error. So I keep adjusting it and I keep adjusting it until the result is acceptable. And so essentially what I'm doing is I'm letting the computer or the robot decide what aspects of the initial data it thinks it's important and to keep in mind in order to decide whether it's a daffodil or a tulip. So let's go to some more real-world applications of that. One really great example that I always like to show is something that Princeton did on teaching a robot to throw things, which is something that's really, really difficult to program. And what they did is essentially they used trial and error. Give the robot ample opportunity and time to practice throwing, and it will go wrong many, many, many times. But the annotation comes from giving it a reward for a good result or punishment for a bad result, which means the robot will essentially create its own training data. If it does well, it'll be happier. If it does badly, it'll be sad, which means it'll try to do better and better. And it will actually get better over time. And you can actually see from this result that it's gotten really pretty good at it. They did a test comparing the robot to the actual staff in the lab, and the robot was actually better at throwing things than the staff was. So really great result. Now, in this example, the data that they use to train the robot is data that the robot gathers itself, and that's not always possible. So I've got a different example. What if I want to teach a robot to pick a strawberry? It's going to be very difficult to get a robot to practice picking strawberries. How many strawberries do we need to destroy before the robot gets good at picking a strawberry? What strawberry farmer is going to allow me to practice or allow a robot to practice in their farm? So I need to find a different way for a robot to train to pick a strawberry. But I need labeled data, right? I need data that will tell the robot, this is a correct strawberry, this is a wrong strawberry, this is the correct location, this is the wrong location. So where do I get the labeled data? And one of the ways to do that is to just take a lot of pictures and get an operator to label them. Say, here's a strawberry, here there's no strawberry. But there will be some error in the data itself, because either the operator can misclick, or it can be confused on how ripe is a strawberry. How hard is it to quantify? So the approach that we use here at DEMCON for this type of problem is to create synthetic training data. So what we do is we define a scene using a very limited number of parameters, and we can vary the parameters and it will change the scene, and that way we can make random but very specific permutation where the annotation is absolutely perfect, because we create it. We know exactly what's in the data, and we can tell the robot exactly what's in the data, and so we know that there will be no errors in the data. And one really good aspect of it is that we can create the rare but crucial exceptions. We can create them and actually use them for training as well. So things that rarely happen in real life, we can actually make them happen quite often in our synthetic training data, and train our robot to cope with these rare exceptions as well. And once we've set this up, we can generate a near infinite amount of training data and use that to train a robot. So if we go back to the strawberry example, this here is a picture of strawberries, but they're not real. They don't actually exist. We've made these strawberries. So we know everything about them because we've created them. We know exactly where they are. We know exactly how ripe they are. So we can actually provide the robot with the data as it would see it, and then supply it for training with metadata as well of exactly how far away are these strawberries from the robot, where are the strawberries, is it there or is it not, and how ripe are them. And actually use this information to train a robot to select which strawberry it's going to pick first and which ones it's going to pick last, or which ones it's going to leave. And the great thing about having a method for creating these synthetic strawberries is that you can make an infinite variation of strawberries in terms of, for example, shape. I can just parameterize what the shape of a strawberry is and show my robot different variations just virtually.
Yesterday you wrote to Emmy, right?
I can also play with the ripeness of the strawberry. So because it's a model of a strawberry, I can make it any ripeness that I want. I can play with lighting as well. I can actually test different methods of lighting the strawberry and seeing, which way will actually get me the best results, and which way will allow the robot to pick the strawberry as best as possible. So different example. Let's say I want a robot to do some sort of inspection job and find defects. So this is an example of a product that we produce. It's a stainless steel product that we injection molded. And we produce a lot of these, and they have to meet quite high quality standards, specifically specific sides and surfaces. And currently we're doing these inspections manually. And some of the defects that we are looking for are actually really, really rare. So we've got very, very little examples. So it's very difficult to train a robot. So what we did here again is make synthetic training data for the robot to train on. So what we did is we made a synthetic model of this part, and then we add a defect, and we can parameterize this defect, give it a different size, make it grow, and we can actually tell the deep learning network where do we require high accuracy, what is the depth map of the thing it's looking at, where is the defect located, and how important is this defect? How bad is it? Is it gray? It's not that important. Is it very light? It's more important. And then we can vary with our model. We can vary the number of defects that we have. We can add any number of defects that we want in any location. And we can actually vary the size of the defects within the group. So I've got 4 the same size, but I can actually make one much bigger than the other one as well. And by parameterizing this way, we can actually generate pretty much an infinite amount of training data that we can use to train our robot and to actually find the defects. And again, we can vary, lighting conditions. We can vary that very easily. Last example that I have, pipeline inspection. If we want to develop a robot to inspect pipelines and autonomously navigate through a pipeline, through this sort of semi-structured environment, it needs to be able to make decisions. It needs to know what it's seeing through its sensors and use that information to actually navigate. So if we want to train our robot to know what it's seeing in a pipeline, we would need a lot of training data to train the robot and to make it cope with that environment. But it's very difficult to obtain training data from an actual pipeline, especially if it's, for example, drinking water. These are pressurized pipelines. If it's a gas pipeline, same problem. We can't just enter the pipeline very easily and acquire this training data. So again, what we can do is we can get a very small sample of training data and actually generate artificial training data in pretty much an infinite amount. So we make sure that they look alike very closely, and we can actually train our robot on synthetic data before it ever enters the pipeline. So in conclusion, we really strongly think that AI has a future in robotics. Some hurdles exist, particularly when you're looking for training data. But if you're using synthetic training data the way that we do, in many cases, it's a very viable alternative to real-life data, as long as you make sure that the synthetic training data actually contains those pieces of information that are important for the robot. So what we've found is that with synthetic training data, we can actually reduce the development cost and the time to market of very advanced complex robotics quite significantly. But you have to be very, very careful. If there is something in your synthetic training data that systematically, a systematic error that the robot will start recognizing, it will actually focus on that. So for example, if there's a white pixel in the top right corner of your synthetic image, every single time when you have a ripe strawberry, it will focus on that one single white picture and completely ignore everything that you want it to see. So you have to be very careful with it, and you do really have to check when you're using synthetic training data. So that's that's my time for the presentation. If there's any questions, feel free to ask me. If you have any other comments or remarks, then my email is on the screen as well. So feel free to contact me later as well.
Many thanks, Dr. Timo.
Yep.
Yeah, it was very nice presentation. And you started with the applications of mechatronics in various business units, and also the data processing using artificial intelligence, deep learning, neural networks, and how to pick the fruits properly. It was very interesting, and it was very informative. So is there any question from audience to Dr. Timo, please?
Hello, can you hear me? Hello?
Yeah, I can hear you.
Yes, so my question is like when you were mentioning on generating synthetic data, when we use CAD models, so from the CAD also we can generate those synthetic data, and but the lighting conditions, the real lighting conditions will vary. What I mean by CAD, say we need to detect some cracks, so we can generate and render that crack, but the natural lighting condition varies. When we go outside, the lighting condition varies. How reliable will it be to use synthetic data from the CAD model itself?
Yeah, so that's a very good question. So we're very lucky that we actually have an animation studio in-house that can create all of these variations in lighting. So you're absolutely right. Using a CAD model for training, we do the same thing, right? So the image that I showed you of the stainless steel part is actually a CAD model. But for the pipeline, the same thing, pipeline inspection as well. We just use CAD models of the pipeline, but our animation studio is capable of actually turning a CAD model into a photorealistic image of what the robot would see under realistic lighting conditions. So we're actually capable of turning that CAD model into something that looks completely like what it would look like under realistic lighting conditions, even if it's outside. But you're absolutely right. Is very important to make sure that if you're using synthetic training data, that the data that you're using is actually representative of what the robot is going to encounter in real life, including the lighting conditions as well. Yeah.
Okay, thank you. So the name of the software is Animation Studio itself, or any 3D Max or something. Which exact software you use for generating this animation?
Oh, that's a very good question. I'd have to check that. If you can send me an email, I'll check it for you because I don't know off the top of my head.
Sure, I'll check
It's
immediately.
our
Thank you
animation
so
studio
much.
that does it. I can check.
This is the question. If anyone in the participants, they are open to ask questions from Dr. Pratik as well.
Yeah, so please, if you just email me, I'll check for you.
Sure. Thank you so much. Yeah, my name is Mahavir. I'm from SUTD only. So I'll put the email to you. Thank you.
Hello, I have questions. I'm Lodin Huang from AUT New Zealand. It's a very interesting presentation because the data collection for AI is a very challenging issue. I found in your presentation that the sensor use is dominated by computer vision. Have you any results for other sensors, like a sensor for detection material properties, like a density, stiffness, or other things?
Yeah, that's a very good question. So you're absolutely right. So my presentation focuses very strongly on vision, but yeah, we can generate pretty much any type of sensor data. If we've got good examples, representative examples of what the measurements look like, you can pretty much generate synthetic data within bounds of reasonability. We've done it for ultrasound inspection for like wall thickness measurement and for crack detection, that sort of thing. We've done it synthetic training for data for a medical device, so it's for respiratory device where you want to detect whether the patient that is connected to the respiratory device is actually breathing in sync with the respiratory device. So you want to detect the asynchronicity. And up to now, all of these devices, they just have hard-coded programming where, endless of sort of trial and error get you empirical relations between, what the data looks like if the patient is breathing in sync when it's not. And we managed to generate very good synthetic training data on what it looks like if the patient is breathing out of sync with the breathing device. So yeah, we have experience with doing it for different types of data. But you're right, my presentation focuses mainly on vision.
Good. Maybe I need to I send an email to you. Actually, I have one problem. It's quite a challenge to non-destruction measurement of the density of the soft material, which is ultrasonic, doesn't work. So I think we need to come out with a sensor fusion scheme which is sensitive to the variation of density of soft materials, so that using AI technique, to quantify the density.
Yeah, that's an interesting. So yeah, contact me, send me an email. Let's think about it.
Yeah, sure. I will send you an email very soon. Hopefully I can give maybe some collaboration, or I need your advice also.
Sure.
Okay. Thanks so much. Yeah.
Yeah, no problem. I'll just share my email again.
Yeah, I record. Yeah. Thank you.
Oh, okay, great. Any other questions?
Hello.
Hi.
Yes, sir, I have a question. So how can you create a synthetic data from a very small sample data taken from real life conditions? Like, how can you mimic real life conditions?
Yeah, so like it depends on the sensor data that you're trying to mimic. But if it's on visual, really our animation studio, the guys they're just animators. They can create photorealistic images of pretty much anything you can think of. If you can describe it to them, they can make an image out of it. So it's a difficult question to answer. But a limited number of example pictures is enough for them to create some photorealistic example images. And once you've got an image, if you can parameterize it well, it's very easy to make lots and lots of variations and examples of it. But if you don't have any samples, if you don't have any examples, then obviously no, you can't make any synthetic training data. So that is it's the prerequisite for using this technique. You do need some examples. You can't do it just completely out of the blue.
So are there any predefined methods or like formula or models using which we can create synthetic data? Like the real life data is the variable for these methods or formula.
No, I don't think there's any sort of set methodology that they use. It just really depends on the situation, what kind of approach they take. No, sorry. Maybe in the
Thank you.
future, but not right now. No.
Thank you, sir.
I think my time is up. So I think I'll give the floor to the next speaker then.
Let me introduce the next speaker, Dr. Srinivasan Aruchami. He's a scientist in Robotics and Automation Division, CSIR, Central Mechanical Engineering Research Institute. He having a Master of Engineering degree from PSG College of Technology, Coimbatore, and also a Bachelor Engineering degree from Amartha Institute of Coimbatore. So welcome, Srinivas Aruchami. Now the mic over to you. Hi, Srinivas. Can you able to hear me?
Yes, we can hear you.
Yeah. And also you are able to share my screen? So you are able to
Yeah,
see
your
my screen?
screen is also visible. It's clear.
Okay. Okay, thank
If
you.
you can maximize the PowerPoint size.
1 second, sir.
You can minimize it. I do not know. Minimize the window. Or
Yeah, now?
yes, perfect.
Okay. So, good afternoon, everybody. And I am going to talk on robots for underwater applications. And we are from CSIR lab, and CSIR labs are across the India. You can see the labs which are located all over the India, and we are located in West Bengal. And CSIR CMARI is the only laboratory of CSIR dedicated to various fields of mechanical engineering. And we are my group is from robotics and automation, and we have done several underwater robotics applications, and this talk is exclusively focusing on underwater robotics. So here we have done a couple of images. You can see we have developed several robots for underwater field robots as well as some manipulators. And in underwater domain, mainly we are focusing on two technologies. One is AUV and another one is ROV. Yeah, underwater robot or underwater vehicle is exclusively a vehicle which goes under the water. If it is an AUV, is a robot which travels under the water
without requiring an input from an operator. That means I am not giving any command to the robot. This robot is already pre-programmed and we are deploying into the either sea or shallow water. It can able to perform its task and it will come back to the surface after completing the particular task. This task is pre-programmed and loaded into the system. And the another version of underwater vehicle is ROV. Remotely operated vehicle is a tethered system or a cable will be provided with the robot and which will command this cable will provide the power as well as commands to the robot. Okay. So next, what are the applications of underwater robot, underwater vehicle? So mainly the present day scenario, surveillance is a major application underwater vehicles are used and mines, lot of mining and as well as submarine warfare. See for example, recently we got a requirement from Government of India where we have to develop an underwater vehicle which have to go and sit in the seabed and whenever any unwanted signals or unwanted submarines is passing through the location, this vehicle which is sitting in the seabed have to come to surface and it have to give the information to the commanding center via satellite communication. So anti-submarine warfare and inspection and mainly oceanography. We know the entire world 1/3 of the location or 1/3 of the ocean is water. So oceanography is a major area where we can find what are the minerals are there. Lot of research we can do in oceanography. And see, we came to AUV. See, this is the first AUV which was developed in our CMERI, and this AUV this project is sponsored by Ministry of Earth Sciences. This can operate. This is AUV 150. 150 means that it can operate up to 150 meter of water, and it can do seabed mapping to collect oceanographic data like salinity, temperature, and conductivity, and various depths. Okay, and this can have a mission time of 4 to 6 hours and it's completely indigenously developed in CSIR CMERI. And we have developed the software as well as the hardware and designing the complete vehicle. And this vehicle can do an underwater mission as well as surface mission. During the surface mission, it will use RF communication and during the underwater mission, it will use acoustic communication. See, and you can see in this slide, the below is the complete vehicle model which we have given here, and there are three portions in this vehicle. There are three portions are there. One is nose module, and there are three sub modules. Nose module and middle module is a power module, and the tail module is a computation module. Yeah, nose module we can see there are two thrusters. The green in colors are the thrusters. There are lateral thrusters for giving a propulsion to the vehicle and the vertical thruster. The lateral thrusters are used to turn the vehicle either right or left, and the end there's one more thruster, there is a main thruster which can give the vehicle forward motion. And there are two vertical thruster, it will give the depth motion. And there are several other units. There are this middle unit is a battery unit where the complete vehicle the power is given from this battery, and there are lot of payload sensors as well as navigational sensors we used. And we can see FLS, forward looking sonar, camera, light, side scan sonar, and we have onboard single board computer SBC which can command the entire vehicle navigation as well as data collection. And we have an altimeter pressure sensor for finding the depth of the vehicle, where the vehicle is from the sea surface, how much distance this vehicle is now, and from the vehicle what is the distance from seabed. And INS is for inertial navigation sensor is for navigating the vehicle from one location to another location, and the DVL will give the aid to the INS. So this is the first version of the vehicle which we have developed, and we have tested this vehicle in the Bay of Bengal, Chennai coast, and the specification of the vehicle is given. The length of the vehicle is 4.85 meter and diameter of the vehicle is 0.5 meter. And this material we used to develop this vehicle is aluminum alloy, and the speed of the vehicle is 2 to 4 knots. Okay, and this was tested in the Chennai coast of Bay of Bengal, and we can see some of the. I can show you when we tested in the lake our vehicle. See, we are launching the vehicle. This is completely autonomous vehicle. I am skipping as we have very less time. So we are launching from the ship in the Chennai coast. The previous one demonstration was from the lake, and this was from the coast in the sea. There's another vehicle which we developed, that is AUV 500, which can go up to the 500-meter depth. This also tested in the port of Goa, and we have tested in March 2017 this vehicle 2 years back, and this can do surface operation as well as the depth operation. And the difference between that vehicle and this vehicle, in that vehicle there were lateral thrusters. For lateral motion we use thrusters, but here we used fins for turning the vehicle right, left, for the turning operation. And this here we use several other payload sensors like FLS, side scan sonar, and CTD, all these things. And we have used a separate information system which can tell where is the ship as well as where is the vehicle. So we can locate where is the present mothership as well as the vehicle, so that we can track the AUV where is the AUV, so that AUV will not come below the ship and it will not get damaged by ship. And the next development which was done in our group is that ROV, remotely operated vehicle. So the difference between ROV and AUV is that you can see that yellow color cable, which is the theater cable, or we can call it as a umbilical cable. In this cable, this complete power as well as the commands which the ROV have to do, we will be sending via this cable. And this vehicle we developed up to 500-meter depth, and it was tested in the Chennai coast. And we before testing in the Chennai coast, we have our own shallow water facility. We tested the vehicle in our shallow water facility, and we can get the live camera views which is under the which is coming from the vehicle with the help of this filter cable. So this is called as an umbilical cable also. And the material which we use is AI 6061 T6 for this vehicle design, and this is positively biased vehicle. And the recent development which we developed recently is the laboratory scale one, which will be helpful for a lot of students for the experiments, mainly for control algorithms and underwater image processing and other activities. So this was a laboratory model which we developed recently, and it has a 5-meter depth, and it have an endurance of 2 hours, and it have a payload sensor, depth sensor, altimeter, and camera, lights, etc. And this vehicle was tested in our own, and any students interested in this work, presently students are working on this for the PhD. You can see the vehicle maneuvering in our water facility. This very recently we developed this vehicle, and And next lesson of ROV, what we have done is that this is the requirement from one particular, mainly from Navy. So what they want is that they want a ROV with a manipulator, so it can able to perform some manipulation under the water. So we have designed this is what currently we are doing, and we are able to achieve some things, some fruitful results. You can see this ROV is designed with a manipulator. You can see a manipulator, and this was having cameras. Through cameras, we can able to grab some objects by sitting in the surface. And we use six thrusters. Two thrusters are vertical thruster for depth operation, and four thrusters for forward direction as well as turning purpose. And you can you can see this is the developed vehicle. Previous one was 3D model. This is the developed vehicle, and you can able to perform a manipulation underwater manipulation by for lifting a particular object. You can see this manipulator. This was indigenously developed by our laboratory. So this vehicle also almost ready, but we are in final fine tuning of this vehicle. This is with ROV manipulator, and mainly I am from software background, so I was in charge of writing software architecture for this ROVs. So this software architecture is mainly we wrote with the help of ROS operating system, with the help of ROS, and we used there are two control SVGs, which is one is sitting in the surface, another one is sitting inside the ROV. So we used Jetson NVIDIA GPU boards for processing these requests, and there is one all these sensors, INS, leak sensor, thruster control, camera node, all will be as individual nodes, which is connected with the ROS master node. From this ROS master node, all the commands will be sent to the particular node after taking the input from the different payload sensors. Mainly, these commands will be going for thruster as well as the manipulator motors. We have a manipulator as well as gripper. The manipulator can move, and gripper can able to hold the object. And this complete software is developed with ROS, and you can see there is a subsea control as well as surface control. Surface control will communicate with the subsea control, and all these node will publish their respective data to a surface control. And and we are doing some more work on manipulators. This was the one manipulator which was procured. But the thing is that what we do is that we will use this manipulator for a lot of our student project as well as you can see that here. This is on one project which we have done for using a real-time based processing. This manipulator or this can an arm when we are just throwing a ball, it can able to pick the ball. So you can see this one. So these kind of student project as well as center projects we are supporting, and this for as I thought there are a lot of students are in this webinar, so I have taken this one, and I'm coming to this one. Okay, so I want to tell some of the things which it is available in our institute that for the mainly for higher studies for BTech and MTech students, and we have 1 year postgraduate diploma in advanced manufacturing technology PGDA MT, and MTech in farm machinery, MTech in power engineering, MTech in mechatronics and design of machineries and equipments, and PhD for engineering as well as sciences, and IDDP integrated PhD program for 5 years with stipend from Government of India. And we are that is for students, and we are doing project training opportunities also for the students in our institute. 2 months summer training for third year students, and we host the students from students and faculties from Indian Academy of Science summer fellowship, and we have a lot of colleagues or fellow guides of Indian Academy of Science. So we can able to host those students and faculties, those who are selected to Indian Academy of Science, and they will get stipend as well, and they can execute their BTech and MTech final year projects in our institute. Thank you. Any doubts, any questions, or any queries?
Thank you, Srinivas Arichami. It was very interesting topic of this underwater robotics. Okay, we could see so many different applications. Okay, so is there any questions to Srinivas Arichami from the audience, please?
Hello?
Yeah. Yes, sir.
Hello?
Yes.
Yes, please ask.
Uh, Sir, actually, I am a student from Delhi Technological University, and we are part of team. I'm a part of team developing an ROV.
Okay.
So, sir, I've seen that and many student teams like us, and sometimes we are also facing problems waterproofing. Like the most common methods to waterproof uh, batteries are electronics using. But I wanted to ask, is there any other option? Like in your vehicles, you have shown that your vehicle can freeze a great. So, are you using any other way to waterproof?
No, we are using O-rings. We are using O-rings and as our sealant, and we are buying all underwater graded cables as well as the equipments. Yeah. And also, I forgot to tell you the complete system. We are having a wherever the place for leak. So we have leak detectors, and whenever any occurrence of leak, immediately vehicle will stop and it will surface the vehicle will surface to the either maybe sea or shallow. So we used to do first whenever we are designing any model or any vehicle. First, we will just check the leak whether any leak is there. If there is any leak, again we will open it and we will put an O-ring. We will put a sealant, everything properly. Again we will test until it's not getting a leak. Yeah, it's really good question. Leak is one of the major factor in underwater vehicles, so we should take care of those things. And there are a lot of cables, equipments are available which was exclusively for underwater. Yeah, some of the things we will make our own casings. We may not everywhere we may not use. See, for example, that small ROV which I have shown, it's not at all a costly one. Means we did not buy any underwater things. We made our own casings. As it's our mechanical engineering laboratory, we made our own casings and we used for maybe maximum you can go 5 meter, but you can test your own control algorithms. Mainly, you can test your own control algorithm for underwater real-time image processing. Those activities mainly for students.
And sir, I have another question. Like we were thinking of using ballast in our vehicles. So I wanted to ask, like which using thrusters or using ballast would give a
No,
better control.
it's the thrusters. Thrusters will have a very good control, very good control. And I will suggest you to use ROS rather than using some other thing. You use ROS from the day one. You start writing in ROS, and this was completely with ROS with Python code.
Thank you, sir.
Any more questions?
Any more question from audience? We have 7 more minutes, in fact. So, Mr. Srinivas Archana, I think not only the leakage, I believe the corrosion also will be another challenge, right?
Yeah,
When we are
yes, sir.
doing
Yes,
this
yes, yes,
underwater.
yes, sir. Exactly. That's why you have to what do you call it? You have to select the materials based on that. Based on that, either
Exactly.
titanium or aluminum alloy.
Yeah, aluminum alloy is one of the
Yes, sir. And titanium also.
titanium also. Yeah,
Yes.
correct.
So the that's
So
the
currently, this kind of recently developed robots, whether we use for any actual application, I mean, so maybe for
we
defense,
got we
for
yes, sir.
defense
Yes,
or any other
exactly.
application.
Navy. There are applications in Navy side mainly for surveillance.
Okay, great. That's good.
We are getting the requirements from government of India mainly for surveillance.
Okay. Okay. So,
Srinivasan?
yeah, please, sir.
Yeah, go ahead, go ahead, go
And
ahead,
one more
please.
thing, see, presently government of India also is supporting mainly for the projects which are related to defense strategy.
Yeah, correct. Because this is
And
more
also
interesting to defense
mainly
perspective.
and corona related activities. Other than that, government also is thinking before funding.
Oh, okay.
I have a query, Mr. Srinivasan.
Yes, sir.
Yeah, this is Christy from PRIST University.
Yeah.
Now, how do you go about, identifying the issues, problems? You may have to work on a project after identifying a certain problem. You just mentioned that most of your projects are defense-oriented projects. But certainly you will be taking up, issues where the societal matters can also
Yeah,
be considered.
definitely, sir.
So when it
Definitely.
comes to that, yeah, well, is there a systematic way of identifying the problem? Who brings it to the table? How these things are tackled?
There are two ways. Even we also will see DST DVT calls. We also will see. We will
Okay.
see what kind of calls are coming from government of India. That's first point. And second thing, see, as I discussed about underwater technologies, these
Okay.
technologies will be only strategic sector can take. Nobody else can buy and use it.
Yes, yes.
Underwater related. We are doing other projects that I did not discuss. Yes, we are doing some societal projects also, but as I
Okay.
discussed only underwater related projects. These are mainly related to strategy, and we also will observe by interacting with the panel members what kind of calls can come in future. So you can get some idea.
Okay.
You have in tie up with some government means institutions, so that you can get these are all the problems in future. They may give fundings.
Okay, okay, okay. Thank you. It was a very nice presentation. We enjoyed it.
Thank you for organizing. Nice, you know.
Any more question to Mr. Srinivasan from the audience? Yeah, we have 3 more minutes. Mr. Srinivasan, I think you just mentioned that you are also working for some COVID-19 related things. Can you explain maybe one or two
Yes,
things?
I see. You
Some,
can come to our website. There are a lot of things there.
I
Presently,
see.
they are doing.
Oh,
And I will tell you, they have done hospital assistive robot where you
oh
can
okay.
serve the medicines, food, and you can share the prescription. You can have a two-way means video conference between the patient and the doctor. And they developed something from a hospital office. Whenever any person entering inside the office, they will be completely screened via thermal scanner, and if they are not wearing the mask, immediately will be intimated. And if it is what do you call that? If it is if they are not having a mask, it will automatically dispense the mask. There are a lot of things they have done for COVID related activities. You can check it in our website also.
Okay, that's great, Mr. Srinivasan Alchami. Yeah, so then maybe thank you so much for your time presenting your very valuable information with all of us. Thank you
Thank
so
you.
much.
Thank you.
Okay, so let me invite to the next speaker. It's Dr. Jai Chandar. Okay, let me introduce him. Dr. Jayachandra is currently a senior lecturer with the School of Engineering at the Singapore Polytechnic. He received his PhD from Universidad Antona de Cruceros, Mexico in 2015. His research interests are in robotics, biomedical devices with an emphasis on solutions for geriatric issues. Jayachandra has over 20 years of teaching experience, including conducting workshops for public and private organizations. He applies the CDIO framework in his research and teaching. Okay, now I hand over the mic to Dr. Jayachandran. Dr. Jayachandran, please. Dr. Jayachandra?
Yeah. Are you able to hear me?
Yeah, you are audible. Now we can
Okay,
see your
okay, then that's great.
presentation
Screen.
slides. Good.
Okay,
Yeah, let's
is it
go.
in a full mode?
Yeah, it's now in full mode.
Okay. Good afternoon, everyone. Thank you for giving opportunity to share our research finding. In fact, I take this opportunity to share thank the coordinators for doing a wonderful job. And in fact, organizing a webinar is not an easy one. I hope this is going to be a first step for the near future to come. Okay, let me start with it. As I've been given a short briefing, I'm working at Singapore Polytechnic. Singapore Polytechnic is one of the oldest institution in Singapore, and we do have 10 different schools having its niche area, like a mechanical, school of computer science, school of electronic engineering, school of architecture, school of chemical life science. So I've been teaching in this school of electronics engineering. Basically, I'm a biomedical engineer. So half of my workload is basically designing medical devices and working onto the elderly care type of equipment. And I also apply for fundings for doing my research. Okay, without wasting much of my time, let me go into the project. Basically, my explanation is going to be, since I've been focusing on a geriatric, especially on elderly care, so I'll be going through the process, how we design and develop a therapeutic pet robots, and what are the pain points, and how do we really look into some of the problem statement and translate into business opportunities. Okay, my topic going to cover for this today is going to be on a therapeutic pet robot for elderly motivation. Basically, if you notice, right, Singapore is one of the countries where we do have real elderly issues. Basically, by 2030, we do find 20% of our population is going to be 65 and above. So this opens up opportunities and also challenges into it. What we notice it in terms of survey, because of aging issues, elderly citizens living alone, they do have around 1.7 times more likely to die prematurely. Even though we boast that we do have a very good, effective healthcare system, and this is one thing, loneliness, and then also the reduction in the quality of life, we really want to address into it. So for which we have been looking into different solutions. One of this is going to be developing a companion antisocial behavior and disease and stroke. So here the antisocial behavior, if you notice it is basically more of the aggressive behavior. So when you're staying in nursing home, they do not respond to any of the instruction by the caregivers. So in a case, what happens is they need to be restrained. So these are something that really don't want to happen, but do happen in the nursing home. So what happens is also we have been noticing out for the last 15 to 20 years, social interactive robots are being coming into the field, and quite a lot of research institutions are working on the social interactive robots. And there have been quite a lot of research done seeing whether these robots have been accepted by elder care institution, especially do elders accept this type of robots. In fact, most of the survey says that elderly people do accept robots into the place, living place, and they are also happy to interact into it. But having said that, if you design a robot and pass it to elderly to interact or play with it out and keep them engaged, what we notice it out is after a period of time, the focus level or the interest level slowly decreases. It's basically when you are a child, when they pass a toy to you, you play for a few minutes, a few days, and then after a month, the interest wanes off, and then you buy another new toy. So basically, we also want to come out with this. Having known the problem, we want to come out with a robot which can be customizable, which means different level of elder users can we come up with a different game, and also different challenge level of interactions. So which means basically a complete kit based upon individual needs. Right. So we want to design a complete kit based upon individual needs. So what happens is we have noticed it, as I told you before, when we try to work with elderly, this is one of the studies we're doing with elderly in the lab. Yeah, they do play around with the robots, they hug the robots, and then they play with it. After a while, the interaction level is not there. So we want to design something where this type of robots can be uh, programmed to another level of interactions. So we want to develop a kit for this elderly.
So this is how my topic is going to arrange. Basically introduction, how do we develop a robotic platform, and some of the interactive tools, right? Like dumbbell, glove, yeah, music therapies. These are things I'm going to cover. Then last one is going to be the conclusion. So when we embark on any project, first thing is, because this is basically a part of a student work also, because being a teaching institution, even though it's going to be a staff research project, we also ensure the student also contribute to some extent so that they can take this knowledge to the workforce or to the industry back. So we did a market survey to really find it out what is the current technologies available. So we came up with two robots that is being used in the nursing home. One is going to be a hash bro. Basically, it's a cat which can respond to sound, and it's basically more of a small huggable type of device. Another one is going to be a therapeutic para robot, which means when you hug the robot, it gives you a sense of belonging, sense of companionship, and also it quietens the resident in the nursing home in terms of those who are having aggressive behavior. This Sparrow basically can respond to by eye movement, and then also gives you a sound which you like it out, and it has a chargeable batteries into it out. Okay, but in terms of, if you look into this, in terms of pricing, one is going to be very close to 100 US dollar, another one is going to be 5,000 US dollar. But Paro, there quite a lot of research activity or research work done as a company robots for the last 15 to 20 years. It's quite a mature platform. So having said that, we also want to have some form of research done in Singapore context. So what we do it as has been told before, we do have something called CDIO framework. Basically, it's a conceive, design, implement, operate framework. Basically, it's a framework for engineers before they go into any projects. Can we understand the user context? So what we do it out is we went on to understand elderly, especially the place elderly are staying, and then how do they keep them engaged or entertained? Do they hang out with friends, and do they own a pet? So these are things. Do they really like a pet? So these are the things we are looking into. If you look into Singapore average age, in the sense the age of elderly, they found it out. The average age is around 84. So after retirement, they do considerable. They do have a long, around 30 to 35 years of lifetime. They do spend, and some of the time they spend is mostly spent alone. So we also want to look into it. So again, we target on a persona, which means trying to find out who could be our average user. So one of the things when we did a survey, we took few of the elderly people, and for some examples, just to show an example, I'm taking one, Mr. Ong, for you to know how this persona has been there. So he has a one child. The wife has already passed away. He stays in a 3-room flat, and most of the time he watch TV, and then they do have a pet, straight cat to feed. And most of the time he's bored, and he does not like to exercise. And then he also does not like to have any responsibility. So this is the group of elderly we are going to address when we want to come up with a solution. And also, this is one thing, understanding elderly needs in a home. And also some of the elderly, they stay in a nursing home, which means around 65 plus, they cannot take care of themselves, so that they go to elderly home, they stay there for 30, 35 until they are invalid. So often said, we try to understand the environment. Basically, when you do this type of new projects, we try to understand the people we are looking into it on, what type of objects they're interacting it on, the environment, and also some of the services who are giving the services, and then what type of messages, are they happy, they're sad, these are things we try to look into it on. So from this, we created a problem statement. Basically, what are the physical limitations? What are the mental disorders they are going to have into it also? This means we find it out the elderly are facing physical limitation, which is quite well known, because as we grow older, our ability to move is also being diminished because of aging issue, and also leads into mental disorder also. So, but also when we do it, most of them really say that they need to want to be motivated. They really like to exercise, and also they need to be cared. They say that we need some attention by the people, because most of the time we're just left alone, and then we have nothing much to look for. So having this in mind, so we started to look into the area of interest. Our project should really focus into it. there's three areas which we really notice it. One is something to improve the mental health of the elderly, keep them active, and also look into the joint movement in terms of physical activity and increase self-esteem. Because once you know that you are dependent upon someone else, you could be a major in army, you could be a medical doctor or a well-known lawyer. Once the aging sets into it on, so when people do not really look for you, that breaks the self-esteem. So this is why we notice it on. So these are the fine underlying signatures when we do look into the study, when we went for interview, when you look into persona which we are really looking for. So we want to have some form of mind game, a simple mind games, and also keep them physically involved. And also we want them to pick up new hobbies, right? Even at the age of 65, they can pick up chess or play cards. And also some of things could be listening to music and singing along with the music. So these are things we started to really plan what type of solutions we are looking for. Even though we may have a robotic dog, but this robotic dog should be able to uh, interface with some of these devices which we want to pass it to the elderly. And we also want to make sure that they do have some form of exercise, basically to extend the range of motion. So, and also if you look into this, right, we also want to have a pet robot to have a good companionship so that they can spend quite a good quality time. So with this in mind, we started to come up with a design. So if you notice, right, we really spend a considerable amount of time understanding elderly. So each country, the user context will be something unique. So we really need to find it out. We cannot just take a robot from a Japan and then translate it to condition which we want to have in Singapore. So we need to understand the local context first. So having understood the local context, having spent time with the therapists and also nurses and healthcare givers and medical doctors, we come out with a design and we have our own different versions of therapeutic pet robots. And the three areas we call this a CR square. We want to really focus into it. It is going to be cognitive, followed by reminiscence and remembrance. All right. So this is how want to have our dog platform is going to be. So if you look into that dog platform, what I set out is we want to have a pet dog which able to have different type of motions, moving forward, coming back, sit, stand, then angle to the left, angle to the right, turning to the right, turning to the left, something very closely resembling that of a natural pet. And also we noticed it out when we did some of the trial studies, experimental studies in nursing home. We noticed some of these elderlies don't like cat, don't like a dog. So we also want to have something like a soft toy. So which means that depending upon the user group, we just change the skin. So today it became a cat, tomorrow it became a dog. We can also say in terms of dog, some like a brown color, some like a white color. So these are things we really find it out. So then this we want to incorporate in our new design. So, and we also want to have something, a device which is quite flexible to move, can interact at the same time with a reduced weight, and also some form of logging in. So, which means we want to log the data into the SD card so that we can take it for analysis application. So this device, this platform, when you take the data analysis out, we really can do some form of data extraction, which will add values to see how effective, how good the patient in terms of interactions, we can find it out. So we come up with a very simple sketch. In fact, every interactions, we bring it back to the nursing home and we sit down with the panel to ask them whether they do like the designs, before we embarking into it. Because iteration is one thing we really need to continue to do it. And we cannot meet one time as being in biomedical field. We cannot try to get the user input and design something and pass it to them. It should be many iterations, and we have to have a constant feedback with them, with the healthcare people. So we also identify the components we're looking for, basically a gyroscope, and then we previously when we started it out, we started with a main with a single motherboard running with the Linux system. It was very power intensive, and we are using a heavy motor. The platform was something around 4.7 kgs, and elderly found it difficult even to lift it and cuddle it out. So we moved from full computer-based version to the Arduino version. And now what we are moving here from Arduino versions, we are going into the ESP32 microcontroller. I'll let you know why we are moving over to ESP32 later. So some of the speakers, so these are motor WCK motors. Now our platform weight is only around 1.8 kg, and it can be fully run by a battery, and it has a timing around 40 to 45 minutes. It can function before every charge. So this is a standard thing via ESP32. It's quite available in the market. So, and also we are going to have some concept like a master and slave. So the dog will be the master, which all the peripherals will be able to communicate to the dog. Okay, in terms of game box, we want to design a game box something like this, where we have a music therapy. We also have image where the patient can identify based upon image. They can do some form of card game. So we are focusing on cognitive, reminiscence, remembrance, and then music touch is also for remembrance. So mahjong game is basically more like a Chinese type of chess, where they do try to have patterns. We need to identify the patterns. So our 3D design for this peripheral. Okay, so let me cover the previous version of a dog. We came up with a CAD model, and then using this we designed the exoskeleton. After this we covered with a soft fur just to resemble some of the like a snowy dog into it. So there are each leg has 3 motors. So altogether we have 14 motors, 12 motors for the leg, and then 2 motors for the neck region. These are servo motors into it. So the board is a custom design board, which a capacitor sensing. We do have motors connected to a speaker into it. The new design, what we have done it, we are moving out the ZigBee communication and replacing with the Wi-Fi communication. That's why we're moving over to ESP32. And we also have a fully functional 5G test facilities in our lab. So for the last 1 year, we have been operating the 5G signal spectrum. So we also want to make sure that the dog also is 5G ready, so that most of the computation will be done in the cloud rather than the platform itself. This is our hardware design. It has a spare everything. So we are using WCK motors, a photo motor for 14 motors into it. The total weight of the platform is around 1.2 kg. Now even batteries, we have changed to a different batteries now to a lighter weight batteries. So when you come out with a platform design, as for those who are taking up robotics, I think this is quite common. We need to come out with a motion control, for which we need to write some of the equations. We call this as inverse kinematics, and then put this into the loop and make it to run. So the standard one, which I've done it on, more of a theory is behind it. Okay, so first device which we want to interact with our pet robot is going to be using a dumbbell. So what happens is when we pass the dumbbell to the elderly, when they start to move, and then the dog starts to respond. The difference of this is previously what happens is when you look into the elderly nursing home, it is usually when this type of dumbbell is being passed to the elderly takes it out, and the nurse keeps on asking them to do it out. Sometimes they are not so happy because the nurse could be at the age of 25. This elderly could be age of 80. They do not like to get instruction from someone younger. So what we do it out is when we pass the dumbbell, and when the elderly take controls of the dumbbell, what happens it out is they have the sense of ownership, which means they become the master. And then when they try to move along with it, the dog starts to respond. Let me do this out and show it to you. Said okay, I just come exit from the main screen, then see whether I can play the video. Okay, let me try to play this video for you to see how it's not a full mode. I hope you can all see this, right?
We can see.
Yeah, it's great. Are you able to see the motion?
Yes.
Okay, great. So this is why we're doing it. So this has a gyroscope, and also it has a sensor based upon the parameters goes into it. Or we have a when you receive the commands, the motion takes place into it. Or so this is one part of exercise. One thing good about this dumbbell, we can increase or decrease the weight of the dumbbell. So it depends upon the elderly strength. We'll pass it out. The next one we are going to do it is basically we call this an interactive glove. So what this glove does it is for finger exercise. So based upon the finger exercise, right, it will start to the dog will start to respond. So this is a new design. We are doing it now. So what happens it out is once we have this finger exercise, finger glove, and then the dog, we can come up with a maze game. So what happens is we can ask the elderly to control the dog to move from A to B. So this also gives them a cognitive type of exercise because they need to follow the pattern. And we also have some research studies done. We do have few papers in the available in IEEE's site. You can have a look into it. Or basically looking into EEG signals when the starts exercise. So after the glove or finger therapy, we also have a card exercise, which you can see it on. We call this more of a reminiscence. So what happens it out is, let me go into this slide because there's another few more minutes there. Okay, so what happens is, when you see, if you notice, right, this is basically a ring. The ring stands for a wedding. So there will be many type of cards. They need to find the right card to match with the wedding. So when they put the wedding photos, then they will be able to respond. When you see a child, they put the trolley into it, or bus means bus stand into it. Some of the things we can match it up. So we are running in a fastener, right? Ping pong, then money. So slowly what happens it out is we can customize it out. So we can come up with the different photos, what they did in 1960s, 1955s, and we can personalize this so that they could be able to remember their path and also gives them a good factor, good feeling when they start to play this type of games. The next thing is we also have a music game where which they need to follow the lights and the music. Basically is for eye and hand coordination. Right, so when they we call it music therapy. So let me play this out. So when able to do this, they will able to we can also increase the number of levels. So when you do anything wrong, it will respond back to it. So this is basically something for your music therapy. So what happens is every time when we listen it out, right? So we will also regularly we do have a meeting in a nursing home. We call usually elder care home. We show the pet into it out. We ask them the feedback. If you notice, right, they're playing with the previous version of the dumbbell, and then we will try to ask them, how do they feel it out? Is it the weight appropriate for it? Or do you find the elderly will be intimidated by the size of the dog? This was the first version. This was third version we designed it out. This version was quite tall, and then what happens is they do find it out. Elderly may find it heavy even to cuddle it out. That's why we came up with a smaller version. Okay, where do we really going in town? So now we want to make sure that since we do have a 5G fully operated network down here, we also want to have place the dog in elderly home connected to a 5G network. All the locomotions and the planning, everything can come will be in the cloud. So and this is all the computations we can move over to the cloud. So which means the platform will be quite light, and then we also can look into some of the analytics can be extracted down here. The next phase, what we're going to go for is voice recognition. So which means that the therapeutic pet will respond to voice command, and this voice command will be customized, which means only to a group of individuals who have been there, they will be able to dog will be able to respond into it. We also looking into some of deep learning into it. And the real challenges for elderly is basically going to be fall detection, and we also will be able to monitor into it. So, so this is our blueprint where we want to look in for another 2 to 3 years time. Basically, a pet robot which should be able to interact with some of the peripherals with a game box, and also a dog which can look at you, respond to you uh, in a real natural way. And also we have to have some form of interactive gloves for the exercise patterns into it out, and also a dog which responds to you when you touch, right? So these are things we look at, and we also want to have some form of deep learning into it, the behavior response of the elderly into it. So I think with this I will end up my presentation, so that the panel I can those who have any questions they can ask me now. So let me end my presentation. Any question from the audience? You can ask me now.
Hello.
Any question to
Yes, yeah.
Dr. Jayachandran, please?
Yes, this is Christy from PRIST University.
Yes, Professor.
Dr. Jayachandar, it was indeed a very, very exciting presentation. You are doing a noble job, that is what I would say, bringing happiness in the smiles in the lives of the elderly people. One thing you were mentioning, the average age span is 85 years, right, sir? That is what you were mentioning.
Yes, for men is 84, for women is 84.5.
Oh, fine, fine. That is unheard of in India.
Is it? Okay.
Yeah, but then, sir, how interactive these robots are? Of course, your last slide where you had shown us the projection, it gave me an answer. But still, I would like to know, when they play with the doll, or when they are cuddling it, handling it, and all, how does the robot respond? How does the doll respond? Is that an encouraging response for the elderly?
Okay. We have done a couple of studies with elderly more than 75 and above. So okay, so what I noticed it out is for all the instances, I would say around 95% of instances for the last 4 to 5 years, we are noticing it out. They do really enjoy playing with it. In fact, this type of therapeutic pet robots is very beneficial in a group setting. So when you put this in a group, when you ask them to cuddle, when you play them with it out, because this can be customized. If you notice, right, you can get a 2 or 3 people. We can come out with the different images. Ask them to select the card based upon the background. When the dog responds into it out, first thing is involvement in a play. Second thing is happiness, because it comes with a score. Right. So what must it out is, if you look into this game box, which I'm focusing now, so when they started to go for different levels, right, it comes with a score. So what must say, they will say, hey, my friend can follow the music pattern. Maybe I should also follow the music pattern. So they will, because we will give them, we do have a specific time frame. So each group, we will not exceed more than 1 hour. To answer the question directly, they're really, really excited to cuddle, touch, and play. They really come forward, provided they do not have any negative experience before. We noticed some of them, they had bitten by a dog. So when you bring a dog into the platform, they do not like it. So that's why we do have inclusion exclusion criteria when we select it out. And again, this will be done with the help of a physiotherapist. So one common question is we can ask it out. Why do we really bring a interactive pet robots into this type of environment? Why can't we bring a dog itself? Which has been done, because bringing a dog has been there for many years. I would say 30-40 years. If you look into some of the journals, they really publish it out. What I personally observe, notice it out, when you have a group setting of 10 elderly, somehow dogs prefer to go and interact only with 2 or 3 individuals. The rest they don't really even turn and see. So they find it left out.
Okay, okay.
So when you bring a animal as a therapist, so we need to also bring a dog trainer along with it.
Oh, that's an added responsibility.
It's another response into it. And also, elderly, they are 4 times more vulnerable for infectious disease. So their dog also carries some form of infection. So we also make sure that after they interact with the dog, they have to bathe, and then so these are challenges they do find it out. And also, dogs are not readily available in a sense that they need to get it from the trainer, and also it's a time process, and they cannot go for regular studies with the same type of dog.
Okay,
Animal
okay.
therapy.
So added troubles are there.
Mm.
Thank you, Professor. It was wonderful.
Okay, thank you, Dr. Jayendra. It was very interesting. And I believe I am from SUTD, Satyan. And I believe this in Singapore context, this will be very relevant because in Singapore, the elder population will be going to be high in the nearest future. And I believe, is there any such kind of pet robots introduced in any of the elder care center in Singapore?
We have our own pet robots have been introduced in 2 elder care now. But every time when we bring, we also been there along, so that we also make sure that we are also properly monitored. We are regularly we are introducing this to elder care.
Oh, okay. Because
Asking them to get a feel.
I'm also associated with some of the elder care center, some service job. So like you may hear that Srinarayana mission. Yeah. So
Yes,
maybe I'll talk to you later.
Okay,
It's
that'll
interesting
be
to me.
great.
Okay.
In fact, I
Okay.
had one of my projects in Srinarayana Mission Yishun
Oh, is it?
for the bed for fall prevention.
Oh, okay, okay. There only I am associated actually, servicing.
That's great.
Great.
Okay then.
Okay, we will meet you
Thank you
later.
for giving me opportunity. In fact, thank you for PRIST University also for coming out with this type of program for the webinar.
Sure. Okay. Thank you, Dr.
Thank you.
Jayachandra.
Thank
Okay,
you.
so let me invite the next presenter.
Signal has another meeting. We'll join within half an hour. Yeah.
Our next presenter is Professor Sri Kumar. Okay, Professor Sri Kumar, can you hear me?
Yes.
Okay, good.
Very good afternoon to
Okay, welcome. So let me introduce Professor Sri Kumar. Professor Sri Kumar is the Assistant Professor of Mechanical Engineering. He did his bachelor's in Mechanical Engineering, MK University, Madurai, a ME in Mechanical Engineering, Anna University, and PhD in Mechanical Engineering, IIT Madras. He has 13 years of teaching experience and 13 years of industrial experience as well. His research interests include robotics, serial and parallel mechanisms, combined mechanisms, smart materials and smart structures, physics control, bioinformatics, and biomechanics. So let me transfer to Sri Kumar to proceed his nice presentation. Welcome, Sri Kumar.
Yes. Yeah. So I'm trying now.
Sure.
My audio is okay, fine.
Yeah, you are audible, sir. You can share your screen.
My screen is visible now?
Not yet.
Okay. So,
Click the third button from left.
Sure. Yeah. Now it is. It is my screen is visible.
We can see you, but not your screen. Now your video is on, but not your screen. I think you have to select the third button. Currently, you selected the second button, the video. That is your own video, your picture.
Screen. Yes. Sure. Now it is coming. No?
Yeah. Now it's coming. Emerging enabling technologies and rising robotics.
Yes.
Dr. Sri Kumar. Yeah, great.
Yes.
Yes,
First of all,
please proceed.
yeah, thank you so much for inviting me for this international webinar. Thanks to PRIST University and the organizers. I am Srikumar from Indian Institute of Information Technology, Design and Manufacturing, um, Kanjipuram, Chennai, India. And my presentation is an overview of the robotic technologies and the research what we are accomplishing at our institution, and what are the problems we are getting now, so that the robotics will move forward to accomplish the future challenging tasks. And first, let me like a few slides related to evolution. And basically, yeah, the ancient man started using the bow and arrow, that is the speed. And after that, the mass is added. And basically, these things are against the growth of the humanity, basically. I can openly say that. And all these mechanisms wherein the modern robotic system is evolved is basically made of extracting the truth, or to give some capital punishment to the culprits. And all these mechanisms, we can definitely say that mostly they are evolved from European countries, including UK. And there are so many, one can search internet to find out a lot of very interesting mechanisms, how the people use some 200 or even 300 years back. And so even there are very huge machines. Even 100 years back, there is a huge machine which was running in UK, and now it is donated to Italy. You could see a massive structure. And even 100 years back itself, we have the technology to cast a huge casting as a single piece of component. But now, if you talk about the robotics, everything you want to miniaturize, not like huge. And so people want of making medical robotics, underwater robotics, and space robotics. And now people are imitating to copy the technologies available in the nature, and reducing the size of all kind of mechanisms and robotic devices. And as you could see, the very ancient sieving machines and mechanisms are developed earlier. But now we could see a very modern mechatronic equipments, including the Xerox machine, sieving machine, etc. On the left, yeah, this is a very ancient the press. Yeah, again, it is a kind of mechanism, and mostly in southern part of India, especially in Kerala, you could see such kind of mechanism in most of the houses, even now also. So again, this is another one kind of evolution of this robotics. You could see the very old, around 120 years old, how the humanoid was developed, and how the modern Asimovs are now started serving the humanity. And another dimension is that people want to miniaturize it. People want to copy the technology available in nature and to apply in the modern robotics. And this is another kind of growth. And we always copy the biological information from nature and utilize in the development of robotics. And so this is another kind of dimension or growth track, you can say that. And all kind of insects and yeah, and other devices which is available in nature. You want to copy their motion and develop artificial things. And we try to introduce all kind of intelligence. So based on various, we have various kinds of control techniques, intelligent techniques. You want to give all kind of intelligence, and artificial, even nowadays, artificial intelligence is emerging as a new topic in every nook and corner of technology. And now we want to, that will play or take a lead role in the near future. And this is another kind of dimension. And the flying devices available in nature, we want to copy. And this technology implement is not new now, but even now the technology is to reduce the size for maybe the spying and other kind of critical applications, etc. So this is another kind of development of robotic devices, like this application of parallel miniatures, parallel mechanism, especially the inverted tech support, etc. And yeah, this is another kind of copying information from nature, and how we are making an artificial spider, and the live approach, how you can be converted robotic devices, etc. So this is the normal frog and natural frog and the artificial frog. And here the technique, the people, a little bit of struggle, what people are making is how to get energy for continuous jumping of repeated cycles of even 500 or 600 cycles, because the robotic device has to jump with the energy storage device also. So that is a critical aspect of the present problem. And now the another dimension is that how to have multiple robots and how to achieve a task using in a cooperative manner, and how to use such kind of devices in agriculture. And yeah, so that is a recent research work going on, and many universities are doing research, and anyone can explore a lot of information by visiting or spending some time in the internet. And yeah, already said, and the communication between multiple robots. And another dimension is that how to reduce such kind of robot in a miniature scale, and how to carry out a cooperative task in a very well efficient manner. That is a present, and how to apply them in various applications, including agriculture, space robotics, cooperative robots in artificial industries, or automobile industries, etc. And if anyone talk about the robots has many components like industrial manipulators, mobile robots, underwater robots, robots in various applications like medical, space, flying robots, etc. And if you talk about the industrial manipulators, we have manufacturing and the logics related, and we have serial mechanisms, parallel mechanisms, and a lot of analysis also required if you want to develop a particular mechanism like a kinematics and dynamics and the trajectory planning. And kinematics include forward kinematics, inverse kinematics, dynamics also, forward dynamics, inverse dynamics, and then the trajectory planning, how to create all kind of complicated motion to these second robotic devices like the joint space, partition space, 2D space, and the 3D space, etc. And how to have different kinds of robots for various applications like palletizing, painting, welding, repairing, etc., etc. And the pick and place, etc. If you talk about the robot mechanisms, so the components are the manipulators or the end effector sensory systems, and power source, that is a critical aspect because mass is concerned. And now the present issue networking system, how to connect various robotic devices, how to transfer communication from one device to another device, and if a device failed, how a group task can be completed. So these are the present focus of the various kind of researches. And then our navigation guidance, and then the communication protocols, the wired, wireless, etc. And let us say multi-system communications, and the different kind of control schemes like the leader-follower approaches, the supervisory control schemes, etc. And so these are the areas in which the present day the research works and all going on. And if you talk about the types of mechanisms, we have serial mechanism, parallel mechanisms, and redundant, compliant, flexible, planar, spherical, etc. So these things that comes under the type synthesis of mechanisms, because there are basically two kinds. One is a type synthesis, another is number synthesis, and the analytical synthesis and graphical synthesis. These are the analysis point of view. And robotics, there is a reason people generally people consider the robotics is little bit complicated. No, not complicated, and the little bit of mathematics involved, and some kind of understanding of the mathematics, how it is being utilized in the development of robotics. That information only seems to be very critical. And if anyone want to the plunge into this robotic motion and all these basic fundamentals of mathematics is, it is the thorough understanding is very much essential. So then only this information can be utilized in the development of robotic parameters. And there are various applications and the design types. You can say that one can spend a lot of time in internet, and you have all the stuff, these stuffs and copied from internet. Simply you can say the serial mechanism, spherical mechanism, parallel mechanism, the hybrid mechanism. Our skeleton is basically a hybrid mechanism. So we have the two hands, basically the serial mechanisms. If these two hands together, that comes under parallel mechanism. The actions are parallel. And like this, whenever all these two legs and two hands put together, we have a very huge parallel mechanism ourselves, and we can carry a huge amount of load And this is the best example of a parallel mechanism. It is a Stewart platform designed or invented for flight simulation studies. And you can say that various kinds of research works are going on, and people keep on developing various parallel mechanisms and serial mechanisms. And a lot of analysis have been coming out in every day. A lot of technologies and methodologies have been used. Now various softwares have been are available, and people are started efficiently using such kind of devices. In addition to this MATLAB, Simulink, and such kind of softwares. And I already said various simulation softwares nowadays now available even free of cost. And anyone want to develop or want to study robotics in depth, and you can simulate all kind of platforms using a line sketch or a symbol or a symbol architecture, etc. And and then advanced softwares like Adams Pro is also available, and AutoCAD Inventor, those things are available, where you can visualize without visualize the motion or even complicated this thing without much difficulty. And so now the next the complicated area is the humanoid robots. Many people, you can say that Asimo robot and Honda robotic devices, and they have already developed humanoid robots, and many universities are working on this. And here the complication is that how to integrate all kind of joint motions, and finally come out with the proper control scheme. So that is a real complex aspect of development of humanoid robotics devices. Now the present trend is how to miniaturize such kind of robotic devices for very certain kind of applications. And for miniaturization, smart materials will be very much supported. And basically, we have various kinds of smart materials, and basically two smart materials are very much supportive. Like they are basically the shape material light and electroactive polymer actuators, where the strain and those things are very high. And so they are smart sensor system and a dual sensor system, and they can act like a smart structure. And there are smart MEMS devices, and the basics of all kind of the material operations and all available, and you can search through the web before finding the machine. And just to do just a few things in the shape of the line, it is if you add and remove the heat, you can find the actuation. And the electroactive polymer actuator, and basically it is like the function is like a capacitor, and there is a middle layer, polymer layer, and the top and bottom sandwiched with the electrode. And if high power is applied, and there is a reduction in thickness, this reduction in thickness is squeezed out in X and Y direction, and this can be utilized in the development of various electroactive polymer actuators, and that can be used in the development of flexible robotic systems. And we have other smart materials like piezoelectric material, electrostatic magnetostatic material. Then rheological magnetoreological fluids and solids, where the rheological properties like the density and viscosity one can easily change it. We have other kind of smart materials also, so that is beyond the scope of our discussion. You have smart fabrics also, and many automobile companies are there started using it. And we have extensive utilization of the smart materials in medical robotics and other medical areas. And so this slide is taken from the internet. We have very modern applications based on then smart materials. There are a lot of robotic devices have also been developed, very miniaturized and wirelessly controllable, and being developed for various kinds of application. And there are people are developing small, very miniaturized robot or milli devices, where can pass through the blood, and where all kind of even photographs or videos can be taken. And other smart materials like fluids, color changing smart materials, and other things also available. And then if you talk about the SMA, there are some basics are involved, and I already said heating and cooling techniques are involved for getting the SMA actuation. There are two phases that are associated, like our steel. There is austenite and martensite phase, and if you heat the material, it go to the high temperature austenite phase, and if you cool the material, bring back to the martensite phase. And so by this transition, you can get to the actuation, and you can see the simulation of heating and cooling. By that way, you can get the actuation. And yeah, that simulation, it is a cryo-feed coupling. When it is stored with a low temperature, the volume of the material is very high. And when it is slipped into a shaft and the temperature is increased, that will make a tight coupling. So yeah, so this is a simple explanation to explain the behavior of a shape memory line. And various robotic applications have been developed using these smart materials like grip test, flying devices, and then fishes, etc. And a lot of surgical devices also being developed by various universities. And the spiders and miniaturized devices, and the endoscopic tips also are being developed using these smart materials. And we have other variety of robotic devices like the fingers and the artificial eyes and various complaint devices, etc. And the people also already using in automobiles, but the technology is not revealed to the common man. But most of the automotive majors, they are using the smart material technologies in their um, cars and other systems. And we have various applications, other applications also, engineering and non-engineering and medical applications. Various kinds of valves have been developed using these smart materials. And you hate that Shep umbrella is being extensively used in the medical area, like stent, orthodontic clips, and other valves, etc. And this is a modern technique, and how this SMA can be used in a medical fixing of backbone, etc. And yeah, the stent and other surgical devices and other kind of robotic tools using this stepomery alloy materials. And as far as this electrolytic polymer, it is a very flexible material and high frequency device, whereas stepomery alloy is a very low frequency device, and efficiency also low in as far as SMA is concerned. Whereas such kind of disadvantages are not available in electrolytic polymer material. But the negative aspect of this material is it is highly flexible and high voltage is required, and that is a negative aspect of this material. But all the smart materials, they have some one common negative aspect, the hysteresis. And right, when you try to utilize this material and or in the form of an actuator, hysteresis is involved, and you have to map these hysteresis maybe in terms of some kind of compensation in the control scheme, etc. And I already said there is the solutions or like up and down curves in the construction of this smart control, so that we will get more flexibility. And yeah, so our institute also did research in using electroactive polymer actuators, lead and follower approaches in implementation of the perfect motion in mobile robots, etc. And a few scholars are working on artificial intelligence, IoT, and in ICPS, interdisciplinary cyber systems, and the integration of robotic devices in automatic capturing of images in 3D printing, etc. So these are areas currently our institute also contributing. And the application point of view, electrolytic polymer actuators, already people have developed a lot of the actuation devices and smart pills, etc. And another dimension of these robotic devices are development of various complaint devices. And ISC Bangalore, Professor Ananda Suresh is spending a lot of time in the development of such kind of devices. How the metal surgical tool can be converted into these complaint devices. I also did some work in complaint devices, especially the large deformation aspect of complaint devices. This is one design aspect of complaint mechanism. That is my PhD work at IIT Madras. And yeah, so this how to convert this metal surgical tool into a complaint surgical tool, especially for these medical applications, etc. Now, so the highlights are, so what are the requirements of the day? And yeah, we need now the IoT-enabled robotic systems, and we need not a single robot. We need multiple robot cooperative systems, and by this the swarm robotics is being explored. And then we need very much suitable robots for very critical applications like high pressure vacuum applications, etc. The very critical space application designed for zero gravity, etc. And then how to tackle problems related to COVID-19 and similar pandemics may come in future. And such kind of research. And this, especially with COVID-19, that gave a lot of research problem, modern research problem for our future PhD scholars. And then how to develop low-cost reliable devices that also aim of the present robotic research. And then how to design a robot for self-decision making in unknown environments. And then self-repairable robots, how the robot motor is failed, how a robot can fix another motor, or how it can get power from another resource, or how it can get power from another robot, and such kind of developments also going on. And how to integrate efficient power transmission, power resources within the robotic system, and how to integrate modern artificial intelligent devices and techniques in the control scheme of. Then finally, you can say that how to integrate various various materials available in the development of various kind of robotic devices, etc. So now, with this, I just conclude my presentation. And thank you all. Thanks for giving this great opportunity for this international webinar. Thank you to the organizers of this university. Thank you.
Thank you, Dr.
Thank
Sri
you so
Kumar.
much for this Mohan Rajesh Elora, and he is the person behind this, connecting me to this international webinar. Thank you all.
Okay, sure. Okay, we will convey this message to him. Sure. Okay, it was very interesting presentation, Dr. Sri Kumar. So, is there any question? We have 4 more minutes in this session. So, any question to Dr. Sri Kumar, please, from the audience?
So you can also post queries in the email, and the email is msk@playdium.ac.in.
Yeah, we noted that one. Actually, it was a very interesting presentation, Dr. Srimar, especially for those who want to maybe the students, because you covered within 30 minutes. You covered most of the subjects related to robotics. You started from the very ancient type of machineries and robotic evolution and robotic mechanism, different types of mechanisms, sensors, tools used, and shape memory alloys and materials, different types of materials, so that many new from ancient to the modern, the material, the technology transformation, as well as what are the new innovative materials and technologies available which can be applied to the robotic systems and subsystem level to meet specific requirement. It was very interesting, and you have put a lot of information over 60 over slides. A great effort, and thank you so much for your effort and time.
Yeah.
May I put a small question to Dr. Sri Kumar? This is Christy from PRIST University. Sir, thank you for a wonderful presentation. We just wanted to know how IIIT is contributing to the cause of COVID-19 in this situation.
Yeah, so MHRD also giving a lot of thrust to this problem, and our faculties are we started working on this right now. Yeah, so not able to give the details, and including myself.
But you are contributing definitely.
Yeah, we have started contributing, and we have many people submitted the project proposal to the government also, and we are planning to invite PhD scholars also. And our existing scholars also started working on this. They are redefining their problem towards this COVID-19. Yeah, COVID-19, they gave a lot of research problems and new research inputs to this, especially the PhD scholars.
Thank you. Thank you for your contribution to this the webinar, sir. Thank you very much.
Yeah. Thanks for giving this opportunity.
Thank you.
Okay, I think now time to move to the next presenter. So let me invite Dr. Saki S. Saldi. Dr. Saki? Hello. Hi. Dr. Saki S. Saldi, welcome to this webinar. Let me introduce Dr. Saki. Dr. Saki is the head of product design engineering study program at Prasetya Mulia University, Indonesia. His teaching and research interest lies in the area of technological product development, thermofluids, and materials processing, with a focus on the use of computer-aided design and engineering, including computational fluid dynamics, CFD simulations. Dr. Saldi's past experience includes research fellowships on integrated safety strategies for hydrogen storage onboard fuel cell vehicles carried out at the University of Warwick, UK. He obtained his doctoral degree from Delft University of Technology, Netherlands in 2012. Welcome, Dr. Saki, to this our webinar. Now I hand over the mic to you to present your distinguished presentation. Thank you.
Okay, thank you very much, Mr. Chairman, for the introduction. Hello, everyone. I hope everyone can see my screen. Before I begin with my presentation, I would like to thank the organizer of this webinar for inviting me to give this presentation. It is such an excellent opportunity. I'm truly honored to have this opportunity. Okay, what I'm going to talk today is on the application of computational fluid dynamics in the design of robots. But before moving into the core of my presentation, I would like to introduce very briefly about my university. Okay, so this is my university, Universitas Prasetya Mulia. It was founded in the early 80s, and it has two faculties now, School of Business and Economics, and also recently we established School of Applied Science, Technology, Engineering, and Mathematics, or STEM. So it was recently established in 2016. So this school is still very, very young. So we will have our first batch of graduates next year. So there are 6 study programs, undergraduate programs in the school, and now I'm leading this study program, Product Design Engineering. So we have collaborated with a number of universities, and we also collaborate with Singapore University of Technology and Design. So as a matter of fact, we organized this joint program back in January 2020 between our university and SUTD in design and entrepreneurship. So students from SUTD visited us on campus, and they collaborated with our students to work on making prototypes of chairs. And we were also honored to have Professor Ramachandran from PRIST University to visit us during that program. So I was introduced to him through Professor Mohan Rajesh Elara and also Dr. Amir Hayat here, who also co-organized this webinar. So it was such an excellent opportunity for our students to get into more international collaboration with fellow students from abroad. And the plan was actually we want to continue this by a return visit to Singapore, but because of this COVID crisis, we have to cancel that plan. Hopefully we can continue with the same program next year. Okay, so this is what I'm going to talk about in this presentation. First, I'm going to touch the subject of design aspects of robots, and then I'm going to narrow down the discussion a bit into something more specific, which is on computational fluid dynamic simulations for robots design. For this particular problem, we can easily classify the problems into 2 kinds of problems, namely internal flows and also external flows. For internal flows, I'm going to show a very simple example of fluid carrying robots in which we have the free surface flows. So I'm going to show results on the sloshing simulation. And then, well, actually, I have an ongoing research on this. And then after that, I'm going to very briefly introduce the problem of external flows. I'm going to talk about a little bit about bio-inspired soft robots and one of the relevant phenomena in bio-inspired soft robots, which is fluid structure interaction or FSI. So when we design robots, we have to take into consideration a lot of aspects. So here I divide the design aspects of robots into 3 layers. The first one is the consideration layer. And then the second one is the fields of study. And then the third one is the component layers. For the consideration of design, we have to take into account a number of aspects. Of course, we need to consider the performance versus cost. And we need also to consider the experience of the user in case we design social robots, for example. Experience for a user is a very example. I think in one of the previous presentations, Dr. Uruchami, Dr. Jaychandar, I think from Singapore Polytechnic, he talked very nicely about the therapeutic robot, in which experience is also very important. And also environment, now because we also have to take into account the consideration of sustainability and also socio-economical aspect, business aspects. And this involves multiple disciplines. So robotics is highly multidisciplinary. We need to consider mechanics, electronics, artificial intelligence, and computing, materials, aesthetics and user experience, and also manufacturing. And on the component layer side, a number of parts are important. Of course, for social robots, the robot has to look good. So we need to consider the body or enclosure. The user interface also has to be, the robot has to be conveniently operated. Sensors are common. It is, of course, important in robots. Of course, also power unit, controllers and microprocessors, and also materials, motors and actuators, and also linkage. So that's the design aspects of robots. And we've seen these wonderful robots in recent years. We have seen these are the traditional industrial robots. We have robotic arms from ABB, Epson, and Kawasaki. These are three of the three major manufacturers of industrial robots. But now we also see this kind of robots. We have Valkyrie designed by NASA for space exploration. We also have these robots from Boston Dynamics, Atlas, and Spot Mini, which can be used also for security and also logistics and other industrial applications in factories, for example. And also social robots, we have these examples of social robots. We have Asimo, which has been around for already more than 10 years, I guess, but recently I think they also developed this continuously. We have the service robots, and also this is Now, which can be used also for interaction with autistic children, for example, and also these non-humanoid robots such as Aibo, the dog robot. But now I would like to draw your attention to the scope of interest of my research, of my presentation, which is not really this kind of robots, not really industrial robots and social robots like this, but special kind of robots which interact with fluid flow. So the scope of interest of my research is robots that closely interact with fluid flows in such a way that the fluid flows will influence the performance of the robots. So, for examples, are these robots. We can classify the robots and fluid flows into two classes. The first one is internal flows, and the second is external flows. For internal flows, examples are these cleaning robots. We've seen presentation from Professor Mohan from SUTD this morning. He co-founded this company, LionsBot, that manufactured Leo Scrub and Leo Vac, the cleaning robots, and also these typical vacuum cleaning robots. For example, Xiaomi from China. These two robots have been commercially distributed worldwide, and the fluid flows play important role here because they carry the fluid flow internally. For cleaning robots, they carry the cleaning agents, liquids inside of the robots. And also for vacuum cleaning robots, there is also fluid flow related to the airflow through the duct of the vacuum cleaning. So fluid flow analysis plays an important role here for the design of, for example, here, the stability of the robots when they do complex maneuver, and also if the manufacturer want to design the robot such that it can be operated at a higher speed and more complex maneuver, then carrying a liquid inside of it may pose certain problems for stability, and they need to think about the stabilization mechanism related with that sloshing in the robot. And also for a vacuum cleaning robot, fluid flow will also influence the way the duct is designed, so that the vacuum cleaning process can work more efficiently. And this is the first class, and the second one is the external flows. So here the robot is operated inside of a liquid. So the flow is external to the robots. For example, the soft robotic fish from MIT here, underwater robots. We've also seen presentations from a number of speakers previously about underwater robots, and also which is also equally exciting is the flying robots like this. For example, Delphi. This mimics the fruit fly, so it's manufactured by Delphi in the Netherlands. So these are examples of how fluid flow analysis is important and how robots can also interact with fluid flows. So talking about computational fluid dynamics, this is a numerical simulation tools to study fluid flows. It basically solves transport equations of fluid flows and also scalars such as energy or heat, element concentration, etc., numerically using computers. For the design of products and processes, CFD simulations play equally important role with experiments and theoretical analysis. But in reality, actually, theoretical analysis will be rather impossible to be applied for design of product and processes in real life, because the phenomena encountered is too complex, so we cannot rely on theoretical analysis. And experiments can be also very expensive, but it's still very important. So if you have access to do experiments, it's very important to do so. But for a number of reasons, we have to go hand in hand using CFD simulations and experiments for the design of product and processes. So these are examples of my past work using CFD. So I have simulated weld-proof hydrodynamics, for example, here for welding processes, and also free surface flows. This is a popular test case for free surface flows, the dam break test case, and also for combustion analysis, or we have a large-scale syngas jet flame here, and also for cylinder tank fire scenario. So CFD has been applied to a wide number of applications. So the enabling technologies of CFD, there are exciting opportunities nowadays. We can not only use commercial software, but there are also open source software that we can easily use these days. So there are a lot of easy access to open source CFD codes these days. And also in terms of infrastructures, the computing infrastructures become more mature, and we also have cloud technologies who can do simulation on cloud. We don't have to own our own computational facilities. We can just subscribe for a cloud computing services. And then visualization using virtual reality and augmented reality will also help us to understand better or visualize better the CFD results in the design. Also, there is an emerging field of combination between artificial intelligence and CFD. So this will help us in the right way to the design of robots, especially because it's a complex thing. We have to simulate many things. By combining AI and CFD, we can actually benefit from the machine learning algorithm or deep learning algorithm with CFD. So this is an example of I think this is now the fastest supercomputer. It's in Japan by Riken Research Institute, which can process to hundreds petaflops per second. So now So this is the sloshing in fluid carrying robots. So this is a free surface flows. So we have a two-phase flow. One phase is water and another one is air. So it's important for fluid carrying robots, especially robots that operate in high speed and complex maneuver. For example, complex translation, rotation, or multimode combination between translation and rotation, and high degree of freedom movement. And also for robots with high ratio of fluid to robot. So the higher the ratio between the fluid and the robot, the more important the sloshing, and we need to take this into account for the design of the stabilization mechanism for the robot, and also for the design of maneuver and trajectory. Basically, we want to expand the work envelope of the robot. So if you want to have a higher speed and also more complex mechanism, we need to take into account this sloshing mechanism for fluid carrying robots. So for free surface flow modeling, there are typically three main ways to do it. We can track the interface or fit the interface. So we have movement of mesh or just capture it. The easiest one is the interface capturing, and for free surface flows dominated by gravitational force, I think this is the easiest and most convenient to use. So capturing methods means we solve the transport equation of a scalar. It can be volume of fluid, level set, or coupled. Basically, both of them have their own advantages and disadvantages. For volume of fluid, it's very simple to implement in the code, and it also has a very good mass conservation characteristics. But the downside of it is that the interface is smeared over several cells. So it is actually problematic for flows dominated by surface tension. But for flows dominated by gravity, for example, like sloshing in the robots, I think this is already okay. We don't need to really care about the capturing a very sharp interface. On the other hand, for level set, it is quite complex computational because we have to reinitialize the distance function at each iteration. And then it also has the downside, a serious one, which is non-mass conservative, but it performs well in terms of interface capturing. It captures the interface much better than VLF. So basically, there's also a combination between the two in order to combine the advantages of both, which is the coupled method. So I would like to show the validation of VLF model. This is taken from my PhD thesis. This is on the dam break test case. So basically, we simulate this column of water. We let the water fall due to gravity, and we simulate the movement of the water. Here we validated the results against simulation results from these guys here, and also there's experimental results back in 2003 on this problem. So here we have the probes at point 1 and 2, and at point P1, at H1 and H2 here, we monitor the height of the surface, and as you can see here, the height predicted by OpenFOAM. So here we use OpenFOAM computational code. Can reproduce really well the results from other simulations and also experiment at probe H1 and H2. And also for the pressure here, we monitor the pressure at point 1 here, P1. We can see that the prediction is also quite well. So we can say that the VOF model here is very well validated. Here, I want to show the simulation of sloshing. So here we have the cylinder of containing water. The capacity of the cylinder is 40 liters. We filled it 50%, half filled initially. Then if we view it from above, so this is the top view, we set the movement like this. So we have also the translational direction, and also we have a rotational movement here. And we implement this movement as a body force in the transport equations, which is already embedded in the code we use, which is OpenFOAM. So we simulated 3 test cases, run 1, 2, and 3. So the difference here is on the amplitude of the linear oscillations. For case 1 and 2, we have 10 centimeters. For case 3, we have 20 centimeters of the amplitude here. And then for the rotation, we vary the RPM. So for case 1, we have 10 RPM. For case 2 and 3, we have 60 RPM. So here we see the movies of the simulation here. We see the sloshing of water liquid here. As you can see for case one, because the translation amplitude is only 10 centimeters and the rotation is only 10 RPM, you cannot, you see that it's not as violent as these two cases. For case two and case three, especially for case three, because we have 60 RPM and 20 centimeters in linear oscillations, it is more violent, and we can see a complex sloshing mechanism going on in the vessel here in the tank. We also monitor the center of mass coordinates, the X coordinates, Y coordinates, and Z coordinates. As you can see here, black lines are for run 1, red for run 2, and blue for run 3. As you can see for run 3, we have the highest amplitude for center of mass in X, and also, for example, in Z direction, it is in the vertical direction because we have this movement over the top of the tank. We see that the center of gravity is also higher. So this implies that if we can monitor this, we can, by using CFD simulations, we can simply also design a mechanism in order to stabilize the movement of the robots. So I think I'm running out of time, but I'm going to talk very briefly about external flows. So for external flows, one of the interesting topics is on bio-inspired soft robots. So traditionally, we already know rigid robots. Well, rigid robots have been very maturely developed. There are lots of development in rigid robots already, but in the near future, I think researchers worldwide are also interested in bio-inspired soft robots. Why? Because this kind of robot, they use soft and flexible structures, and they can operate in higher degree of freedom and highly adaptive. And that's basically means that if we can move from rigid robots application to bio-inspired soft robots, we can obtain better energy efficiency. We can have also lower noise. It's also possible to design a multimodal locomotion. Maybe in the not so distant future, we will have application of robots that can move terrestrially, underwater, and also aerial because of the application of soft robots. In terms of fluid flow analysis, we have fluid structure interactions. This is an important phenomena in which there is a coupling between fluid and also structure. From computational point of view, we have one-way coupling and two-way coupling. So for one-way coupling, the fluid forces calculated by the fluid solver will be used as input for a structural solver, and that's it. And we move to the next time step. But for two-way coupling, after solving the fluid solver, we have the fluid forces acting on the structure solver, and the structure solver will calculate the body deformation, and it will use again as the input for the fluid solver. And there's a weak coupling and strong coupling. For strong coupling, it is more accurate because we have to reach convergence between the fluid solver and the structure solver, but at the expense of more computational cost, of course. So this is my last slide, actually, to show the FSI for soft robots. For fluid structure interaction, the deformation is not only elastic due to mechanical loading, but there is also active deformation because of stimuli induced that can be light or heat or electric signals. And then we need to also take into account the active deformation part here. So in terms of computational model, one of the most advanced but also easy to implement method is the fixtures domain method, which benefit us because we can only use fixed grid. So we don't need to use moving grid. So it's very easy computationally. So this is a video that I downloaded from a journal. This recent journal from the US, they actually do simulation of I think this is jellyfish robots. So they simulate the fluid structure interaction. Here we see on the left. This is where we consider active strain radially and also azimutally. So the locomotion proceeds very stable. But for this one, we only consider the radial direction of the strain of the active stimulus. So as you can see, there's an asymmetry in the flow. So that causes the locomotion, that inhibits the locomotion, and it becomes unstable and unsymmetrical. So this is a typical example of fluid structure interaction simulation, and it is very useful for soft robots design and development. So to conclude, I have shown the important role of CFD simulations in robots with fluid flows, both internally and externally. But we need to obtain more efficient algorithm for modeling and simulation to cut actually the computational cost. But there's also enabling technologies which offer exciting opportunities, for example, AI and also more powerful computing infrastructures. And we will see a much broader application of robots, and that certainly poses a design challenge. I think I've come to the end of my presentation. I would like to thank you all for being here with me with the presentation. So I'm happy to answer any questions for you. Thank you.
Thank you, Professor Saki Saldi. It was very interesting presentation from your side, and you could nicely covered the CFD guided design of robot applications, its different challenges and opportunities. So it was really will be interesting for the robotic enthusiastic people. Okay, so is there any question from audience to Professor Saki?
Yeah, I saw in the chat box here questions from I think Dr. Rizana Parvin from SUTD. Which software is used for sloshing simulation? For that results I've shown on my presentation, I used OpenFOAM software. So it's an open source CFD tools. I've been using these tools since I started doing my PhD, so it's more than 10 years already, and they developed such a wonderful open source CFD software. The good thing about using the software is that it's open source, so we can actually implement models into it. So it's not a black box like commercial software. And also the good side is that it's an active community. There's an active community using the software, so you can easily exchange information and ask questions on the forum. So many cases that might be relevant with our cases, and we only have to modify something in the code. It's very practical. And also, I think it's gaining more popularity these days, especially with the cost of commercial softwares. I think it's better to invest on computing infrastructure and then just use open source CFD code. So that's my experience. Thank you for the question.
It will be a good. It will be useful for all researchers, Dr. Saki. Okay, so any more question?
This is Christy from PRIST University. Hello, are you hearing? Yeah. Thank you, Dr. Saki.
Hello, Professor Christy.
Thank you for it. Since it is about fluids, I just wanted to know, is the temperature of the fluid factored in when you are designing the robo? In your work, have you done it? Temperature of the fluid?
Okay, I've shown results on internal flow and external flow. For my result is on internal flow. For internal flow, I use isothermal simulation, so I don't use temperature variation. But I think for cleaning robots, that's also the case because there's no temperature difference in the fluid. And for the external flow, the results that I shown is not my results. I only review it from one of the papers in the Journal of Computational Physics, which I think very excellent results. And I think also in that case, it's also isothermal case. So there's no temperature variation in the fluid.
Fine. But suppose you are designing a robo for handling a hard fluid. You know, look at a chemical industry requirement. Inside a container wherein liquid is stored at a higher temperature, the robo is supposed to operate. Probably during such occasions, we may have to factor in temperature.
That's right. I think we have to look at the application first. If it's in the environment where temperature variation is important, or if there is a like element concentration, there's a chemical concentration inside of the liquid in such a way that it influences also the fluid flow, then we have to take those into account.
We have to take into account. But so far, you have not come across such
cases, No, right? Where no, temperature was no. considered. Yeah. It was only an Yeah, it's for, isothermal. yeah, isothermals. Okay. And just for interest's sake, what was the temperature range kept? It was the room temperature? It's room temperature. Room temperature. Room temperature. Thank you, Mrs. Zalki. That was a wonderful presentation. We enjoyed. Thank you, Professor. Thank you. Thank you.
Okay, thank you, Professor Saki. So I think the time to move to the next presenter. Let me invite the next presenter, Dr. Elangovan Karthikeyan. Okay, so Dr. Karthik.
Yes.
You can you hear me?
Yeah.
Dr. Karthikeyan. Hi, hello.
Hello.
Hi, Karthikeyan. Okay, let me introduce the Dr. Elangovan Karthikeyan. Dr. Karthikeyan is currently as a research fellow at Singapore University Technology Design SUTD. He received his PhD in Advanced Multidisciplinary Engineering from the Tokyo Dankai University, Japan, and MSc in Information Technology from the Sikkim Manipal University, India. He obtained his Bachelor of Engineering degree from the Annamala University, India, before joining SUTD. He also has some major experience as a production engineer at different industries in India. His research interests are in robotics with an emphasis on self-reconfigurable platforms. He is the recipient of Singapore Mark Design Award in 2017 and 2018. Also, a Prime Design Award in 2018. Welcome, Dr. Elangovan Karthikeyan, to this webinar. And
Yeah,
we are happy
thank you,
to
Satyan.
transfer the mic.
Yeah, thank you, Satyan. Hello, everyone. I'm Karthikeyan,
You
number
can
one.
see your screen. You can make it a full screen.
Okay, sorry.
Okay, nice. Thank you.
Yeah. Hello, everyone. I'm Karthikeyan, number one. I'm working as a researcher and a professor at Shilera. So now I'm going to talk about bio-inspired robots. I can take a special case of Scorpio. The Scorpio is a bio-inspired self-reconfigurable rolling, crawling, and wall climbing robot. So this is funded by Singapore military. Singapore military have some certain requirements, like the robots need to be smaller. It's need to be used in urban recognition missions, as well. It's need to crawl, roll, and climb the wall as well. So we just look into nature, and then we found total 18 different species, which have multiple locomotions, like crawling, rolling, or crawling, jumping, or crawling, wall climbing, something like that. The special candidate is spider, which is a Cybernus Reichenbachii spider. So currently, what they are using now, they are using those kind of big machineries to do the urban recognition missions. This is bulky as well. It's the noisy. So what we did. So this is a Cybernus Reichenbachii spider. The spider is found in Moroccan desert. The Cybernus Reichenbachii is a professor who found this spider. The spider is a specialty of the spider is rolled like a somersaulting. So it's a meter per second. The speed is meter per second, and then it can crawl, roll, and climb the wall. Obviously, we know every spider can climb the wall as well. So, so we quite interested in this, and then we start mimicking this, and then we did a lot of mathematical modeling, and we reduced the size of the motor. But first, in the beginning, what we start with a bigger platform for the feasibility, how whether it can work or not. Like, so I will go with the video. Yeah, so this is we start with a bigger platform. The platform weight is around 1.5 kg and 38 centimeter diameter. So it's quite it can crawl and roll as well. So it can transform like this, and it can start rolling like a somersaulting. We try to mimic the real spider. But the actual real spider has 8 legs, but with the 4 legs we can able to achieve all the locomotions. But the speed is still it's very competitive. Yeah. So with the next gen, we come up with the size of the robot is around 200 millimeter, and then we with the weight of 500 grams. So this is the second version, but it's a little bit unstable. So we did the mathematical modeling afterwards. Like we just come up with a new design, which is the next version, but it can do all the locomotions as well, like crawling, rolling, and sideways motions and everything. Yeah. So these are the robots. It's a initial prototypes, and then the next version is come up with full 16 to 17 gauge generations, like which can able to do crawling, rolling, and even though it's fall upside down, so it can recover, it can come up and come to the home position as well. So now it can able to crawl, roll. Yeah, this is more stable platform. This is weight of 200 grams, and the size of the robot is 200 millimeter diameter. So it can do the curve locomotions as well, because in the autonomy, like we can just avoid the obstacles in a different ways, like sudden 90-degree move, or it can do curve as well. So the rolling, but in this we apply, we implement while rolling, it can able to turn right and turn left as well. It's a steering control. So even though it's fall, so it can recover at any position. So we implement the IMU sensor in it, so it can at any because it's open recognition missions, no man will be touched the robot or something, like unmanned environment. So what it will do, like with the IMU feedback, and then it can recover at any fall, even though it's stuck, it can recover. So we tried the stability of the platform. It's just rolling down on the stairs itself, like, but the robot is quite strong, and then it's still alive. Yeah, it can, because it's autonomous, like it can recognize its fall, and then it can recover, and then it's try to recover, come to the home position, but because of the environment, so it's drop, it's fall down again. So it stuck in this case. So what it will do, like, yeah, it can recover, and then it can come up, and then it can start again rolling. Yeah. So after this test, and we found the legs are okay, the robots are completely fine. So it can recover. Yeah, it's still working. So this is equipped with only IMU sensor, not even any obstacle avoidance or something like that. Yeah, and next one, we implement the wall climbing mechanism in it. I'm stuck somewhere. Oh, sorry. Okay. Oh, yeah. Okay. So this is a family of Scorpio. We can tell this is a great grandfather, the left side one. So we come up with the family members, and then the last one is a great grandchild with the wall climbing mechanism. So the wall climbing mechanism is inspired by like a monkey family called ape. The ape, whenever the ape is get enthusiastic, like it's so happy. So what it will do, like it can just push the two trunk and then move the central body swing. So in that way, we just implement that into our robot. And then this is a basic locomotion. And then next videos, and I will show you the real Infosys mechanism as well. Like So the wall climbing, we just check the wall climbing descending and ascending and multiple times. And then even though with those wall climbing mechanism, it can able to roll, crawl, and climb the wall as well. Yeah, it can transform into the rolling position and then it can move to rolling. Yeah. So it can crawl as well. It can do upside down recovery. Yeah. So now the previous video, like what we saw, like the robots need to go. If it's need to go climb the wall, and we need to take it by hand, and then we need to put it on the wall itself. But now in this case, it's automatically recognize the wall in front of the robot, so it can transform into the wall transition motion, and then it will just flip and then go and approach to the wall, and then it can just stick and climb the wall as well. So yeah, it's a wall approaching happening at the moment. So this is the mechanism which I mentioned, the ensure mechanism, which is it can, because it's a passive adhesive. Over some time, it will just get some dust and those things. So what it will do, it's like a hammering motion. It's do the hammering motion, and then it can just push against. Once it sticks, it will push again and push again. Something like it will just continue the cycle. So even though it can able to climb the curved surface as well. We have a camera over here. It's like it will be work like a CCTV. Like we can just place that robot and then it will just go somewhere. It's like a portable CCTV as well. It will work in that way. Yeah, and what we tried, like with the single lifetime of charging, like in single charging, it will be like 36 hours we tried in the first initial test, and then afterwards, like what we did, like it will be like a 7 days single charging, and then it will continuous. It's work. The robot is working like the robot will be sit in the corner. It's in the dark area, dark environment, with this lidar ultrasonic sensor, and then it will just detect any motion or something. It will just wake up and then it will just move away to the rescuer straight away. Like we did the same lidar, ultrasonic lidar, to do the simple mapping, because this platform is small and tiny, so we cannot put the big lidar sensors or something. So we just build our own the sweeping mechanism to mount the ultrasonic sensor in it. Even the narrow chair legs and those things, even the narrow chair legs and the transparent obstacles, also it can avoid, and then you can do the stuff. This is obstacle avoidance. It can just roam, and the next open space, it can just move along the way. Yeah, and we tried with the autonomous locomotion with only based on IMU sensor. So what we did here, like we have a flat surface, and whenever the robot enters into the slope surface, and then it will recognize the slope, whether it's more than 10 degree. So it can consider that as a slope. The slope is better thing for the rolling. It's very easy, no energy consumption. So we can just use the rolling motion, and then it can just automatically roll away wherever it is, and then it's fall down. Even it's fall down, it can recover from that position itself. Yeah, this was the third version of the robot. Yeah, so now we are going to see the swarming behavior, multiple robot coordination. We have a small size. This robot size is around 120 centimeter diameter, and then it can able to it can coordinate each other. So the first robot doesn't know what is in front. It's a dark place as well. So the first robot, once it's enter into the slope, and then it will just fall down, and then it will just give a command to the fellow robots like, hey, there is a slope in the front, so you can just roll. The rolling is a better place for the slope. So we just did the communication between those. Yeah. So it start rolling now, and then once it's go back, and then it's pulling the direction to go into that slope direction itself, like. Yeah, so this is the video, and yeah, so now we have a path planning. We have a random path planning. We use the random path planning, but we have an object finding a task for the robot. So the robot the robot will randomly can roam around, and then can just search where is the object and those things. But we set the gun as an object. So once the robot find the object, so it can just directly approach and then stay nearby there. Yeah. So we did a lot of stuff, and there is this is my PhD thesis, like for diagnosis of a reconfigurable crawling rolling robot based on support vector machines. Because in machine learning, there is a many applications they use in the machineries like lathe machine, milling machine, those kind of machines. But some of the robots, of course, yeah, some of the robots they used to use the machine learning approaches to detect the noises, detect the faults and those things. But I think in the reconfigurable robot field, very limited stuff is using machine learning. So what we plan, we wanted to use our robot itself, like in the reconfigurable robot, our Scorpio itself. So what we did, like we use a support vector machine to detect the fault of the each leg. So what we are using here, one single IMU sensor. We didn't use any other sensors. We use the IMU sensors and an encoder feedback from the servo motor. That's it. So if the robot leg got broken or something, so we made that fault. Sometimes, like, we break the leg and then we just let the robot run. So what will happen? And then, yeah, this is our test site, the environment of it. So this is what we got. So it's quite clear, like so for this is a fault, non-fault, and this is fault. And we did two. This is, for example, I'm putting the platter here. Backward locomotion and curve left locomotions. So this is all the locomotions here: rolling forward, backward, right turn, left turn. And then these are the degrees, like a speed, how many degrees it can turn in one period, like 1 second or something. So this is the 3, 6, and 12. So these are the results. It's quite reasonable. It's more than 90% of result, more than 90% result. But with the limited sensor, that's really nice. So I used CSVC and VSVC. So we did the two motions like the linear kernel and radial basic function kernel with those, and then finally we found out like we tested the method of the crawling, rolling robots locomotion in over different three speeds. We tested the algorithm using two different types of SVM, namely called CSVC and VSVC. So in addition, we tested two different kernels as well, and then the result indicates it's more than 90. It's 90% of overall. In the overall accuracy of all four classifiers is above 97% of it. Yeah. So finally, like so what we did now, because we finished this project, we hand over to to Singapore military, and then what we start with, like afterwards Singapore military mentioned like they take out some of the technologies from that Scorpio, and then they mention like, okay, you guys can do whatever you want to do. You want to commercial it, you can commercial it. So what we plan, like we try a edutainment robot, which is this is an advertisement video. So whoever like it, you can just order from now onwards, I think. Yeah. Yeah, thank you so much for inviting me as a speaker. Thank you, professors. Thank you so much.
Thank you, Dr. Karthik, for such a nice presentation.
Yeah, thank you, thank you.
I would like to also introduce that to the participants that Dr. Karthik is the chief robotic architect designer in our team. Like most of the platform which you are seeing is designed and conceptualized by him. It ranges from Estetro, Tarantula in today's presentation, even Panthera. So the brain behind the architect is Dr. Karthik. I'm inviting audience to the participants to ask questions, which I suppose everyone will have after watching this interesting video. Please go ahead and ask questions from Dr. Karthik related to this bio-inspired design. Thank you.
Yeah, thank you, Amar.
Any participants, please go ahead and you can open your mic and ask. We have time, 7 minutes.
Yeah, I think I had some question. I think it's disappear soon. So how to obtain the forward and backward locomotion, the leg rotation you were talking about, right? Yeah, I think so. So what we did, like, yeah, those legs or each and every legs have a 180-degree rotations. So which is I just minimalized like which leg need to rotate in which direction to which direction. So if you see in Scorpio, the front legs, it won't rotate much. So it will only go downwards and then it will just fold from there. The back legs, it's need yeah, the back legs need to rotate a 90-degree turn above. Sorry, it's 180-degree turn above, and then it will just make a circle. So that's what we did. Yeah. Thank you. Next one.
Hello, Dr. Karthikeyan.
Yeah.
This is Karthikeyan Pasraman.
Oh yeah, Karthik. Yes.
It was a wonderful presentation you have given now.
Yeah. Thank you, Karthik.
I need to ask, what is the response time for each gate to recover from each gate? From, for example,
Means like the recovery gates you were talking about.
from
Hello.
Yeah.
rolling to crawling. Response time.
Oh, the rolling to crawling. Okay.
To
The rolling to
transform
crawling, what we showed in because we, yeah, one phase to another phase. Like you mean like crawling to rolling to crawling or upside down recovery. So those stuff is 30 seconds, is less than 30 seconds because we don't want to stress the motor, the servo motor, because it's anyway it's a prototype at the moment. Sorry.
No, I'm just
Hello.
Yeah, I'm just listening. Like,
Oh yeah, okay, sure.
30 seconds.
Yeah, because for the rolling to crawling, it's depend upon the which direction it's need to go up to the home position, because the rolling is backward and forward. There is a two matters. Yeah, there's a two matters. Like if it is backward, it's need to go upside down first. After that, it will recover. So that will take 45 seconds. So the rolling to crawling immediately, like it will be 25 seconds to 20 seconds. So it's very quick. For the recovery, different recoveries have a difference. So it's not exceed more than 45 to 50 seconds. Yeah. I had another question. It's waterproof, not at the moment, but eventually it will be waterproof, because what we did, like we have a spray which can able to do the water spillage proof. We can spray it all the electronics components, so which means the robot is completely kind of waterproof, but it's not, you cannot dip into the water, but the spray you can able to accommodate. Yeah.
Since it is used in security surveillance purpose,
Yes.
the 30 seconds seems like a very large time. Can we
Means
make it much lesser?
much lesser. Yeah, of course. Because this is this a prototype. So for the prototype, what it will do, like the servo motors, it's commercially available, but even eventually it will move to the military grade, which means the motor is more robust and then it will be more faster. Obvious, we can go with 10 to 15 seconds even. Yeah.
Yeah, you
Yeah,
also
that's matter of
mentioned that
the hardware. Sorry.
you also mentioned that CPU is for sale. What is the cost of each robot?
Each robot is $350 Singapore dollar. Yeah, I'm just kidding. It will be soon, but yeah, it will be there. Yeah, we are making the we are going to that trajectory. So hopefully, yeah.
Thank you, Dr. Karthik. It's an amazing work.
Yeah, thank you, Dr. Karthik. Yeah, thank you. Any questions?
One quick more questions. We have still 2 minutes. One quick question from the audience.
Hi, Dr. Karthikeyan, this is Nishan here. Just one quick question, right? First of all, interesting piece of innovation, great architecture which can do multiple locomotion with one single robot.
Yeah.
So you mentioned regarding I think like during the afternoon session, Professor Rajesh Mohan Hidara also shared a commercialization effort. And I'm pretty sure that this is one technology which definitely has a commercialization effort. And you did mention that it's going to be a toy. So can you elaborate? Yeah, could you please elaborate more on toy, like what kind of a toy it is, and just to see like how feasible it is in the future.
Okay, so what we are planning, like, it won't be toy for just normal toy. It's a entertainment toy. It will be an entertainment toy because what we are doing, like nowadays, there is a fixed robot. Some of the robots they are using, but it's very expensive. So what they're doing, like they can use simple motors to assemble and then programming skills and those things. Why we don't want to use it our Scorpio itself? Like we just think about the Scorpio. Yeah, of course. This is a every people will like it with the transformation and then multiple locomotion stuff. So what we can do, like the even basic level, because we have a three different types of product. One is we are targeting the kids, which is elementary school level. So what they will do, like they can use a simple motors and everything. It's a quick fix, so they can just plug and play. So they can plug it and then with the buttons like a Lego, and then they can use and play with it. And then eventually it will move to the higher secondary. They can able to code it, and then they can able to do whatever they want to do. So we can use this to teach them a variety of robotics programs and those things. Yeah. So that's what we're planning at the moment.
That's great. I think that's really
Thank
great.
you. Thank you, Nizam. Yeah, thank you.
I think that's really great. Thank you very much. I think in terms of edutainment, right? I mean, I've seen some robots which are mostly like which are capable of single locomotion, but this is something which can do multiple locomotion. I think it's a very great toy where it will be useful for edutainment. Thank you very much.
Yeah. Thank you. Thank you, Nishan. Thank you.
Thank you. So we have our next speaker with us. He is Professor Ruwan Chandra Gopura. He is a professor attached to the Department of Mechanical Engineering, University of Moratuwa, Sri Lanka, and a former head of the Department Mechanical Engineering. Gopura is a chairperson of IEEE Sri Lanka section in 2020. He was the chair of IEEE Robotics and Automation Society Sri Lanka section. He is a senior member of the Institute of Electrical and Electronics Engineering, that is IEEE, and IEEE Robotics and Automation Society. Rowan Gopura is also a founding member of Sri Lankan robotic meetups. I would like to invite Rowan Gopura to share his slides and continue with the presentation. Thank you.
Thank you very much. Hope you can see my slideshow.
Yes, we can see the slides, and we can also hear you, and we can also see you in the video. Thank you.
Yeah. So I have power cut, maintenance power cut here. Hope my batteries are okay to continue the presentation. So today I'm going to present robotic exoskeleton for assisting motions. So give me a second. Right. Today, I mainly focus on what is exoskeleton robot, their usages, and recent research that we have carried out in this area at the University of Moratuwa, Sri Lanka. So, because of the increase. Sorry, host, if you can mute the other participant, it will be very helpful. So, because of the increasing of number of physically weak people, so the present and coming society can be identified as an age society. That means more percentage of population is age more than 60 years old. So, if you see the current age structure, you could see that billion of people are age 60 years of age. When it's come to 2050, so this number will be increased to 2.1 billion. because of this reason, so we have to think about age population and especially their welfare. And also because of injuries, congenital disorders, strokes, and diseases, more percentage of population in the world is physically weak. Robot scientists, robotists, we have to support them in a possible way. In addition to that, because of these physically weak individuals and some other factors in the world, the working population is decreasing, especially countries like Japan, as well as in the South Asian regions. This issue can be seen. Because of this diminishing of working population and increasing of physically weak individuals, healthcare industries face major issue in providing support for their physically weak individuals, which also affect the socio-economic growth of the globe. In this situation, robotist or the robot scientist, we can play a vital role. In this situation, what we can do is we can develop to assist physically weak individual or the patients. If you take assistive kind of a robot, categorize them in several ways. So one is power or the motion assist robots used for the assist of the limb motions or limb power. Assistive robots like surgery support systems, surgery assist systems like Da Vinci. Kind of assist robot, you know that there are bots especially for the cleaning services, cleaning purposes of households. So household assistive robots are also considered as assistive type of robot. And also, if you take medical assistive robots and power or motion assist robot, we can categorize again, especially the motion assist robot, as prosthetic devices and orthotic devices. Prosthetic device is a device which replaces the missing body part. Device which gives the power for the existing body part. So this exoskeleton robot can assist especially the individuals. What is an exoskeleton robot? Is an external structural mechanism with joints and links. Those are corresponding to the human limbs. See this diagram. So you could see that your inner skeleton and you have your joints, device is parallel to the human joints, parallel to the human joints, which we call the exoskeleton. Exo means outside the body. So parallel to the inner skeleton, we have outside skeleton. This device can be used to power the weak limb. So these devices are wearable device, can closely fitted to the human body and work in concert with the joints and limb segment of the human. So these device can be used to power the weak body part. So if you consider the exoskeleton and the wearer, we can consider them as human machine combined system. The specialty there is the machine can provide the power which is less in the human being in the case of a physically weak person, and human the intelligence to this combined system. So therefore, we can have a system which has advantages of intelligence as well as advantages of the power. see in all over the world. So this is HAL. You can see in the figure HAL hybrid assistive limb. HAL 5 developed at the Japan, and also Tokumat for the rehabilitation purposes. So if you take exoskeleton robot, we can use for them for many purposes. One application is clinical rehabilitation. So if your knee is weak, so you want to get the support of the therapist. So therapist feed the motion to the exoskeleton robot, as you can see in the video, and then robot can perform the same motion repetitively. So clinical rehabilitation, we have two types: rehabilitation of your limbs or body parts, as well as neural rehabilitation, rehabilitation of damaged cells of the brain. Another application of exoskeleton robot is teleoperation of systems. As you can see the second video, so the system developed inside the computer, so you can control using the exoskeleton worn by the human being. So these kind of systems can also be used for operation and also for the rehabilitation. And power assist, as mentioned, is it's assisting your limb power, and power augmentation, again assisting your limb power, but there's a difference between power assist and power augmentation. Power augmentation means you have the required power, but you need additional power. Like in military personnel, they need additional power to carry the backpacks. So that is power assist, and power augmentation is you don't have the required power to carry out the motion. For that, you need some power. So these kind of purposes, exoskeleton robot can be used. For controlling of these devices. Now, if you use exoskeleton robot for motion assist or the power assist, the system or the exoskeleton robot should work in accordance with your motion intention. Otherwise, it is useless. That is, if you think that I want to do this motion, I want to carry out, say, elbow motion, elbow flexion extension, the robot should support the motion while we are thinking at the same time. That is, the human motion and the robot motion should be synchronized. For that, we can use biological signals like EMG, we call electromyographic signal, and EEG, electroencephalography signals. So lower limb exoskeleton robots, we can use foot pressure sensors to give input to the controller, and sometimes hybrid type of exoskeleton devices are available, which uses biological signal as well as sensor signals. And also there are other type of controllers in the exoskeleton robot which uses the kinematics of especially the walking to control the lower limb exoskeleton robot. We can get the kinematics of gait cycle, and using that we can program the device. So these are the basic ideas of the exoskeleton robot. So then I will briefly go into the projects that we have carried out at the University of Malappuram. So in 2012, so we developed a lower limb exoskeleton robot. So it is 2 degrees of exoskeleton robot. It can power your hip joint and the knee joint, and it is a standalone system. That is, the required backpack circuitries and the motors and the power, everything is inbuilt in the system. Unfortunately, we couldn't control this properly because of the issues of the motor. But this video shows that the system can generate the required human motion without any interference to the motion of the human. So then late in 2018, we developed a compatible joint ankle exoskeleton robot we call CJE. So specialty of this one is it has 3 axes which are aligned to the human joint axis. So this robot can generate 3 degrees of freedom of ankle, inversion, eversion, plant flexion, dorsiflexion, and the rotation of the ankle joint. Right. So this one also can be used for the human motion assist or rehabilitation of ankle joint. Right. So to verify the assistance that the robot can be given, we carried out few experiments. So what we did was we carried out ankle motion, ankle dorsiflexion, plant flexion motion with and without the exoskeleton robot. The motion with the exoskeleton robot, of course, the power the person should give to carry out the motion should be reduced. In the diagram, the line shows the gastro muscle signal. So you can see the in the without exoskeleton figure, the EMG sensor. I've taken EMG signal from the gastrocnemius muscle. So you could see that the muscle signal has reduced with the support of the exoskeleton robot. So we carried out several experiments with this device, and we could identify that the robot can provide 30% of assist rate. That means, so the 30% of power of the ankle joint can be supported from this compatible joint ankle exoskeleton robot. Last year, that is 2019, beginning of 2019, we developed another exoskeleton robot. We named it as Anthrox. So this one can be used for especially for the rehabilitation purposes, lower limb rehabilitation. It has 2 degrees of freedom, hip 1 DOF and knee another degrees of freedom. The specialty of this one is we developed the knee mechanism and the hip mechanism to have the anthropomic nature of the human motions, as well as to cater the axis changes during the motion. I'll explain that one. So when you carry out the knee motion with the motion shown in the first figure, the rate of rotation of axis is change. So to cater that change, we develop the robot. So the next one is the chair that we developed last year, which assist your sitting, which is called sitting assistant robot. Of course, this can be used for industrial workers to get the different sitting postures or different crouch postures. But this device cannot be used for the physically weak persons because the prototype is a little bit higher weight. So therefore, this device can be used for only for industrial workers. The specialty of this one is, as you see in the video, so it can take different crouch postures. So in this case also, relevant circuitries and everything is in a small backpack. For the safe, the person gain the sitting postures, we lock a ratchet system. So this skeleton chair can be used for industrial purposes. In addition to those, last year also we developed some other exoskeleton device. You can see a hip exoskeleton robot, which can be used for lifting, which can support for lifting of heavy weights. Also, another exoskeleton robot, passively powered exoskeleton robot, we developed last year. It's a knee exoskeleton robot. It does not have any motor, but it can give power when you do squatting motion, especially when you lower your body. Squatting motion, when you will lower your body and raise the body. When you lower your body, it can gain power and store it in the mechanism. So when you use the upward motion, the stored power is released. So inside the knee mechanism, we have the spring systems. So this one also we checked with different healthy male subjects. So we could identify it can give 20% to 30% assist rate. That is, it can give 20% to 30% assistance of the power of the knee joint. So that's all for the day. So, exoskeleton robot are external structural mechanisms with joints and limbs corresponding to human joints and limbs. Those can be used for especially clinical rehabilitation, teleoperation of systems, power assist, and power augmentation. So we have developed some system. Still, we are using the system with validation experiments, and we have not done clinical trials because this kind of system working with human beings, so we have to do a clinical trial, especially for the rehabilitation purposes. So thank you very much. If you have any question, I can answer.
Thank you, Professor Gopura, for
yes,
introducing us to the exoskeleton developed in your lab. And it ranges not only from like arm exoskeleton, but like almost every part, like and knee, ankle, hip, arm. So I was aware of like with the arm exoskeleton, people were developing at IIT Delhi in India. So I was aware of that, but the development with the knee exoskeleton is very impressive. I have one question. Let me start from me as well. So, in the knee, how you cater for the degree of freedom that is available in the knee? So, your mechanism is only designed for the as per the knee's degree of freedom, that is abduction, adduction, and flexion, whatever the motion is provided at the knee joint is only considered, or it has more redundant degree of freedom that is not there at the knee and the mechanism has it.
Yeah, for the moment, actually human knee, we have mainly the knee flexion extension. So in this case, we only considered knee flexion extension. We didn't put a redundant degree of freedom, because if you put a redundant degree of freedom, when you control it, it will be a problem. For the moment, we have only flexion extension, 1 degree of freedom, but for that degree of freedom, since the axis of rotation is changing with the motion. For that, we have a special mechanism.
I think in the front there was a passive joint which was helping in that, right? If you can play that video, there was some passive joint in the front which is pivoted, I think, about the knee joint, and that was helping.
Oh, so just a minute, I'll share the again. Yeah. You're mentioning about this one.
Yes. Okay, this is a 4-bar, similar to 4-bar, right?
Yes, but exactly not the FOBA. Yeah. I have one.
Okay.
Consider these bars. You mean about this passive degree of freedom in the frontal plane? Yeah, we have one passive degrees of freedom in the frontal plane, but
Yes.
we can lock it. We can lock it.
Okay, sure. Okay, thank you, thank you. I got the point.
Yeah.
Okay. From audience, we can have quick questions. We still have 5 minutes for the next presentation, so please go ahead and ask a question from Professor Gopura. From audience, please go ahead and feel free to ask. Even you can type your question in the chat box so that we can take from there.
I couldn't see any question typed. Have any question about the exoskeleton robot? So the lower limb exoskeleton robot, very important thing is to get the balancing. Unlike in upper limb, so balancing is very difficult to get, and retain the balancing is also very difficult with the physically weak individuals. And one question is the material used. So so I have different devices I have explained. So in most cases, we have used aluminium or 3D printed parts. In most cases, aluminium frames, and we use also some part 3D printed. But currently, we are carrying out a research project to develop a soft exoskeleton robot, because in the soft devices are trending now. We are trying to develop soft actuator for soft exoskeleton robot. But with the soft actuator and soft exoskeleton robot, the power that we have taken is an issue. But if you combine soft exoskeleton and the hard exoskeleton, that is with the aluminium or metal frames, so that will be kind of a very innovative as well as very good product in the perspective of exoskeleton robots.
Any more questions? Else I have one more. So are you using these devices for teleoperation as well? Some teleoperation activity, or it is just for assistance?
Yeah, for the moment in our laboratory, we have only used for assistance and rehabilitation, but not for the teleoperation. But in our university, some other laboratories, they are using this for the teleoperation. They use teleoperation, and with the teleoperation, they are trying to get the neuro kind of neuro rehabilitation, trying to achieve neuro rehabilitation.
Still, we have 2 minutes. Some more questions, please.
Sir, audible?
Sir, I have a question.
Hello.
Yes, yes, please
Yeah.
go ahead.
Sir, I wanted to ask how can you detect and evaluate the signals to the muscles from the brain so that the exoskeleton works?
Yeah, now in our cases, we use EMG signal, that is muscle signal, muscle activity level. To extract the muscle activity level, we have EMG extraction systems. So what we have to do is we have to attach the electrodes on top of the surface of the muscle, or we can use intramuscular EMG electrode. Intramuscular means you have to insert it into the muscle, but practically we cannot do that for day-to-day activities. Therefore, we use surface EMG, and using surface EMG electrodes, we extract the signal, and then we amplify it using an EMG amplification system, and then those signal we process to use for the exoskeleton robot. We took RMS signal of the EMG. Did that answer your question?
Thank you, sir.
Hello, sir. I have one question. Is audible?
Yeah, okay.
Yeah, doctor. I am Dr. Kumar, sir, PRIST University Assistant Professor, Mechanical Department.
Okay.
By this method, we can able to pick the load.
Sorry.
What I'm asking now, we can be able to pick the loads. Some materials are part, and what is the maximum limit to pick the load?
So you mean load lifting with the exoskeleton robot?
Yeah. That's right. Load.
Yeah. Yes. Again, so as I mentioned earlier, so this exoskeleton robot, so we can provide kind of an assist rate. That is the support that can be given by the exoskeleton system. In most cases, so the similar to the support given by the exoskeleton system, we can lift or handle the loads with the exoskeleton robot.
Okay. So with the support, I think it can be able to independently.
Yeah. Now, actually, the people's the person or the wearer control should be there. Wearer give the intelligence. As I mentioned, wearer give the intelligence. The machine gives the power. So we can design the device as per our requirement. If you say if we want to lift 50 kilograms without any feeling of the weight to the body, so we can design the system, giving the designing the motors required for the system to pick up 50 kilograms. When we design the system, we have to consider about the load we are trying to lift.
Okay, sir. Okay, thank you, sir.
Thank you so much, Professor Gopura, for introducing the audience to the application of exoskeleton in multiple domains. Now we have our next speaker with us. He is Mr. Gopaka Ganesh Sai Apuru. He is currently pursuing his dual masters in nanoelectronics engineering and design from Singapore University of Technology and Design. He graduated with a bachelor's degree under ECE discipline from Amrita University in 2018. He previously worked as a visiting researcher in SUPD. During his undergraduate term, he was a student researcher in HUB labs, working under various projects, and also was a part of IEEE SP leadership. His areas of interest include autonomous navigation, for robots, embedded system, and deep learning. So the presentation now is up to Mr. Apuru. Please go ahead. Thank you.
Yeah. Good evening, everyone. I hope I'm audible and my slides are visible.
Yes, you are audible and slides visible.
Okay, so thank you for such a wonderful introduction, and I extend my warm greetings to all the students and dignitaries from academia and industry who are attending my webinar today. So I'm Aparup and I'm a robotics enthusiast. So I was always aspiring to work or build solutions that can assist human beings in their daily activities. So robotics is one such field which enables us to achieve that aspiration. And as you know, like in today's world, it is pacing progressively uh, and rapidly towards imparting automated solutions to help and to enhance the efficiency of human beings that are working in different fields. So it is quite obvious that the major companies like you've seen or you've heard are working towards and making significant attempts in creating their own mark in the global ladder in terms of robotics. So one such company, which you all know, is Toyota, and it made a significant leap in creating few robots that help in making that help in increasing the efficiency of the human beings. So today I'm going to discuss and show one such robot from Toyota and what all applications that we have built over that hardware platform. So today's presentation will be structured as follows. I'll be introducing all of you to Toyota's human support robot, which is a robot that we are going to see in the rest of the presentation, which is followed by a glance at its capabilities and what all things that it can do. One more thing, main important thing of this presentation is focused on the applications and the open-ended solutions that we have built using this robotic platform, followed by a conclusion and a question answer session. So coming to the introduction, Toyota's human support robot is a multi-purpose research platform. I just want to drop a few background points over this. So Toyota has built this hardware platform and picked 16 global universities to build open-ended applications based on this platform. So SUTD is only university from Singapore to get fortunate to work on this particular platform, and all the open-ended applications that are built on this platform were done under supervision of Professor Mohan sir. And this is basically designed to support human activities. That means it has to navigate through tight spaces in a domestic setting, like in houses or in caretaking places like hospitals, etc. So for that, it is important that the robot body and the locomotion has to be very specific. So the designers at Toyota had kept this thing in mind and created this robot with a lightweight body and provided it with a holonomic drive capacity for easy maneuvering. Also, since this is a research platform and the main objective is to create an numerous open-ended applications, so a wide range of sensors are also secured on this particular robot, along with provision of 5 degree of freedom robotic arm that you can see in the image. And in order to reach for a maximum space, they also provided the design in such a way that the torso can be adjustable, which is in a telescopic way, and thus it achieves an extended configuration space. Coming to the World Robot Summit, we are also participating in that global challenge where we are bestowed with the task to create algorithms that can help this robot to perform the challenges such as tidying up a particular place or bringing some particular object to the user, etc. So even efforts are being made to develop this platform towards that. So it weighs about 40 kg and can move with a speed of around 0.8 kilometers per hour because this speed is way much enough in domestic and hospital settings, for example. And the arm that is provided here can be used to lift objects that are with weight around 1.2 kg. And also, for example, the robotic arm has to grab something which can be either a glass or it can be a disposable cup. So there should be a different force that has to be exerted on the type of the based on the type of the object that it has to grab. So a force sensor is also secured on the end gripper, through which we can monitor how much force is being exerted on a particular object based on its type and characteristics. So as you see, there are a lot of sensors and a lot of mechanisms all running on this particular robot. So there should be a stable platform for it. And HSR runs on robot operating system, and this is a framework. It is simply to put it as it can be a meta operating system where you will be having a lot of packages and at a different layers, and this can be used as a central central software part where you house all the packages and other software related things. And this helps in controlling the robot in a very orderly manner. So as you know, before we execute any R algorithms, we have to test it on the robot in a simulator, and that is must. So in order to do that, there is also this provision where a file called as universal robot description file is provided, which is nothing but it is a file that contains information about the links and joints of the particular robot. So what exactly happens is that this file helps the user or the developers, which are us in this case, can be used to spawn this robot in a simulator, such as Gazebo or any other simulator, and it will help us to execute our own algorithms that we develop before deploying it in the field. So that is what we do here. And ROS also helps in various ways because it is quite famous for its distributive computing and easy testing, which is also rapid. And the software reusability is exceptionally good. And that is why almost all the robots in the world are now migrating to this particular software. Coming to the capabilities, as mentioned earlier, this robot has a wide range of sensors like a RGBD camera or a dual stereo vision camera, a microphone array, a force sensor, a magnetic strip sensor, a laser range scanner, and so many other things. And as you can see here, the robotic arm is used to pick objects and place them at wherever the user chooses them to be. And another important aspect for this robotic arm is that it can also pick thin objects like a sheet of paper using the suction mechanism that is secured on its end gripper. So that is quite a good design. And as mentioned earlier, force sensors and wide angle camera on the gripper helps to capture the coordinates of the particular object that it has to pick. And then the robot can easily grab that and avoid any other obstacles and take it safely and keep it in another place. There is an image down in the right side corner which shows that the position of that particular object is estimated in a 3D space. And once the coordinate is estimated by the RGBD camera, certain translations happen, and then it is fed to the inverse kinematics motion planner, and the motion planner then plans for the path that the robotic arm has to take. So once the robotic arm has got its motion plan, it will just execute it to grab the bottle. And as you can see here, the another set of images. This is one of the challenges which we are trying to achieve. So a lot of objects that are scattered all around the room has to be cleared out by the robot, and it has to place the objects exactly to their corresponding places. Like a water bottle has to go into the refrigerator, something like that. So efforts are being made to create algorithms that can execute this task. Also, the microphone array that is secured on the head of the robot helps us to talk to the robot. So simply, like, instead of talking to the robot through a tablet or a computer, you can simply say that, okay, hey robot, go fetch that water bottle and give it to me. So the voice recognition model helps the robot to understand the keywords, and then it will locate for the water bottle, go fetches the bottle and gives it back to the user. Since this is a research platform, a lot of communication ports are also given if in case the researchers or the developers want to have an extra set of hardware systems. So coming to the continuation of the capabilities, there is also a 7-inch screen that is secured on the head of the robot. This can be used to communicate with people remotely. Just like you can take an example of this WebEx meeting is happening, right? Similarly, we can talk over remote people through that screen. Also, there is a secondary computer, which is a graphic processing unit that is secured inside the robot to perform deep learning calculations or take any set of extra computation tasks. And one more interesting research topic is the robot expression. So it is something like robot knows what it is doing, but it also has to express to the user, or it has to express to the people surrounding it. And it should be able to convey what exactly it is feeling, right? So even steps were taken to touch that research topic by this particular robot, and interactive LEDs were set up depicting different states of the robot that it is undergoing. So for example, if it is in a stable state, it will have one type of color. If it is in a different error state, it will have a different type of color, and that will tell the user that there is something problem with this robot and he has to troubleshoot it. Also, HSR can be controlled through various means. One is the mainframe workstation, another one is a joystick, and the third one is a human machine interface, something like a tablet. These control mechanisms are not limited to these three things, but it can be expanded also. So what happens is that the user can sit at a mainframe workstation, and the robot can be connected over a wireless network, and the user can give his own commands to the robot. So coming to the applications, this is really interesting because we have worked developing algorithms for this. So as you see, the images here is of SUTD's library. SUTD library is a 3-storied place where a lot of things there. And this is actually an example of modern architecture where it is not like a conventional library, but with a lot of spaces that are designed particularly for this library. So it is kind of challenging, but at the same time interesting to develop and build this robot for that particular application, which is a tour guide and a surveillance, because there are a lot of people visiting this particular place in SUTD for various purposes like meetings or collaborations or even discussions. So surveillance and library tour guide is a strategic aspect in that sense. So we developed HSR to perform these applications. Let us see what exactly we did. So before running a robot, it has to know and it has to understand its unknown surroundings. For that, we do mapping. So trials have been done to perform 3D mapping as shown in the video. So the video shows that the robot is capturing the unique distinctive features that are present inside the room, and also having a sensor fusion, such as combining the odometry, IMU, and the vision data to localize itself at the same time simultaneously map the location. So what happens is that we did these trials, and actually it is quite computationally intensive. And we also performed 2D mapping, where you can see the 3 images at the bottom, and these are the 3 images of these 3 images are the floor plans of the SUTD library that we mapped. And once we got these maps, the 2D coordinates of places of interest are extracted, and these 2D coordinates are then fed to the ROS navigation stack. So the ROS navigation stack houses many components, of which now we will be looking at a global planner. This global planner takes the two coordinate points or multiple coordinate points, and then it will plan a path between them or among them. Okay. And while navigation, HSR avoids dynamic and static obstacles. And during that time, the local cost map will be used to estimate dynamic obstacles. And how we made this 2D maps is that we manually ran the robot using the joystick, which I mentioned earlier, as a control means. So this is once we got the map, it is time for the robot to execute the point-to-point navigation within the library, and it has to go to the places of interest and then speak the importance or significance of that place. So for that, we have done we have utilized a speech synthesis module, which is open source, and integrated that module into the HSR, and we have written a predefined text. Upon reaching to that particular point of interest, the robot is going to speak that predefined text. Also, there we have created a small, a simple GUI Python-based GUI that can be used by the person in charge who is controlling the library tour. And this GUI shows the points of interest where the personnel in charge can click, and the robot will proceed to that point. At the same time, the in charge can also look at the live camera feed that is being transmitted from the robot. So he can just jump in for a manual intervention if there is any problem. So the next thing would be surveillance. You must be having a doubt why there should be a surveillance robot inside a library, because SUTD library has certain ground rules where people shouldn't be carrying eatables or drinkables inside, or they shouldn't be discussing very loudly. So these things, to maintain these ground rules, usually the staff goes on rounds, but in order they can happily control this robot over a wireless network through a joystick, which we developed on a custom based. Then they can, based on the live transmission feed that they are getting from the robot, they can easily monitor, thus scattering their time to most important and pressing needs. So what happens is that there is a master workstation, and a joystick is connected through a custom based through a custom developed joystick module, and that joystick module can be used to operate the robot over the wireless network, and speed and voice modules are also integrated into it, so that the personnel in charge can speak to the student or can speak to the visitor. So thus exploiting this voice synthesizing modules, we have extended its application to one more step, which is converting this robot into a receptionist, where HSR is designed to answer most of the frequently asked questions. So there is a we have used we have used this particular voice synthesizing module to recognize keywords and then give out the corresponding answer. Another important application is at a food court, which we used this robot to clean based on the type of food litter that is present on the table. If it is a liquid, it will just wipe. If it is a solid, it will it will sweep. Based on we have created a custom-based deep learning architecture to detect the position of the food litter and then clean it accordingly. So this is the architecture. We have utilized the sensors that are on board, and the GPU is also utilized to perform deep learning calculations. Similarly, as mentioned earlier, the coordinate points will be extracted, and those coordinate points will be translated and then sent to the motion planning algorithm. And that motion plan algorithm will perform the arm motion, and thus the robotic arm will clean. So these are some of the results. And the thing is, like, the robot will perform initially one iteration of cleaning and look for the stain. If there is a stain, more stains, then it will again perform another cycle of iteration. And until it reaches a certain threshold that it detects there is no stain, it will perform the series of iterations. Another aspect of the application is deploying HSR as a maintenance robot, where nowadays in the wake of COVID-19 times, it is really necessary to sanitize and maintain all the places. So door knobs is one of the main important places where people come into contact with frequently. So we have developed this spraying module, which sprays the disinfectant on the doorknob by detecting it using the deep learning architecture that is running on the robot and cleans that particular doorknob. So in conclusion, we have used HSR to develop many open-ended applications, and its technical capabilities are also discussed here. And we have discussed how it can help increase the efficiency of human beings where they can concentrate on more pressing issues. And this will help assisting the human beings in their daily activities, like I mentioned, and thus solves the purpose. Also, efforts are being made to create more open-ended applications with this research platform. So I thank everyone who attended this webinar. So it's question answer time.
Thank you, Apuru, for the presentation on human service robot by Toyota and the nice application developed using it by your team. We can have quick questions from the participants related to the wide range of tasks shown using the application developed by Apuru and team. Please go ahead, feel free, and open your mic and ask. I can see Dr. Manuel is here. You can ask questions, right? Money.
Sorry. Hello. Yeah.
Yes, I'm here. Can everybody hear me?
Yes, yes, it's clear. Please mention your name and then ask the question.
Hello, I'm Dr. Manuel.
Hello.
Hi, Apuru.
Hello.
Okay, one of my questions is basically focusing in your experience about what do you think you need to develop the same technology, the same thing, same applications, but in your country with your capabilities and the resource that you have in the universities. You know, because we know this robot is expensive, but now you have the knowledge, right? So you think it's possible, and how you can make it?
Okay, so that's really a good question, because a lot of innovations happen by visiting various different countries and through knowledge transfers. So this robot is expensive because it houses a lot of sensors, because the main objective of this research platform is to create open-ended applications and to know what exactly this robot is capable of. So I think that if they call universities or the students who are focusing on the problem, then they can definitely know what exactly or what exact hardware components or the software related things that they would require to build a robot. And that would be really cost efficient. So one more thing is that now manufacturing is picking up in India. And since this is this can be easily built with available material that is currently available in India, I think approaching the problem is the main aspect in building these kind of robots. And if we understood the problem and how we can approach to that with respect to this hardware and software fusions, then I think it is really cost effective to build such kind of robots, because basically robotics is all about emulating our own lives, or how we are approaching to performing some task, right? So if we are picking up something, we are just doing that action, like we are coding that action in a stepwise manner and feeding it to the computer. And the computer is just emulating our human way of picking up or grabbing things. So I think the main answer, my answer would be like focusing on the problem would solve that issue.
Great. Thank you. Thank you so much, Apuru.
Yep. Thank you so much.
One quick question, or we have another speaker with us.
Okay.
One quick question we can still take.
Sure.
If no question, we can move on to the next presenter.
Okay.
So let me.
Sir, I have a question.
Okay, please go ahead.
Sir, I wanted to ask, how are you using the camera and force sensors to detect objects, the distance between them, and avoiding obstacles?
Okay.
Can you give some brief about that?
Okay, sure. Good question, actually. So, what exactly happens is that force sensor is an attribute in that entire function, where the main weightage goes to the camera sensor, because the camera is a depth sensing camera, where it can through a series of filters we can estimate the 3D position of the particular object. And once we got the 3D position of an object, as I've shown earlier in the image, in this, yeah. Through that you can estimate, I mean, there are certain algorithms which you can use as a motion planner to perform the arm motion to reach that particular point. So several translations happen internally, like the motion planner itself, like the motion planner's basic thing is that it should perform inverse kinematics to reach the particular given point. So the camera performs a major task here in identifying the coordinate. Force, coming to the force sensor, it is just a feedback, or it is just a control mechanism which enables us to know how much force it has to exert on a particular object. It cannot exert a large force on a disposable cup, right? It will just crush it. And at the same time, it cannot apply a light force on a glass. It might slip during the locomotion. So we can pre-program little things regarding the, based on the characteristic of an object, and accordingly we can proceed. So that means force sensor and camera sensors along with the other sensors go hand in hand in executing the task. I hope that answers that question.
Yes, sir. Yeah. Thank you, sir.
Sure. Thank you.
So thank you, Aparup. We have our next speaker, Dr. Satish Kumar Samiappan. He received his Bachelor's of Engineering from Bachelor of Engineering in Electronics and Communication Engineering from Bhatiyar University, Coimbatore, and Tech degree in Computer Science with specialization in Computer Vision and Image Processing from Amrita University, Coimbatore in 2006, and PhD in Electrical and Computer Engineering from Mississippi State University in 2014. He is currently an assistant research professor at Geosystem Research Institute of Mississippi State. His research interests are machine learning, pattern recognition, signal processing, and image processing, invasive species, and data-driven land conservation. So I would like to transfer the presenter.
Sri Lanka connect ಇಲ್ಲ
So Satish, can you hear me?
Yeah, I can hear you.
Yeah. Good. So you can go ahead and share your slides, and then.
Yeah, sure.
Thank you.
Can you see my screen?
Yes, perfect.
Good evening, everyone. My name is Satish Samiyappan. I'm an assistant research professor at Mississippi State University. I work for the Geosystems Research Institute, where we are the Center for Unmanned Aerial Systems. We do research by using like small drones. We fly small drones, collect imagery using different sensors, and apply to problems in agriculture, forestry, and typical urban applications. So in this talk, I'm going to cover a little bit about the sensors that we use on our drones, and a little bit about drones themselves, and how we do pre-processing to get the image mosaic where we can then apply pattern recognition algorithm. The main motivation for using unmanned aerial systems is typically you can collect ground information by using three different modalities. One is ground-based, where a person goes on ground, takes a GPS, takes a point and shoot camera, take pictures, take readings, and all that. That used to be the typical thing back in the days. And then we have satellite-based modalities. You get satellite images like Landsat, MODIS, and whatnot. And the third paradigm is collecting aerial imagery. So when I say aerial imagery, it could be a manned aircraft, like a typical aircraft that's a smaller size. You connect a sensor in there. As you can see in this case, so we have sensors connected on the belly of the aircraft that can collect imagery. And the last one is use of unmanned aerial systems or drones. So I call it unmanned aerial systems, not drones, because it's drone plus more computers added into it. So one of the motivation for using unmanned aerial system is there are a lot of drawbacks in existing systems. So if you want to do a ground-based data collection, it's time consuming and expensive. You go to a large area like a wetland, it's nearly impossible to reach remote sites. And also there could be wildlife, diseases, the terrain is not flat in most cases, and you won't be able to cover a lot of area to collect the information. So that's where remote sensing comes into picture. We can use space-based platforms like satellites to collect information. The problem with space-based satellites is the resolution of these images are very low. So when I say resolution, it's the spatial resolution, not the spectral resolution. So each pixel could be anywhere between 1 feet to, let's say, 15 feet, something like that. And also satellites don't look at the same location all the time. As the Earth rotates, it kind of makes a sinusoidal pattern around the globe. So if we need a particular location to be captured, we may have to wait for days to weeks for the satellite to reach that point. And the benefit of going for a space-based platform is it provides a larger coverage. So we can get an entire state, we can even get an entire country in like a matter of hours. So that's beneficial. And also the communication link between the satellite and the ground station requires the images can only be transferred very slowly. So it takes a day or two for the collected imagery to come back into ground, and then we do pre-processing. By the time you get the imagery, we won't be able to take like immediate actions on what we see. Like in case of a forest fire, you may want to take immediate action that may not be possible with space-based platforms. And another advantage of going for a satellite is that it's just there all the time. You just need to commission it and it'll collect the imagery. The next one is a airborne. That's by using a manned aircraft. Obviously, with a manned aircraft, you need to have a pilot, you need to have a nearby airport, you need to do a lot of planning. It's not unlike a satellite, it's just there all the time. You just need to redirect. And that's one of the drawbacks of doing a manned aircraft. Since it's not a space-based platform, it's an airborne platform, it flies like fairly low. So it gives you a higher resolution images, and we can go and fly whenever we want to, and we won't be able to cover an entire state or an entire country in few hours. You can only cover maybe an entire city or an entire county in a day. And like I mentioned, you need to have a lot of logistics planned to go collect. So it's kind of expensive. So here is where the unmanned system comes in. Unmanned system kind of mitigates a lot of drawbacks of manned aircraft. You don't need to have a pilot. You don't need to have an airport nearby. You don't have to do so much planning to go collect the data. At the same time, unlike satellites, we don't have to wait for days to get the imagery. And obviously, the drones tend to fly at a much lower altitude. So we get a very high resolution, centimeters, in some cases, sub-centimeters. It's very inexpensive. You don't need to spend hours on the field. And we don't need to worry about transferring the data, because the moment the drone lands, you just collect the SD card, put it into your computer, you have imagery. And also with space-based platforms and in some manned aircrafts, the presence of cloud is a problem. If we are collecting invisible imagery, cloud can obstruct what we want to see on the ground. With unmanned systems being flown at a very low altitude, you don't really need to worry about cloud. The only drawback is that it can only cover a small area. It could be a part of the city, a small part of the city. So that's the only drawback. So this is a little bit of introduction about unmanned systems, why we go for unmanned systems, and where it fits in the remote sensing platform spectrum. And this is the imagery that we have collected over a 10 square mile region in South Mississippi. There is a delta here, Pearl River Delta, and this is a very dense forest with a lot of waterways, as you can see. We collected this imagery like in 1.5 days. So it's very high resolution. Each pixel is almost equal to 5 centimeters on the ground. So you can imagine if there is a car in the ground, you can see that car from this imagery. And the only drawback is if there is a rain or some harsh wind conditions, we won't be able to fly them. And if it's an urban area, heavily populated, we don't usually fly them, because if something happens, if it falls, it hurts people. So the government regulation is one of the things that we need to keep in mind when collecting drone imagery. And talking about the drones themselves, there are like 2 types of drones that we usually use. There are hybrid varieties out there. There is the fixed wing. The small ones that are usually hand launched. So you just turn on the drone, the fan starts rotating, you just throw it in the air, it starts flying. And then a multi-rotor, you can just leave it on the ground, it takes off. You don't have to throw it. And with the fixed wing, it needs a landing strip, a flat area so that it can come and land. With a multi-rotor, we don't need to have a landing strip. So multi-rotor is useful for applications where you don't have a lot of flat area, and fixed wing needs something like that. And benefit of having a fixed wing is that it can fly a long time with a smaller battery, because just one propeller and the air kind of helps, the aerodynamics kind of help. But with the multi-rotor, all these fans need to be like rotating all the time to keep the platform stable. And as you can see, in both the excuse me. As you can see, both in the fixed wing and the multi-rotor, we have the IMU. The IMU unit records the roll, pitch, yaw, the GPS location of the drone that it's currently capturing. That is connected to a camera sensor where it delivers an electronic trigger so that the images of the ground can be captured. And the same setup is there on the multi-rotor platform. So you have the IMU, you have the GPS antenna, you have the camera. So this is how we collect the imagery. Once we collect the imagery, we have different camera platforms used by which you can collect the imagery. So you have an obvious one, like a typical point and shoot camera, like you have on your cell phone, that collects a blue, green, and red wavelengths. So somewhere around 450 nanometer, 550 nanometer, and 650 nanometer. That image is good for viewing it on a computer screen or a TV. So those images are something that we are all familiar with because we collect them all the time. We share them on social media. But the unmanned system payloads just don't limit itself to the visible spectrum. We collect images in the infrared spectrum as well. So that is in this region, 750 nanometer to 1200 nanometer. Infrared spectrum gives us the ability to understand vegetation in forestry and agricultural applications. So we are interested in sensing the IR spectrum. We usually don't see IR light in our eyes because the visible spectrum limits us to only see between 400 and 700 nanometers. But the information in IR is really useful. Depending on what kind of images the sensor collects, we can classify them into broadly 5 categories. Panchromatic is basically a scale image. We would, like in olden days, we'll say a black and white photograph. And the benefit of having a panchromatic image is it can be of very high resolution. Unlike a color, the sensors are like well developed, well tested. It can provide a very high resolution. Most of the satellite platforms provide a multispectral. And the second type is multispectral. Like a point and shoot camera that we have on our cell phone is basically a multispectral. It provides 3 wavelengths, 450, 550, and 650 nanometers, corresponding to blue, green, and red. And you can have infrared in your multispectral. You could have like a 750 nanometer, 850 nanometer. So that's what we call a multispectral. Usually the bands are very discrete. As you can see, there is a blue band, it's a green band, the red band, and then we get into the infrared spectrum. And the third sensor is a hyperspectral sensor. The difference between hyperspectral and multispectral is we typically have about 10 bands in the multispectral, but in case of hyperspectral, we have hundreds of bands in the same region. So if it's blue, we have tens of shades of blue. If it's green, we'll have several green bands. And the last 2 sensors are thermal and LiDAR. We use them ground survey and animal applications. Excuse me, I hear a lot of. Please mute. Please
I'm
mute.
trying to. Yes, yes, yes. I can also hear, but. Even the host is unable to like mute all. I'm doing that mute all, but that option is.
I don't.
Yeah, now it's okay. I think. Yeah, please go ahead. Sorry for the injury.
Yeah, no problem. So the thermal can sense the heat signatures. It senses in the infrared band. As you can see, we have trapped a wild hog. So you can see the hog here. It's not very clearly seen from a visible imagery. So this is collected from a Canon DSLR camera. We don't see them kind of clearly, but here is a thermal footage. You can see a clear difference in heat signature between the animal and the ground. So we use thermal camera for estimating the abundance of animals like deers, raccoons, wild hogs, and things like that. So this is an ideal application for monitoring animals in a field. And then a LiDAR, I'll talk about LiDAR a little bit in the coming slides. So LiDAR stands for light detection and ranging. It can give you the distance information or the height information on the ground. It's an active sensor where your sensor sends out a pulse and it records the return pulse, and the time difference between the transmitted pulse and the recorded pulse gives us then estimate of the distance between the sensor and then the point it touches. So here is a LiDAR imagery that we have collected by using a drone. And the one you see in the bottom is the actual RGB footage, and the one on top is the LiDAR footage. And when you see the water bodies are usually tend to be flat. LiDAR cannot estimate the exact height of the water because it kind of absorbs all of the near infrared light. So that's why you see kind of a flat profile in there. But you can clearly see the road, trees, and buildings on ground. Some of those buildings are barely visible if you see from a visible imagery, but they can be clearly seen from a LiDAR. And this is a multispectral sensor that we use. And I'm just showing this slide to see the size of the sensor. It's kind of very small. It can collect 5 bands. It's very lightweight. And it can collect a blue band, green band, red edge, and near infrared. So the reason why I'm talking about near infrared is because, as you can see, the difference between a stressed plant and a healthy plant can be clearly differentiated by using a near infrared band and a red edge band. You cannot do that by using a blue, green, and red band. And this is a point and shoot camera that we use to collect blue, green, red images. And so now moving on to talk about the processing of the collected imagery, we use a technique called photogrammetry. So photogrammetry is widely used in robotics and low altitude remote sensing. What it does is it uses multiple images to estimate the surface parameters. So what I mean by that is if we collect multiple images, as you know, the point and shoot camera or a multispectral camera, it can take only a snapshot. Just click, 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 keep on clicking. As the drone moves, it takes multiple pictures of ground. And in order to get a full view of the ground, we need to stitch these images together as a mosaic. And then the technique we use to create this mosaic is called a photogrammetry. And it also allows us to estimate the surface of the ground. So what is the height of this building? What is the height of this tree? We will be able to estimate that by using visible images. Yes, of course, we can estimate that by using a LiDAR, but photogrammetry allows us to get a similar estimations by using a visible sensor. And what I mean by georeferenced is you just connect a point in the image to a point in the ground. So that's what we georeferenced in a crude way. And typically we do this by using, like humans do this with a stereopsis. We have two eyes. We see objects from two different perspectives to get a real world a point mapping on our brain. But with the drone, since it's keep on flying, we can get a picture of the same target at two different points, right? So this is a typical a flying pattern. So we launch the drone here. It takes this scanning kind of an approach, like a raster scanning kind of an approach, and then finishes its flight and comes back to where we launched. And every red dot that you see here is a point where an image is captured. So you have two different views of the same target by which we can do stereopsis or we can apply photogrammetry techniques. As you can see, like this part of the image, there is a board. And as the drone moves, it collects a different perspective of that board. So here you can see the backside of the board. Here you can see more of a top view of the board. So we can use these two images on computers to get the photogrammetry. And what we need to do is we need to identify key points on both the images and use them as a type point to do the estimation. Along with the points, we know the information about at what altitude this imagery was collected, what was the longitude, what was the longitude, and the GPS location and all that. All this information can increase the accuracy of the measurement that we do using photogrammetry. So here is an example of two images. We know that these 2 points are the same, but we have this information here. That information is missing here. So by using this, we can do a 3D estimation of things on the ground. And we can do this in two ways. One is without any camera parameters known, without any IMU information. It's useful for like very simple applications. If we need to go for like a precision application, we need to know the information about the camera and possibly in some cases a ground target point. As you can see, the advertisement board estimated as a 3D model by using a photogrammetry, and this is how it looks on once the photogrammetry is done. So we are seeing this at a 30-degree angle. Although it's an aerial imagery, the photogrammetry allows us to construct a full 3D mapping. And getting a DEM and DSM, like an elevation model and surface model, are really important because if we are doing a forest survey, we need to know what height the tree is. One of the projects that we undertook was to study the effect of dead trees on power lines. So there is this 40 feet dead tree that's about to fall on the nearby power line. We need to predict that, or we need to anticipate that like months ago to make sure that we don't get power interruption. So we fly over high voltage power lines and we estimate the health of the tree by using the NIR band. And then we will say, okay, this tree has a potential of falling down like in 2 months. Let's just go there and cut it so that we won't have any power interruption. So we took one such a project where DEM and DSM is very important because we need to know if the tree is taller than a power line, because most of these terrains are not very difficult to access. Like in person, you cannot go there because it's like dense forest. There is a lot of mud and things like that. And in several situations, there is like a wildlife out there. So estimating an effective DEM and DSM is very important. So these are the softwares that we use to create the DEM, DSMs from the drone, maybe relevant for this talk. And this is the software. As you can see, the blue patches that you see in the image, these are the different perspectives by which the drone took picture, because the drone don't look at the ground the same position. because of the wind and everything, there may be a drift, and each blue square tells you at what angle the image is being captured. So this helps the photogrammetry. So for each image, we have a longitude, latitude, altitude, and then the error estimate, yaw, pitch, and roll of the drone. And so this is again talking about DEM and DSM. Like, because of time, I'm kind of just skipping through the slides. And this is a Pearl River Delta that I showed at the beginning of the presentation. I'll just skip these slides because of lack of time. We are already like 30 minutes. So this is the DEM estimated. As you can see, the ridges on the ground. This is the actual imagery. This is the image that I showed at the beginning of the slide, beginning of the presentation. And the sources of error in collecting the data, the GPS that we use on the drone, it's not very expensive. It can only connect to 5 satellites at a time. So the exact location accuracy may not be as good as a satellite one. So we need to do a lot of pre-processing to get that established. And then the IMU cannot be a larger unit because these are specifically made for drones. So there will be some inaccuracies. And we have the issues of blurred imagery and oblique imagery based on the situations and the focus on the camera. Usually the camera is focused to infinity. So even then we have seen blurred images due to shake and things like that. And low spatial resolution is usually not an issue with most of the drones that we use, but they are an issue with the gas-powered drones like the petrol engines. They fly at a slightly higher altitude. We don't have. And then the featureless terrain is a source of error. Like, for example, if you're flying over the water, you don't have any key points to tie. And if you're flying over an agricultural field where it looks kind of flat, there is no unique feature to tie them around. Getting a stitching may be difficult. On windy days, the vegetation can kind of swing and move around. So that will cause a lot of errors. And most of the sensors that we use has a global shutter. So what I mean by global shutter is if you have 5 sensors, the 5 bands are collected at the same instant. But in some cameras, it's a rolling shutter. The one sensor closes, the other sensor opens. So in that case, we'll have a shift in the bands that we've collected. That's something that we need to account for in post-processing. Yeah. Thank you. Yeah, that's my presentation.
Thank you, Dr. Samiyarappan, for introducing us on the photogrammetry process and your research projects. I would like to invite participants to ask questions from Dr. Samiyarappan. Please. Yeah, so I have one question. So
Sure.
this using the LiDAR, what is the resolution of the data points that you were getting, and which LiDAR was used for this geodesic mapping?
So we use the small Velodyne LiDAR that's used on autonomous vehicles.
From which height? Like the 3D LiDAR mounted on the aerial robot unit?
Yes, it's there is this company called Velodyne that
Yes,
makes
yes.
this for drones and autonomous cars. That's the one we use. It's not the one you typically see on like a manned platform, like a heavy one that can capture like several million points. and then the viewing angle of this lidar is very limited to a very small area because of the
Yes.
availability of battery and power on the drone. It's a very small lidar. At the same time, it's not as small as the one that you've seen in the small robots. It can put out like 10, 15 points just to estimate the distance, and this can get like several thousand points.
Is it an effort towards like 3D reconstruction of like whole area? Even we can in future like have a 3D reconstruction of whole Earth, like something like that.
So we already do have a 3D reconstruction, like a high resolution lidar for most countries that are
Okay.
either collected from a manned aircraft. But what the resolution of those kind of image products are kind of really low for some precision applications, and by using drone we can get a localized high resolution surface and terrain information.
And just one more question: what, how the post processing is done? So once you have those image data or RP data, the post processing is done. How the post processing of those data, because those are some data must be like having must occupy a large memory size. In
Yes.
2D it might be. So the post processing is done on which platform?
So once we collect, once the drone lands, we take out the SD card and put it on like commercial softwares, like I showed, a Pix 4D, Photoscan Pro kind of softwares that can do photogrammetry. And then there is something called Open Drone Tools. It's an open source tool. We don't use that often, but that's another thing that we can use. And with the lidar, what lidar does is it gives a multiple points of return. For example, if there is a tree, it gives a return on the surface of the tree, and then lidar can penetrate. The last return will be from the ground. So you will have like bunch of points. What to estimate the surface, we have a lidar processing software that was supplied by the company that manufactured this lidar. Once you put the data in there, and then you can set, okay, I need 5 returns. I need the last return. I need the surface return. It kind of gives you different products that you can save as a like a GeoTIFF file on your computer.
Okay, thank you so much. Actually, I forgot to notice on the time we exceeded like I think 5-6 minutes more. Sorry, Dr. Manuel, who is the next speaker. Thank you so much, Dr. Samirappan, for your presentation. Let me introduce our next speaker. So our next speaker is Manuel Vega Heredia. He obtained his PhD in engineering science with a specialty in robotics at UACG, Mexico. He worked as a postdoctoral research fellow in SUTD, Singapore University of Technology and Design, from 2018 to 2020. Most of the platform which you have noticed it in my presentation, I have used a glass facade cleaning robot. It was his team effort, led by him. He is currently a fellow research professor at UADO in Mexico. His research area of are reconfigurable robotics, SLAM, machine learning, and biotechnology. So a warm welcome to Dr. Manuel. Please continue the presentation. Thank you.
I thank you so much, my friend. Hello, everybody. Good morning for some of you and me, and good evening for you. Uh, like Dr. Amir say, I'm Manuel Vega. I was working in SUTD. I'm still working with them. I'm from Mexico, and I want to present you some of the work that I'm making right now. Are you seeing my presentation? Hello?
We can see, yes, we can see your presentation, and now it's full screen as well. Please go ahead.
Okay, perfect. So, okay, the presentation basically is about the robotic applications in hygiene and health. Right now, we are living very special time because we have this pandemic, these problems, and definitely the world is changing in many ways. So, like an introduction, I want to speak about the motivation for these kind of platforms about cleaning, about sanitization, about health, etc. Uh, Many people here, like me, we are from some countries that don't have many resources, right? So we need to found very good solutions with these resources that we can receive. So one of the most important things here is how much is the capability of the people to access to the technology, to access to the robotics, and what we can make to increase this. So the robots market right now, if you can see in the first plot is China is the leader in the installation of industrial robots. My country, Mexico, is just 5.7 thousand of units per year. India is here in the red one, 4.8. Singapore is 4.3. We need to consider the population, obviously, and the size of the country. If you see, even United States don't have many industrial robots like China, but it's because obviously the industry in United States is outside, right? But in the robot density in the manufacturing industry, actually, I observed that my country is not there. The leader is Singapore. Then is Korea, and etc. etc. So many countries here uh, are not in this plot specifically, and the market is increasing. So right now we have basically, from my point of view, two options. We can take this like a crisis, or we can take this like an opportunity. So to solve one of these problems, I work in reconfigurable robots. I was working with Dr. Mohan under him in SUTD, and we work more in adaptive robots. The adaptability is one of the greatest solutions from my point of view, because adaptability help you to don't use many platforms. They give you flexibility, and flexibility help us to save money and help us to have many applications for the same platform. So like I told you, this can be a crisis or can be an opportunity. If you see the prices of the robots, for example, for the sanitization, disinfection, etc., is 26,000, 25,000, 18,000, 19,000. So our goal is to reach around at least the half of this price, or even just the 10% of this price. I'm focusing in countries like my country that need technology for everyone. Actually, this is the slogan, like you can see in the top of the presentation. Well, I want to speak about my work in SUTD, like Dr. Amir say, is window cleaning robots. We start with that, and we get many versions, 4 versions actually, 5. But the tendency was to go for the smallest one. Reduce the size, reduce the price, reduce the weight, reduce the consumption, because actually all the technologies are going in that way. This robot have the capability to be nearly holonomic, nearly omnidirectional, and it can shift from one window panel to the other, detecting the frame, and right now have many systems to detect how strong is the attachment to the window, All this is developed by the Roar Lab team. Is one of the greatest team that I know in my life. At the same time, from this robot, we get the wall cleaning robot. This wall cleaning robot basically is obviously to clean the walls using water or using many liquids, and have exactly the same technology than the previous one. So the idea here is from one platform we can get another and another, but just changing some small specifications. Then we can apply for different applications. Then the control was based in the distance between the modules, and from there we can get the position of each module and the orientation. Like you can see in YJI, here we can get the speed of the each wheel based in the characteristics of the motor gear and the radio of the wheels. From there we get the linear velocity and the omega, the angular velocity, and the control is performed by using this linear velocity and omega. Now, from the same thing, we get marine applications. Dr. Mohan founds a company with some good friends there, and they are using for paint stripping, surface analysis, and etc. etc. Then we get some pipe inspection. All these are vertical robots. They can attach for many kind of surfaces. This one is for metallic surfaces, and we get even different sizes. My point explaining this thing is the opportunities are huge. The robotics have each time, each day, more and more applications, and no need to be very expensive to be successful. In airplane cleaning and inspection, this one is attached by using EDF. So the turbine in the IMU detects the orientation of the robot, and this one accelerate and attach to the different surfaces, like you can see in the different circles. Now, what are the opportunities areas I want to show right now, like examples? One is the sanitization. The other is the reconfigurable cleaning robots. And the other is prosthetic and orthotic devices, low cost. The last one is some people came to us and proposes this to solve this problem, because many people, at least here in Mexico, when they have accidents, they need to change the prosthetic limb, or the prosthetic extremity. Can be arm, can be hand, can be feet, I don't know, anything. So it's very expensive, because you need to go with some special specialist, and they need to make customize the size specifically for you and your problem. I will explain a little bit more in the next slides. So I want to introduce you the sanitizer robots. These robots for sanitization is very similar to all the robots, like you can see. Have the bumpers, the lidar, the UV, the ultrasonic sensors. This one we are developing right now, and is right now under construction, but obviously for the pandemic is a little bit difficult. So it will take a little bit of time. This one is using UV. You can see the ring in the top, and even we are using UV light below the robot, pointing directly to the floor, and at the same time we are using steam. This steam is coming out around 150 degrees. The idea is sterilize the surface when the robot is passing through this. And obviously have the vacuum, the scrub, the brusher there to remove all the dust. In this one, our goal is to reduce the price of the robot to 150 USD. This is amazing because normally, like you see in the previous one slides, was 25,000, 19,000. So $150 is super cheap, very, very cheap. The idea is everybody can have access for this. Normally, the most expensive thing is R&D. Our goal is reach around 700 USD. But I'm showing you this one because we want to mix with another robot. The idea is to, well, sorry. The architecture of the robot is, like you can see, we are using ROS, like Apurup say in the previous presentations. He said that ROS is a very good tool for the robotics because it's open source, and we try to use only open source software. In that way, we don't need to spend money in that. Actually, the technology, we want to make it open, and it's a differential robot, so the control is very simple. We just controlling obviously two wheels and the position of the robot bases. Right now, we are using only zigzag. One of the let's say challenge here is the speed of the robot, and I want to explain why. When we are using UV, the light need to be on the surface depending on the intensity, minimal 6 seconds. So the robot cannot go faster than that. And if go slower than that, we can eventually burn the surfaces because UV affects all the surfaces, more the plastics. Everything, it will receive some damage using UV. That's why we want to use the steam too, because the steam normally don't damage the surfaces. Obviously, depends in the temperature, and we want to reach 100 degrees, but even with 70 degrees, we can kill near to the 80% of the bacteria and virus on any surface. So 100 degrees is for sterilization. The normal temperature that we want to use is 150. And the good news in this is this robot is using 12 volts in all the devices. So one of the challenges is mix everything, UV, steam, and vacuum, because we need to have a balance between the efficiency in the energy and the water. If we go too slow, the water to make the steam, it will finish too fast. So the people will need to go and reload again the water. So there will be no sense to use a robot because the people will need to be there continuously filling the water. So the idea is to efficientize all these resources at the same time. So that is the challenge right now. The speed, it will be based more in the UV and the steam. Now, I want to introduce you the autonomous reconfigurable floor cleaning robot, or RFCRO is the name. This is a reconfigurable robot for clean the the surfaces like the floor. This one is using n number of linear actuators, like you can see in the figure in the right side of your screen. These are the combinations of configurations using these kind of linear actuators. In each extremity, like linear actuator, is using a pipe. This pipe is connected to the vacuum. So basically, the robot is using the vacuum in each extremity. In that way, when the robot is changing the configuration, automatically the extremity is in the edge of the robot. So then the robot can clean a very very small and accurate areas. This one is omnidirectional, is using omni wheels. You can see the circuit and the components in the right side and in the bottom. So when we select the configuration, the robot automatically adjusts to that based in the free area or the area without obstacles. Our goal price in this one is 350, and R&D need to be around 600. This is a very very big challenge because linear actuators are very expensive, and that the idea is combine the previous robot with this one. Actually, if you can see in the top have a ring. The ring is the UV light. Okay, our F2 adaptive algorithm is based in the free area. Like you can see in the figure in the left side, there is a small free area. In the distance, the free distance between the obstacles is everything that can stop the movement of the robot. Is very very small, and obviously is smaller than the dimensions of the robot. So using the leader, we can detect these areas, and based in the D, the distance between the obstacles, we can select the configuration like you can see in the figure B. Then the robot select the configuration. In this case was rectangle. So reduce the size and can go inside of that free area. How we can make it this? Basically, we use the orientation of the robot. If the robot is moving front, we are just using the readings from the sensor, who is SR, from 1 to n number of readings. We have a window of 90 degrees in the front of the robot. We are only using 90 degrees for every place where the robot is moving. Saying in another way, if the robot is moving from, we are using from 45 degrees to 135 degrees only. If the robot is moving to the right side, we can use from 45 degrees to minus 45 degrees. So this number of readings is always the same, but the range is changing. And we filter all the readings from minus 1 meter, and if it's more than 1 meter, we are not using. That means the robot is reconfiguring only from 1 meter. We are using DJ to define the speed of the wheels and linear velocity using 4 wheels and omega in the same way, knowing that these one are omni wheel. Now, this one is the adapted prosthetic limb. This adapted prosthetic limb, like I told you in the previous slides, one person from a rehabilitation center here came to us and presented this problem. And one of the motivations for me and for the people who is working with me was that we see people in wheelchair making wheelchairs for people who need wheelchair. I will explain again. Sorry, the people who cannot walk because they are in the wheelchair, they fabricate the wheelchairs for people who need wheelchairs. For me was very amazing, and I asked why, and they say nobody can understand better the problem than us. And it's true. And one of the problems that they tell us was normally the prosthetic limb or orthesis need to change the size because sometimes the people grow, sometimes the people decrease the size. When you become old, sometimes the size of your body is reduced. So the prosthetic limb need to be adjusted each time. And in most of the cases, the people need to make one prosthetic limb and then after 6 months, another one because the size change. And then 1 year after that, another prosthetic limb because the size change again. So our idea is to use the same prosthetic limb always. That means the limb will grow with the person. I will repeat. This prosthetic limb is growing at the same time that the person grow. How? Basically, is based on the weight of the person and the posture of the person. In the right side, you can see a T, inverted T, on the hip of the person and the spine and the prosthetic limb. This one have an IMU, actually two IMUs, one IMU on the top and one IMU on the hip. At the same time, we have weight sensors on the feet. You can see the wires coming out from the feet. So when we sense the weight, in theory, both legs need to carry the same weight. That means if the person's weight is 100 kg, each limb need to carry 50 kg when the person is completely straight. But one of the problems that we observed in these patients is because they don't have a good posture. Finally, the spine get damaged, the body, the full body get damaged, so they cannot be straight. In the sense that if they stand up, normally they cannot be completely straight. They have some problems to maintain the posture. So obviously this prosthetic limb is for persons who have problems. It's not for healthy people. So the prosthetic limb need to adapt even to that problem. How we can reach that? Well, first of all, we get an anthropometric measurements. We make these measurements from the leg, and we consider the height of the person and the weight. But finally, we took 350 measurements from people from 18 years to 55 years old. we are trying to get another 150 to reach 500 measurements. Like I told you, right now is 350, and from there we get the range. That means the prosthetic limb can grow around 20 centimeters, because that is the range in the anthropometric measurements of the people. So all these measurements, for example, like from fibula to the based hamstring, or from the hamstring to the ground, or from the rectus femoris lower part to the floor, and in that way. So how is working right now? Right now, we are using the weight of the person. The weight is considered in all the body. Let's say this is the back of the person, and if the people is completely straight, the weight will be equal in both legs. If the people is not straight, obviously the weight will be unbalanced. So one of the variables that we are using to make it grow the limb is the weight, and the other one is the posture. How we are doing that? We use two IMUs, like I told you, one in the hip and one in the upper part of the spine. And we are sending the weight of the person in calculating how is the result or the resultant moment for each leg. That means the weight is moving from the center of the hip maybe to the right side. That means the right side is receiving more weight. If the people have some inclination to the right side, that means the limb cannot be higher than the other one, because then it will be more unbalanced. The problem in this is if we fail, we can increase the disability of this person. So the idea is slowly even correct the spine if it's possible, obviously, because then the limb, it will adapt each day the length to maintain the people in the best posture. So we are taking the Y component. That's why we are using sino of phi, and the force basically is coming from the weight. So if we multiply the cosine of t, t is one of the angles even from the T bar in the hip, considering that the weight is completely vertical and is going straight down. We just take the half of the hip. Why half of the hip? Because if you see, we take many measurements here. One of the measurements is the hip distance. Each of us, we have different hip dimensions. So the idea is to place this device exactly in the center. So from the center, we will estimate the deviation of the weight to each leg, and then we can know exactly in which of the legs is receiving more weight. We know that both legs will receive some weight, but finally the weight need to be balanced to don't stress too much the other leg. So in conclusion, the adaptability is one of the solutions to decrease the number of sellings or from the people to buy many devices. because one of the devices can solve this problem. That's why I show you this last one about the prosthetic limb, because when you use this adaptive prosthetic limb, the people only need to use once, and automatically the limb will adapt. And the previous robot, the RF Pro, this one you don't need a big robot than a small robot, because this one can adapt there. So I think this will be not a crisis. This will be an opportunity for us to develop new solutions for the new problems and for the previous problems. Thank you so much. Thank you to SUTD for giving me the opportunity to work with them, and Prof. Mohan and Raw Lab team, everybody. Thank you to UADO for receiving me like a professor. And again, thank you for Raw Lab. It's a very amazing team. These people is applying many technologies to solve real problems. We not only develop technology just to have more knowledge, is more to solve real problems. If somebody have any question, please feel free to ask. Yeah, adaptive limb. Adaptive limb is very interesting. Have you used simulation modeling? Okay. Right now, the simulation that we are using is numerical. We are not using the normal simulators and that. So for this, we are using just C++, and there we are getting the plots. So to plot, we are using GenuPlot. GenuPlot is one of the tools. The other one I don't remember, but it's GenuPlot, the most one that we are using. Kumar Duraraj. So this one is basically we are checking the results to be sure then the limb can work or not. We don't want, yeah, it's open source. It's open source software. Obviously, C++ is completely open source. We are working with ROS. ROS is working with C++, and GenuPlot is open source too, fully. I don't like to use too much like MATLAB and that, because you need to pay, and sometimes here we don't have the resources. So we are going always for open source there. Oh, my university name in English, Autonomous University of the West. Yeah, but I think if you put the name of the university in Spanish, sorry, in English, it will not appear. Need to be Universidad Autónoma de Occidente. In English, can be Universidad Autónoma de Occidente. Sure. I can answer. Sorry, another question. Thank you, Dr. Kartik. How is the scope for using hygiene robots in industry at low cost? Has hygiene is necessary in this pandemic? Yeah, okay. Well, one of the scopes that we are looking for is trying to cover the most of the surfaces, like I show you in the fourth slide. I don't know if everybody is seeing right now. These robots, most of these robots are from China, and they are using many UV lights. The only point in this, Dr. Kartik, is we will not use many likes, and these likes are not very expensive. So it will take more time, but finally the job will be done. That is the point. That's why we mix UV with steam, because in that way the floor will be clean, and with the top UV light, we need to spend more time to get the sanitization, but it will be done eventually. Okay, sorry. Thank you, Dr. Kartik. Nice to see you. Eh, oh, thank you. Good question. Like you see, Prof. Christy Dean, in the third slide, I show the number of robots that Mexico is using. At least it's in the list. Mexico is using some robots for the industry, but in the malls, in the houses, and in all that places, basically no. Mexico is not using robots. When I lived in Singapore, I saw them in the malls. There are many robots. Actually, I saw Leobot in the airport and in another malls. But when you arrive here to Mexico, it's very difficult. Why? Because the salary of the people is much, much, much less, and I think you can feel identify with me in the people in another countries. I will not say the country, but mm, finally we want the same technology, but not all the people can pay the same technology. So, short answer, for COVID, they are using some sanitization robots, but it's just in very big industries. And some of these ones is just spraying like chloro or alcohol or uh, ozone. I think so. I don't remember all the things. The lockdown here is not strict, not anymore. We are using a transit light. They call the transit light. My state is in red light. We need to be in lockdown. But the 75% of the states in Mexico are in yellow, and one state I think is in green. That means they are almost free of COVID. Here the people is dying, many people each day, but it's not in the news. Only in the local news, actually. Another question? Well, thank you so much. Thank you for hearing me. I hope this information was good for you, and I will be very happy to continue working with all of you. And thank you for the opportunity, Dr. Morham, Priest University, Vice Chancellor, and thank you, Dr. Hayat, for that good introduction.
Thank you, Manuel. Like it's always a pleasure listening to your presentation, and you can carry on and on and on, and we can listen you. We need a special whole day session to with Dr. Manuel to know his research, wide range of research that he carries. Now it's time for Dr. Ashutosh Das to uh, wind up the sessions by his addressing note. And Ashutosh Das, are you here? Dr. Ashutosh?
Thank you very much.
Yeah, please.
It was a very wonderful day with so many informative and eye-opening sessions covering various aspects and applications of robotics, covering a range of robots from cleaning, domestic house to cleaning the sewers, and healthcare, covering wheelchairs, exoskeletons, and hygienes, and spatial mapping of the brains and even terrains, and even motivational robots like pet robots for the elderly. This session today was also thrown the lights on the ideation, the creativity through bio-inspiration, and what are the different steps, the scopes for patentability. And besides that, there have been multifunctional autonomous robots and the basic design and modeling approaches using AI and CFD. Even the commercialization processes and experiences. This was a very enriching experience. The several modeling platforms and open softwares are also presented in a way that anybody is interested, because you have some people who are also robo enthusiasts interested. They get a very clear directions where they should go for and what are the things they need to master to enter into the field. It is not a very scary field. At the same time, it's not a very easy field unless somebody prepares oneself. So it gives a very wide scope for people to enter into the field and at least know what they are supposed to do. So I am very sure that those who have attended the whole day, they would have really enriched themselves with all this information about every aspect from ideation up to commercializations. At the same time, this also provides opportunity for those who are already experienced in this field and professionals to see the different scopes and opportunities where they can share the knowledge, they can collaborate themselves, so that it can be a more fruitful experiences for others. Because in this present age, especially when pandemic COVID has spread all over the world, so there is hardly any scope where people can practically go and do the things. And at that time, robot technology seems to be the only source where anything can be accomplished. So it is a very inspiring experiences. So I thank all the speakers, and it is very amazing that all through the day there are more than 120 personal participants. That actually hardly anybody is going in and going out from this. It is such a great patience required to attend whole day, no break. So it is amazing. Where hats off to all the participants. I never had the experience of any day-long seminars, webinars like this where people are attending all through. No disturbance, no distractions. It is really amazing experience. I thank all the organizers at SUDS for providing their immense supports and making such an exemplary experience for all of us. And I am sure for all these participants too. Thank you very much.
Thank you all. So we come to an end of today's session. And don't miss the tomorrow session as well. Thank you so much. The meeting is ended now.
Just 1 minute. The feedback forms are available, so those who have not submitted, they may please submit that, because e-certificate will be issued based on that. Thank you.
They are asking for e-certificate link. So the link is already given in the okay.